be the greatest, you can be the best. You can be the King Kong banging on your chest.
You can beat the world, you can beat the war. You can talk to God, go banging on his door.
You can throw your hands up, you can beat the clock. You can move a mountain, you can break rocks.
You can be a master, don't wait for luck. Dedicate yourself and you gon' find yourself
Standing in the Hall of Fame.
Yeah,
And the world's gonna know your name.
yeah,
'Cause you burn with the burst flame.
yeah.
And the world's gonna know your name. And you'll be on the walls of the Hall of Fame. You can go the distance, you can run the mile. You can walk straight through hell with a smile.
You could be the hero, you can get the gold. Breaking all the records they thought never could be broke.
Yeah, do it for your people, do it for your pride. Are you ever gonna know if you never even try?
Do it for your country, do it for your name. Cause there's gonna be a day when you're
Standing in the Hall of Fame. And the world's gonna know your name. 'Cause you burn with the burst flame. And the world's gonna know your name. And you'll be on the walls of the Hall of Fame. Be a champion. Be a champion. Be a champion. Be a champion. Walls of the Hall of Fame. Be students, be teachers, be politicians, be preachers. Yeah. Be believers, be leaders, be astronauts, be champions, be truth seekers. Be students, be teachers, be politicians, be preachers. Yeah. Be believers, be leaders, be astronauts, be champions. Standing in the Hall of Fame. And the world's gonna know your name. 'Cause you burn with the burst flame. And the world's gonna know your name. And you'll be on the walls of the Hall of Fame. Be the greatest, you can be the best. You can be the King Kong banging on your chest.
You can be a hero, you can beat the world. You can talk to God, go banging on his door.
You can throw your hands up, you can beat the clock. You can move a mountain, you can break rocks.
You can be a master, don't wait for luck. Dedicate yourself and you
If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker, and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
Hola, Zamboanga. When traveling to Zamboanga City for business or leisure, please be ready with the following. Hotel booking. Stay safe QR code. COVID-19 vaccination card. And your 5-day itinerary. Visit the tourism office in case you need assistance while in Zamboanga City, or message them at Turismo Local de Zamboanga Facebook account. Make your travel to Zamboanga a memorable one. Stay safe!
buscar aquí en la Zamboanga, mga balay, kultura y sabroso comida. Di makaolvida como ya ton historia, vida mucho colores como de la aton pinta. Ustedes en música, qué alegría te da llevar. Ue, 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 aguantahan kita todo mano. Ue, 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 que todo kita kiman hermano. Mas talagayaan aquí na Zamboanga, todo mga gente sige baila canta. Mas talagayaan aquí na Zamboanga, todo mga gente sige baila canta. Kinan vale Zamboanga, sa pagduda esperar. Venia, venia, mas talagayaan na Zamboanga celebrar. Venia,
Nos alegra la Zamboanga, uy tú mi amigo. Música palanqueta ya de tu favorito. Vamos de el cacho desperta na maga dormido. Sudor de la alegría tapusa para bonito. Junto, junto, salta alto. Hula kita con alegría del pájaro.
Muslim man o cristiano,
Manos llena de alegría está para cuando necesita quita todo el amor. Para pirmi alegre cada ta subir al sol. Acorda quita amoga desde el pavor. La vida del viviente es para más tiene valor.
ue, 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 aguantahan kita todo mano. Ue, 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 que todo kita kiman hermano. Más alegría aquí na Zamboanga, todo el mga gente sige baila canta. Más alegría aquí na Zamboanga, todo el mga gente sige baila canta. Quieren bailar en Zamboanga, que se puede esperar. Ven ya, ven ya. Más alegría aquí na Zamboanga celebrar. Ven ya, ven ya. Quieren bailar en Zamboanga, que se puede esperar. Ven ya, ven ya. Más alegría aquí na Zamboanga celebrar. Ven ya. Quieren bailar en Zamboanga, que se puede esperar. Ven ya, ven ya. Más alegre aún en Zamboanga celebrar. Ven ya, ven ya. Quieren bailar en Zamboanga, que se puede esperar. Ven ya, ven ya. Más alegre aún en Zamboanga celebrar. Ven ya, ven ya. Quieren bailar en Zamboanga, que se puede esperar. Ven ya, ven ya. Más alegre aún en Zamboanga celebrar. Ven ya.
Like to love, see the sun looking down from below. Hear the call, rising up, setting fire to my soul. We don't know where we are, but it don't matter in the wild. Here we go, making moves, ready or not tonight. Like a bullet, speeding high, I'll be your ride or die. Let's do it. Oh, you know, you know, you know, you know I'm up for anything. Up for anything. Up for anything. Never stop, make it last. Raise up our hands all night. Go where we want, rushing past all of the no's and why's. We can do it all. All the feels that feel so right. Look at me, looking at you, and we know we'll be fine. Like a bullet, speeding high. I'll be your ride or die. Let's do it. Oh, you know, you know, you know, you know I'm up for anything. Up for anything. Up for anything. Oh, the world's our playground. We're the kids forever young. Running free, oh come on. You know we'll stay forever young. See the magic go round. Let the feeling take you now. We're always down to go so much higher.
Check, check, check. Hello, check, check, check.
Walang.
Hello, check, check. Okay na, meron naman. Hello, check, 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 check. Hello, check, check.
Hindi ako naka-headset.
Hello, check, check, check. Sound check. Check, check, sound check. Sound check, check. Hello, check, check. Jay, okay na, Jay? SJ?
Hello, hello. Okay na, Oli. Hello.
Naka-open na ba?
Hello, hello.
Hello, check. Jay?
Hello, hello, hello.
Hindi
Yes.
naririnig.
Test?
Papunta sa atin.
Hello, check.
Hello.
Ay, sasalita siya sa... Hindi marinig.
Hello.
Mm.
Hello.
Check, check.
Hello.
Hello, check.
Hello.
Oh, yung pabalik sa atin, wala. GS3, GS3.
Hello. Hello.
Hello. Test mic?
Hello,
Good
test.
morning.
Ay, wala. Hindi narinig. Kami sa Zoom. Oh, wala pa. Hindi, I mean, dito sa inyo, di marinig.
Hello, check. Jay?
Hello, hello.
Yan.
Test? Hello.
Yun yun. Asan yung kabi ko? Nandito naman na. No, ito. Yung popular. Ito ba yun?
Check, check, check.
Hello.
Hello?
Ay, wala. Wala. Wala din. Ay, sound, wala. Ay, nawala yung sound ko sa'yo. Yan, may sounds ako eh. Oh, sa Zoom natunog yan. Hindi sa... Yan. Ayan. Wala. Pero sa Zoom meron ako. Yung music, wala. Ayun na, meron yun eh. Kung yung sound. Ano yun? Kasi meron dyan kasi sa akin. Ay, yan. Nandun sa Zoom, meron yun. Wala. May RPA ba yan? May RPA. Meron. Okay, sir. Ano, grounded? Thank you, sir. Wala dito. Ayun, ayun. Wala dyan dito. Wala. Ito. Sundo meron naman. Dito lang sa in-house. Oo, dito lang.
Ito daw dito ang itlog, sir. Ito daw ito dito. Mayroon.
Grounded. Grounded. Tinanggal ko na to ah. Grounded siya. Tanggalin mo nga yung ano. May mic na naka-open. Yung RCA, yan yung RCA.
Check. Check. Jay, salta nga, Jay.
Check. Hello, hello.
Wala?
Check.
Galing sa labas, wala dito, papunta sa atin. Oo, yung sounds, nawala yung sounds. Na ano?
Hello, check.
Yun, meron tayo eh. Meron tayo. Wala, kahit sounds, wala eh. Kahit sounds, wala. Sir.
Oli, narinig ka namin, Oli.
Jay?
Hello, test.
Yan,
Test.
okay na.
Ano nangyari?
Okay na, Oli. Okay na.
Hello.
Hello, check. Jay?
Hello, hello. Yan, hello.
Hello. Yan.
Hello. Rinig mo na ako?
Oo, narinig na. 5 minutes countdown tayo, Jay.
Sige, go na.
Ay,
Start webinar na tayo.
Pasok muna tayo.
Start webinar. Sige, sige.
Looping ka, pre.
Welcome. Before we begin our meeting, please be informed of the following video conferencing etiquette. Number 1. If using a laptop, tablet, or mobile phone, make sure that your battery is fully charged to avoid sudden disconnection. Number 2. To be the best, you have to look the best by observing and wearing appropriate attire fit for the meeting. Number 3. Be on mute at all times and listen attentively to whoever is speaking. Number 4. Maximize the use of chat box and other tools made available by the system whenever you want your voice to be heard. Number 5. Avoid interrupting the speaker, and make sure that you are acknowledged before you speak. Number 6. As much as possible, turn on your video so that we could have a wonderful conversation. Number 7. We encourage you to station yourselves at a place free of destructive noise so that you could focus on the meeting. And lastly, number 8. We want to capture the moment with you. Kindly stay until the end as we will have a group photo after. Thank you. And have a good day ahead.
requesting everyone to please find their seats and settle down as we will begin the program in 5 minutes. Once again, requesting everyone to please find their seats and settle down as we will begin the program in 5 minutes.
We, members of the Institute of Integrated Electrical Engineers of the Philippines Incorporated, in recognition of the constant involvement of technology, in uplifting the quality of life, and in accepting a personal obligation and dedication to our profession, its members, and the communities we serve, do hereby pledge and commit ourselves to the highest ethical and professional conduct, and agree to accept responsibility in making sound engineering decisions consistent with the safety, health, and welfare of the public, and to disclose promptly the factors that might endanger lives and the environment. Avoid real or perceived conflict of interest, or disclose existence of such to affected parties. Be honest, objective, impartial and realistic in stating claims or estimates based on available facts. Avoid at all cost graft and corruption in all its forms. Improve the ethical understanding of technology and its appropriate application. Continuously improve practitioners' technical competence. Disclose full pertinent professional and technical limitations. Seek, accept, and offer constructive criticism of technical work, acknowledge and mitigate errors, and give credit where it is due. Equally treat all persons regardless of race, gender, physical condition, age, or national origin. Protect and avoid injury to others' life, property, reputation, or livelihood by false or malicious actions. Observe utmost transparency, responsibility, due diligence and fairness, and accordingly, not manufacture, spread, or disseminate false, incorrect, unverified or misleading information or data against any co-member, or the IAE, its officers, employees and representatives or agents, in any form whatsoever, whether verbally, in writing or published or whether through electronic means or otherwise, especially if such tends to discredit, besmirch the honor or integrity or impute a wrongdoing on the part of a co-member of the IAE, its officers, employees and representatives or agents. Support colleagues and co-workers in their professional and technical development, and assist them in complying with this code of ethics. timely and fully comply and abide with any and all of his obligations to a co-member of the IAE itself or any third party. Does not engage in or commit anti-competitive, fraudulent, and deceitful practices in any form, and uphold free and fair competition.
Buenos dias!
Maayong buntag!
Assalamualaikum!
Magandang umaga!
Good morning, ladies and gentlemen. Welcome to the third day of the 9th Western Mindanao Regional Conference. I am Louis Angelo and Ebol,
And I am EJT Perez,
your Masters of Ceremony. Finally, this is the last day of the 9th Western Mindanao Regional Conference. And grabe partner, makikita mo pa rin na ang dami pa rin participants. Ayan. And doon mo malalaman na interested sila na matuto sa ating mga guest speakers for today.
Yes, partner, up until now, I cannot believe that we are on our last day already. It is such a great honor and a privilege to be part of this event.
Yes, indeed, partner. But you know what? I am so curious kung ano naman ang mga baon ng ating mga guest speakers for today. You know, this 3-day conference, parang ano siya, parang 3-course meal siya. Yung first day natin, webinar, parang yun yung appetizer natin. And then yung second day natin, which is yesterday, yun yung main course kasi winelcome natin yung mga delegates natin as well as we had a lot of mga technical seminars and technical product presentations. And today, hindi makukompleto yung 3-day conference natin without the dessert. Ito na yung dessert natin. This is our last day.
Yes, chill lang partner, kahit ako excited na rin. Wait lang tayo. Wala nang patumpik-tumpik pa. Let us have our first technical seminar on short circuit calculation in per unit method. Just a reminder for our guest speaker, you're given 1 hour for your presentation. If you heard the sound, you only have 10 minutes to wrap up your presentation. Our guest speaker is an electrical engineer, at Al Hati, Saudi Aramco. Let us all welcome Engineer Marlu C. Vargas.
Hello, good morning. Good morning, everyone. Naririnig po ba?
Yes, sir.
Okay, thank you very much for that introduction. And first of all, I'd like to thank Western Mindanao Region, IIE, for having me as part of your very prestigious event for today, and to be part of this is already an honor. Good morning again to all the participants in today's event, and I will begin with my presentation and discussion regarding regarding short circuit calculation. Can I be allowed to share my screen?
Yes, sir.
Okay. Is the presentation can be viewed now on your screen?
Yes, po, sir.
Okay, thank you very much. Okay, good morning again. Okay, we will be discussing short circuit calculation in per unit method using symmetrical components. This is this particular method of calculation is mostly used even with the power system softwares. They normally use per unit and using the symmetrical components. Okay, let us first understand what is short circuit. And what is short circuit? Okay, obviously it's an abnormal condition in an electrical circuit. And to be more specific on that, it's when an electrical circuit causes current to flow along an unintended path with a very low electrical impedance. So since it's having a very low electrical impedance, the resulting current would surely be very high in magnitude. Okay, so that is short circuit, and the illustration of the circuit here below, as you can see in this slide, okay, it shows here this red path as the short circuited path, and at this particular condition, a short circuit current happened, and the magnitude of that is very high. The short circuit current has, in short circuit calculation, we need to understand the characteristic of the short circuit current. Okay, as illustrated here in this figure, okay, you can see the normal current as the red sinusoidal wave as the normal current. And at the very onset of the fault, when a fault happened, it suddenly rises to a very high magnitude of peak current. It is because of the DC component that is present during the initial stages of the fault, the initial occurrence of the fault. Okay, we call that the first half to 1.5 cycle, we call this one as the momentary state. Okay, and after that, from 1.5 to 4 cycle, we call this as the interrupting state. Beyond that, when the DC component is decayed or already eliminated or it already decayed from the from its what you call it, because the DC component normally will eliminate by itself after some time. So at that point, we call this one as the steady state already. Okay. Here are the sources of short circuit current. Electric utility grid is one of the sources of short circuit current. The power generators, which also provide power and is also a source of short circuit current. The synchronous motors also provide or contributes to the short circuit current, and also even our load, the induction motor, also provide or provide or contribute to the short circuit current. So whenever we calculate short circuit calculation, all of these sources of short circuit current must be properly identified, so that we know that which circuit provides a contribution to the short circuit. Importance of short circuit calculation. Why short circuit calculation is required? Basically, in any design, in any electrical system, there is what we call there's what we call no fault proof system. It means that any electrical system, abnormal condition could surely happen, and causes of short circuit are given in this particular slides here, are some of the causes of short circuit causes of short circuit. So intrusion of foreign object is one of that. Failure of insulation due to aging or poor maintenance. Factors attributed to weather disturbances. Electrical surges accumulation of dirt and moisture, and equipment failure are all causes of short circuit. So it just means that there is no electrical system that a short circuit or abnormal condition could not happen. So thus, it really requires for us to determine or to perform short circuit calculation. Here are some reasons why we need to perform short circuit calculation. Why is it being required? To ensure that during design stage, abnormal conditions such as fault are considered. To ensure a good design that must be safe and reliable. Okay. To ensure proper selection of electrical component to withstand overload and fault conditions. Adequate protective devices are considered to protect both equipment and personnel. Okay, the application of short circuit calculation is also itemized here. These are just some. Okay, so proper sizing of electrical equipment for required mechanical strength to withstand the stresses as a result of high short circuit currents. The proper selection of circuit breaker, this is for the interrupting ratings. Okay, the proper selection of protective relays and fuse ratings required for relay settings and proper protection coordination. Short circuit calculation is also required for arc flash analysis. Okay, the assessment of overall system voltage profile as a result of varying magnitude of short circuit current is also very crucial to perform. Is also one of the application for short circuit calculation. Required in the design of substation grounding system. So short circuit calculation is one of the basis in designing substation grounding and in sizing and selection of neutral grounding. Required in determining the adequacy of interrupting capability of existing protective device. So this is like we are verifying the adequacy of the interrupting rating of already existing protective device or protective equipments. Compliance to regulation and as well codes and standards. So we go back to this particular illustration. Okay, we determined earlier that there are 3 stages of in the short circuit current. So first is the momentary state. Okay, this is the most common short circuit calculation wherein it has a very a lot of application that can be that this particular short circuit calculation is used. So at the first half 1.5 cycle, this is what we call the momentary state. And at this very condition, the 4 sources of short circuit current will have what we call subtransient impedance. Okay, so this subtransient impedance must be properly determined so that we can properly perform and get the accurate result for short circuit calculation. So common application of this particular short circuit calculation at momentary state, okay, is for HB and MB circuit breaker as shown here in the right side of the screen, for close and latch current rating, LV circuit breaker interrupting current rating, short circuit withstand rating of equipment, determine incident energy level for arc flash analysis, selection of instrument transformer, consideration for relay instantaneous strip function, and design of grounding system. The next state of doing short circuit calculation is at the interrupting state. Okay, this is after 1.5 to 4 cycles. And the common application of that is for HB and MB circuit breaker interrupting rating selection. Assess actual fault clearing time by the protective relay and circuit breaker for required coordination. And the last one, the last short circuit calculation is at 30 cycles. Okay, and this is the application for this is to assess the performance and coordination of time delay protective relays. Okay, the per unit system and common power base. This is as we go for the calculation, we need to do we need to convert the impedance values into a per unit value and at a common base. So this is how it's being done. So what is really per unit concept? Per unit system is a commonly used for power system analysis of an electrical network having two or more voltage levels. So this is the use of per unit system is very applicable for system that has two or more voltage level. Okay, in per unit system, the value of system quantities of any unit is expressed as a ratio of the actual value and the base value of the same unit. So the formula is simply like actual quantity over base quantity, that is your per unit quantity. Per unit system are expressed in reference to a base value, base quantity. So calculations in this way, the calculations are simplified because quantities are expressed as per unit and do not change when they are referred from one voltage level to the other. So commonly selected power base, or we are going to select a common power base. Mostly it's a 100 MVA or sometimes also 10 MVA. For simplicity, transformer voltage rating are selected as the voltage base. Both the primary and secondary voltage are selected as your voltage base. So here are some of the formula that we can show here. Per unit quantity, actual base over base value. Per unit impedance is actual impedance over the base impedance. Per unit ampere is actual ampere over base ampere. Per unit voltage is actual voltage over base voltage. MVA, we have some another formulas here. Okay, this is the MVA base, and then the I base, the impedance base. When we are going to determine, because this I base and current base or the impedance base are going to be determined using this formula. So Z per unit is actual, Z actual over Z base, and we have also here the conversion from when you have a impedance, all the impedance that is referred to a different base, and you're going to convert to a new base or your selected base, then this is the formula on the right side. Okay, we have here an example which we will also use during our during later part sample calculation. Okay, the selected power base here is 100 MVA, and the selected base is 13.8, and the secondary voltage is 0.48 kV, 0.48 kV or 480 volts. So using that calculation, we determine the I base here, and we resulted to these particular values. Also, we calculate for the Z base for both 13.8 side and the 480 side, and we have this particular values. Okay, so this is the summary of the calculated base quantity. We have the selected MVA base, 100 MVA or 100,000 kVA, and we have on the 13.8 kV side, we have the I base calculated here at 4,184 and the Z base at 1.9044 ohms. Also at 480 volts or 0.48 kV, we have the 120,000 ampere, 120, 281 ampere. 120,281 ampere. Okay, and 0.0023 ohms. So this will be our reference base quantities as we go on in our sample calculation later. Okay, single line diagram and equivalent impedance diagram. Okay, This particular single line diagram here we will show, and we will also use in our sample calculation later on. And we have a power utility, 13.8 kV voltage system with the available short circuit of 200 MVA. XR ratio at the point of connection is 25, and it's connected to a transformer T301 having a rating of 3 MVA, which has a transformation voltage from 13.8 to 480 volts, 13.8 kV. The impedance, as seen in this diagram, is 7%. Winding connection DYN 11. Okay, and XR ratio of 11. XR ratio is 11. Then it has 4 feeders. The 480 bus, okay, is there are four feeders connected on the 480 bus. First feeder is a motor, 200 horsepower, and with its corresponding cable size. And then the MCC, we have the motor control center having a total connected motors of 500 kVA, 460 volts, okay, with the subtransient reactance X double prime of 0.28, XR ratio of 2.30. Okay, and we have an MDP here, this lump static load. Okay, I just have to explain that when it's a non-motor load, it do not contribute to any fault, to the fault. So with this, we'll see in the next diagram that impedance diagram that this one will not contribute to the fault. Also, T301 is not a contributing equipment or not contributing anything to the short circuit type. So we have all of this equipment connected under this particular single line diagram. So we are going to create now the impedance diagram, the equivalent impedance diagram of this single line diagram. So this will be the outcome of the equivalent impedance diagram, which is we are going to use. This will be very important as we go to our calculation of short circuit. So the utility is represented by the impedance Z and transformer T301. The cable for each of the feeder connecting to the load are also represented. And then the impedance of the motor, subtransient impedance of the motor, ZM, subtransient impedance of this MCC, motor control center. Also, the transformer impedance is also reflected here. So now we are going to calculate show the process of calculating each of these impedance value in per unit and in common power base. Okay, calculation of per unit impedance subtransient for the power utility as shown. We have the given 200 MVA short circuit available short circuit MVA, which is 200 MVA, and then 13.8 voltage XR of 25. So the calculation using the formula shown earlier, okay, and we substitute 13.8 squared over the 200 MVA provides us 0.95 to 0.9522 ohms. Okay. After that, we have to determine what is the resistance and reactance component of this impedance. And using these particular formulas, okay, since we have the XR ratio from the impedance diagram, the data here is can be defined. Okay, so RU is equals to ZU cosine arctan of X over R. And substituting the values, it gives us 0.03806 ohms. Also, we perform for determining the reactance component of the impedance, and we also arrive at 0.95144 ohms. Okay. This particular impedance is still based on the original 200 MVA base. And therefore, we have to calculate under the common selected base, which is 100 MVA as per our sample. So actual over Z base. So the actual, this is a 13.8 kb site. So actual impedance over the Z base at 13.8, and we arrive with this particular result. Okay, ZU is equals to 0.01998 plus J 0.4996 in per unit. So next, we have to calculate the per unit impedance of T301, and we were able to compute that it's already given, no? It's already per unit. However, it's still in reference to its capacity, which is the 3 MVA. So we use this particular formula to convert to common base from the old impedance to the new impedance, and we have substituting the values, and we arrive to 2.333 per unit. Then we have to derive the resistance and reactance component of that impedance, and substituting again to the same process of using same formula and same process for resistance and for reactance, we arrive for this impedance, which is equals to 0.21125 plus J 2.32372 in per unit. And this is now under in reference to the common base of 100 MVA. Another transformer that is connected in that particular single line diagram is T001, the low voltage transformer with a capacity of 750 kVA, voltage 480 to 230. At this point, we will calculate the same process as the way we did for T301. The impedance of the transformer is already given as 5.78%, or it's 0.0575 per unit. And we have to convert this one to the common base, which is 100 MVA base. And using the formula of conversion, we arrive to an impedance equals to 7.6667 per unit. Okay, and again we have to derive the resistance and reactance component of that impedance, and following the same process and using this formula for resistance and reactance, we arrive this value of 1.30262 plus J 7.5552 per unit. Next is motor load. Okay, we have one feeder having a 200 horsepower, 460 volts. Power factor efficiency is there, and the subtransient impedance is given at 0.2, XR ratio of 5.8, and using this formula, okay, we first derive the old kVA, okay, and we calculated, and it's equals to 180 kVA here. This will be the old kVA of this particular load, motor load. Then we are going to compute for the new reactance, okay, and based on this, we are going to use the conversion formula, and substituting the values here, we arrive at a new motor impedance reactance of 102.02 per unit. Okay, now since we have an XR ratio here given 5.8, we are going to convert, we are going to determine also the resistance component. So by using the ratio of the XR ratio here, we arrive at a resistance of 17.5931 per unit, Okay, and substitute, and therefore the impedance here as a result is the combination of the resistance and reactance component. The MCC or lump motor load, okay, of 500 kVA is also calculated to determine the per unit values, and using the conversion formula, we arrive with the calculated value of new reactance of 51.4305 per unit, and determining the resistance, we calculated and came up with 21.6094 per unit. Okay, and combining them, it's representing the impedance of this MCC lump motor load. Okay, before we go for the cable calculation, I just want to show this reference, as for manufacturer data. It's given here depending on the type of cable, single core, multi-core, single core, AC resistance and AC reactance here. So as we calculate for the impedance of the cable, we are going to use this table as the reference. So calculation of per unit impedance of the cable, we for the sample calculation, we just present here for power cable number 101. It's a 3-core and size 120 mm squared with a length of 40 meters, 480 volts, and the given from the table, this resistance and reactance per kilometer were taken from that table from the previous slides. And we arrive with the calculation first in ohmic value, which resistance is 0.00788 ohms, and the reactance in ohms is 0.00288 ohms. Okay, then converting this one to to the per unit value. So we just simply divide the actual value by the base value. Okay, so we divide it using the base value at the 480 volts. Okay, and the result is C is equals to 3.4261 plus J 1.2522 per unit. Okay, so the other cables are already, I calculated that one, and we on the same process, and we arrive with this for power cable number 2, power cable number 3 is power cable number 4 or PC04. So we have here highlighted in yellow. So this will be now all of this impedance that we calculated will be used in our per unit calculation. Okay, now the resulting impedance after our calculation will look like this. Okay, we have the impedance of the utility. This is already in per unit value and on common power base. Okay, so all of this impedance is the one that we calculated there. So this will be the final impedance we are going to use during the calculation. Now, we have to understand symmetrical components and equipment sequence modeling, network model. Okay, symmetrical components. Symmetrical component concept of symmetrical components is used to simplify fault analysis by converting a three-phase unbalanced system into two sets of balanced phasor and a set of single-phase phasor. Okay, it says that these sets of phasor are called positive, negative, and the zero sequence component. Okay, sequence component domain notation are 1, 2, 0, just to be very specific with this. Okay, 1 represent positive, 2 negative, and 0 is zero sequence component. The phase domain here is ABC, A, B, and C, or A, B, and C, and capital or small letter, it represents the phase domain, which is the original phasor. Okay, just to illustrate how is the symmetrical component concept is, okay, we have here in the middle illustration diagram, okay, we have here the unbalanced the black color are unbalanced system, and it can be represented as per the concept of symmetrical component. It can be represented by three sets of phase three sets of component, which are two of them are symmetrical and one single phase component. So as shown here, okay, we have the positive sequence, negative sequence, and zero sequence component, and just by aligning it properly here, and we can see that a unbalanced phasor is represented by the three sequence components. Each phase are represented by the three sequence component. So here we have the phase voltage to symmetrical voltage domain. So here is the conversion formula. Okay, from phase voltage to symmetrical domain. Also from symmetrical domain to phase domain, here is also the formula at the bottom right of the slide. It goes the same for the current. Okay, here the current is represented by the unbalanced system, unbalanced network, and it can be represented by the symmetrical components. So here's again the phase current to symmetrical current domain conversion. Okay, and also here, as you can notice, we introduce here the what we call the A operator. Okay, which is equivalent, A is equivalent to 1 angle 120 degrees. Okay, so at the bottom right, also the formula from if we are going to convert from symmetrical current domain to phase domain. Okay, fault point. Okay, in symmetrical components, we are going in short circuit calculation using symmetrical components. We are going to calculate the impedance at the fault point. Okay, so fault point is that point in the system where the unbalanced condition is replaced by a balanced set of sequence component. So this balanced set of sequence component is what we presented earlier in the previous slide as the positive sequence network, negative sequence network, and zero sequence network. The positive sequence network has what we call the Thevenin's equivalent voltage as seen at the fault. So, and then the positive impedance is Z1. Here is the Thevenin's equivalent positive sequence impedance as seen at the fault. It goes, and for negative sequence network, Z2 is the Thevenin's equivalent negative sequence impedance as seen at the fault. And it goes for zero sequence network, Z0 as the Thevenin's equivalent zero sequence impedance as seen at the fault. So for utility grid, the utility grid equivalent model is represented by these figures. Okay, for positive sequence, you will see the Thevenin's equivalent voltage along with the Z1, and then for negative sequence, you will have Z2, IA2 here, and for zero sequence, ZO, IA. Okay, synchronous machine, also similar to generators. Okay, it will be like this as shown: positive sequence, the negative sequence, and then for zero sequence, we have the solidly grounded, and for zero sequence that is having an impedance grounded. Okay. The equivalent positive and negative sequence for network of power transformer as shown here for 2 windings and 3 windings. You can see how it's being represented. And for 3 windings, there is a particular formula also shown here to determine the impedance between the terminals, primary, secondary, and tertiary terminals. Okay, for transformer, zero sequence representation depends on the type of transformer connection. It depends on the winding connection. So we have to be very careful in establishing the zero sequence diagram of when we have a transformer connected to the system. We have to be very careful what is the winding connection, and if the neutral has solidly grounded or impedance grounded. So here are some of the common connection, transformer connection, and the equivalent zero sequence circuit. Okay, for motor, the induction motor will have similar to the synchronous machine or even to the generator. It's just so similar. For cables and transmission line, it's just represented by the impedance of the line. Okay, R and reactance component, resistance and reactance component, all for positive, negative, and zero sequence network. Okay, balance and unbalanced pole. So we have 4 types of short circuit current that is considered, and one of them is balance, and the 3 are unbalanced fault. So let us discuss this particular point. So we have the 3-phase fault. This is what we call the balance fault. Okay. And as you can see in the illustration, we have all the phases short circuited, and it's the ground current here is considered 0 since the fault impedance are balanced as well. Okay, so since all circuits, all phases are short circuited, we consider 3-phase fault as a balanced fault. So the boundary condition as shown here for this particular fault is shown here in the bottom right. 3-phase fault as shown for the positive, negative, and zero sequence, but it's said, okay, since this is balanced, there's only the positive sequence component that is present, meaning negative sequence and zero sequence is not present. So on the boundary condition here, it shows voltage zero sequence is 0 and voltage for negative sequence 0. I0 is also 0 and I current for negative sequence is 0. Okay, here is the formula for calculation of 3-phase fault. Okay, if ZF is 0, then basically 3-phase fault is equals to the E voltage, Thevenin equivalent voltage, over the Z1 or the positive sequence impedance. Then the conversion here as shown, compute phase fault current. It's just introducing the A operator. Okay, line-to-line fault is an unbalanced fault because it's only involving two phases. Therefore, it will surely be resulting to an unbalanced short circuit current. Okay, the system will be put into unbalanced condition. So here's the boundary condition here, as shown at the bottom right for the line-to-line fault. Okay, this is the symmetrical component representation for line-to-line fault, wherein you have only the positive sequence and negative sequence. And since there's no line-to-line fault is not grounded, okay, there is no zero sequence component. So formulas as shown here in this slide, and also to compute for the phase fault current is also shown in this slide. Single line to ground fault involves one circuit grounded to the short circuited to the ground, and this one we consider one of the phase, okay, phase A for this particular illustration, and therefore here's the boundary condition here that IB is equals to IC, which is also equals to 0. So only IA the faulted base will have the zero, will have the short circuit current. So here's the illustration for symmetrical component illustration for this single line to ground fault, wherein positive sequence, negative sequence, and zero sequence component are in series. Okay, and the formula for calculating the single line to ground fault is shown here. Compute sequence fault current down, and after you calculate that, you can compute for the phase fault current, which is on this formula. Okay, double line to ground fault, as shown here, we have two phases, short-circuited and also linked to the ground. So in this case, the two phases, unlike the line-to-line fault, which is not grounded, okay, which is not short-circuited to the ground. This particular fault is where two phases of the system is short-circuited to the ground. So there will be a ground component here, or even if it's a, as you can see, the ground current here will be the resulting summation of the phase B and phase C short-circuit current. The boundary condition as shown here in this bottom right, and the symmetrical component connection of this double line to ground fault is as shown here. We have the positive sequence, negative sequence, and zero sequence are all in parallel. With that, the zero sequence component fault current are determined using the formula as shown in this one. I1, which has this formula, and I2 formula, and I0 formula, or zero sequence component of the fault current. The boundary condition again as shown here, okay, and for computing the phase fault current, again we will just be using the by introducing the A operator using this formula. Okay, we are going to illustrate one sample of short circuit calculation to demonstrate what we have initially calculated in the previous slides. Okay, going back, okay, this single line diagram that we initially considered, we are going to calculate fault on the 480 bus, meaning we are going to determine what is the fault level at the 480 bus. So from that single line diagram, we were able to calculate all the impedances in per unit and at common base, the 100 MVA base. So now we can see, and we can simply calculate what is the fault impedance at this bus, at the 480 bus. Okay, we select here the fault point, and it is at the 480 bus. Okay, now we develop the positive sequence impedance. Okay, the first positive sequence impedance which shows us, as you can notice, we have these blue lines, dotted lines, okay, and it connects all the feeders that has the motors, the motor first feeder, which is the motor 200 horsepower, the MCC on the second feeder, and as well the utility. Okay, because these are only the point, what you call it, the circuits that will contribute, or that will contribute to the fault current here at bus, at the 480 bus. So with this is how the positive sequence impedance network will be shown. Negative sequence, okay. And then we'll go for network. After we develop the positive sequence impedance, we'll go for network reduction. Okay, what we will do is to add, combine all the impedances that are in series or in parallel. And with that, we combine the ZS here, or the one from the source, which the utility and the transformer impedance. We combine that. And then from the feeder, feeder number 1, motor feeder, we combine that under ZL1. And feeder number 2, we combine that impedances under CL2. And then after that, we combine the parallel. This is parallel impedance. The two feeders are in parallel. So Z line tot L2 or LT is equals to the parallel combination of ZL1 and ZL2. So with that, we arrive with this one. With the value of ZLT equals to 12.81806 plus J35 35.5361. Now this will be the simplified. After combining everything, we will have now the simplified diagram, and with that, it will only show the source side impedance and the combination of the combined or the parallel impedance of the two feeders. Okay, and then simply we can calculate the total positive sequence impedance as the parallel combination of the two impedances in reference to the fault point F. Okay, so we arrive with this value of ZF impedance. Positive sequence impedance at the fault point. So the same way we calculated for negative sequence impedance of the network. We developed the negative sequence impedance. As you can see, it's just so similar to the positive sequence impedance, but without the voltage, Thevenin voltage as seen from the pole. Okay, and after that, the same process we calculated. Since in this case, the positive sequence and negative sequence impedances are equal, we just arrive with the same value of impedance as the positive sequence impedance. For zero sequence network, we have to develop the zero sequence network. Now we are going to consider the type connection of our transformer. Again, for the first transformer, this is delta Y. Okay, and as you can see here, delta Y like this, and the delta side will be open. So the delta side here of the transformer is open, not linked to the source, and secondary side is Y, and Y grounded, and therefore it's grounded to the transformer is grounded to the reference bus. And another transformer here shown, it's a Y delta, but it's not a grounded Y. So it's open on also on the Y side, and it's open on the Y side, and it's also open on the delta side. So then we compute for that. This will be the resulting zero sequence network. Okay, we will just be computing this highlighted in yellow. Okay, following the same process, we combine the two feeder, the parallel feeders, and to have the simplified diagram like this. Okay, with the transformer T301 impedance and the combined impedance of the two parallel feeders. Then we calculate, since these two is also parallel in reference to the fault point, and we arrive to this particular value of short circuit zero sequence impedance. Okay, now we are going to calculate now the three-phase fault. After we calculate all the impedances, positive sequence, negative sequence, and zero sequence impedances at the faulted point, which is here. I reflect here in the upper right corner of the slide. Okay, and we substitute it at to the formula. Okay, and after substituting it to the formula here, we didn't use the negatives and zero sequence since we are computing for three-phase fault. We are only considering the positive sequence impedance, and we calculated a per unit I1 positive sequence current, fault current of 0.37885, angle negative 84.31 per unit. And we calculate after that the phase domain, phase A current. Okay, phase A is equals to phase B and equals to phase C in a three-phase fault. So A, we were able to calculate this value. Okay, 0.37885, it's just equal negative 84.31 degrees. And then we introduce the A operator one here, and we arrive with the phase B current with a different angle, same magnitude but different angle. The same for phase C current, it will be same magnitude and different angle. After that, these are still all in per unit. Okay, then we calculate the actual phase fault current by multiplying the per unit with the base current. With that, we arrive for phase A, we arrive at 45.57 kiloampere, angle negative 84.31. Likewise, for phase B, we multiply it with the base current, and we arrive the same magnitude, 45.57 kiloampere and 155.69 degrees angle. The same way for phase C, same magnitude, but the angle is 35.69 degrees. So this is for the three-phase fault. So we are done with three-phase fault. We will go for the line-to-line fault calculation, and we simply introduce again. Since we already calculated the positive sequence and negative sequence and zero sequence impedances at the fault point, we just simply substitute it at the given formula, and we arrive with the positive sequence fault current and the negative sequence fault current here. Okay, and then after calculating that, we calculate for the phase domain fault current, which is still in per unit. Okay, and the phase B is 0.32808 with angle negative 174.31 degrees in per unit, and phase C is the negative of IB, and we have this value phase C current 0.32808 with an angle of 5.69 per unit. Now we again going back to determine the actual phase fault current in kiloampere. We will simply multiply it with the base current, and we arrive with 39.46 kiloampere with an angle of 174.31. That is for phase B. And for phase C, we arrive at 39.46 kiloampere with an angle of 5.69 degrees. So single line to ground fault. This is the formula. Okay, here I1 is equals to I2 and equals to I0, and which is equal to E over positive sequence impedance, the sum of positive sequence impedance, negative sequence impedance, and zero sequence impedance. And that after substituting the values of each of the impedances, and we arrive at I1 equals to 0.1337 angle negative 84.22 per unit. Then we calculate for the phase domain. Okay, and then here we substitute on this particular formula, multiplying it by 3, and we arrive at the phase fault current of 0.4011, angle negative 84.22 per unit. After that, we calculate again the phase fault current, we multiply with the base current, and we arrive with a 48.24 kiloampere, negative 84.22 degrees angle. Then we have our double line to ground fault. This is the formula for double line to ground fault. And we have to determine here I1 first before we can determine I2 and I3. Because I2, as you can see in the formula, we need I1 before we can calculate I2. And so substituting again the values, the impedances, positive sequence, negative sequence, and zero sequence impedance on this part in this formula, we arrive at I1 equals to 0.26045 with angle negative 84.26 per unit. And this value, we are going to use this value to calculate the negative sequence fault current. So substituting again the values, we arrive at the negative sequence fault current of 0.11840, angle negative 95.57 per unit. Then we calculate also the zero sequence component of the fault current, substituting the values of I1 and the fault impedances. Okay, and we have the zero sequence component of the fault current equals to 0.14205, angle 95.88 degrees per unit. From there, we again go back to, we again use the formula of converting from the sequence domain to the phase domain. Okay, and we calculate IB here, substituting all the earlier calculated current, the sequence component currents, and we arrive at phase B, IB equals to 0.39181, angle 152.74 degrees per unit. And when we calculate also IC, or phase C domain fault current, and we arrive at 0.39060, angle 38.74 per unit. From that, we have to calculate the actual phase B current, which we were by multiplying it to the I base, and we arrive at 47.13 kA at angle of 152.74 degrees. And for phase C, actual phase fault current, we arrive at 46.98, angle 38.74 degrees, kiloampere. Okay. Degrees is the angle of the 4 phases. Then what we have, finally, we have to add, for double line to ground fault, we have to add both IB, or the phase B current, and phase C current. And with that, substituting with this formula, we arrive at this value. Initially, we use here the per unit value of the IB and IC. Okay, so we arrive at the double line to ground fault of 0.42614 per unit, with an angle of 95.88 degrees. Now, just by multiplying it with the base current, okay, and we arrive at 51.26 kiloampere for double line to ground fault with an angle of 95.88 degrees. So After doing all the calculation, we tabulated the all the fault current, and on this table we summarize all the um, calculated fault current in the this is the actual fault current, okay, in Ka. So for three phase it's 45.57, the same magnitude for all phases in kiloampere. For line to line fault it is 39.46, the same magnitude for both phase B and phase C but different in angle. For single line to ground fault, we consider phase A as the faulted phase, and we were able to calculate 48.24 kiloampere. And the double line to ground fault, having phase B and phase C as the shorted phases, and with a grounded, okay, we have 47.13 Ka for phase B, 46.98 for Ka for phase C, and the summation of these two current gives us a ground current of 51.26. So what we have just did is the process of short circuit calculation, from especially from developing the single line diagram, the impedance diagram, the sequence network diagram, simplification of the network reduction that we did for each of the positive sequence, negative sequence, and zero sequence diagrams. And after that, calculating the impedance, the fault impedance at the fault point, and then moving to calculate each type of fault using the respective formula for calculating fault currents. So with that, this is the summary, or this is the outcome of our calculation. And I guess this is my last slide already. And thank you for your for listening. Thank you.
Now, due to time constraint, we can no longer accommodate any questions. So
At this moment, we would like to present to you your certificate of appreciation.
let me read the citation. The Institute of Integrated Electrical Engineers of the Philippines Incorporated, Western Mindanao Region, Zambasuta Chapter. Certificate of Appreciation is hereby presented to Engineer Marlu C. Vargas, PEE, in grateful recognition of his invaluable contribution to the Institute of Integrated Electrical Engineers of the Philippines Incorporated as technical speaker during the 9th Western Mindanao Regional Conference with the theme Leadership Rising Above Adversity Through Passion and Commitment Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur Martian Garden Hotel, Zamboanga City. Given this 8th day of October 2022, signed by the President of Zambasuta Chapter, Engineer Mark Anthony U. Sebastian, and the Governor of Western Mindanao Region, Engineer Alexander D. Co. A round of applause, please.
Yan. So again, thank you so much, Engineer Marlu C. Vargas.
Thank you po. Thank you po.
Thank you po. Before we proceed with our next technical seminar, we would like to inform the presenter that you are given 1 hour to present your presentation. If you hear this sound, you only have 10 minutes to wrap up your presentation. To proceed with our next technical seminar, our next guest speaker is a former Zambasuta chapter president. Let us give a big round of applause to Engineer Proculo L. Francisco Jr. to present the conductor and again, a big round of applause, please.
I am very proud of Marlo, the first speaker. He was my former student in undergraduate and my former student in the master's degree. That's in the power system protection, power generation, control system. And I congratulate him for his systematic presentation and the fluency in the deliverance. Thank you. Congratulations, Marlo.
Thank you, sir. Thank you, sir.
That's the title. Low voltage cable and overcurrent protection device coordination. We have a sub additional topic, simplified fault current calculation. That's a three-phase fault and a voltage drop calculation. But unfortunately, I don't think we can get through that. So, doesn't move, sir. Ayun. From that outline, you have A, effect review. And second, the circuit breaker protection. Thirdly, the conductors. But again, I doubt if we can cover D and E. But we have to go faster. But in spite of the speed, I want you to be attentive because I will be asking question later and I'll give you this one. IAEE 9 WMRC token. Ayaw. So for our quick review, we will cover Article 4, motor circuit protections. Isa pa. Yun. Says on Article 2.15, minimum conductor ampacity not less than the non-continuous load plus 125% of the continuous load. We'll be using those standards in our load computations. The conductor ampacity should not be less than the maximum load to be served and the application of any adjustment or correction of factors depending on the applications. The voltage drop standard, 3% from the distribution panel, maximum 3% to the farthest outlet, or a total of 5% maximum from the service entrance down to the farthest outlet. So remember those standards. The protection of conductors are required based on ampacities. And ampacity of the conductors should be greater than or equal to the rating of the overcurrent. Greater than, remember that, or equal to. The overcurrent protection should not be greater than the ampacity of the conductor. Next po. For motor circuit, single motor conductors that supply single motor in continuous duty application, 125% also. So that's a magic number. Remember earlier we have 125%. 125% of the full load current. For small motors, circuit rating should not be less than 2.0. Sometimes we use the 3.5 as the minimum for motors. In our old designs, we use 5.5 or 30 ampere. But PEC says 2.0 is allowed, but not more, less than that. Several motors. If there are several motors in the circuit, 125% of the full load current rating of the highest motor plus the sum of the full load current ratings of other motors plus 100% of the non-continuous, non-motor load, non-continuous, and 125% of the continuous non-motor load. That's another thing that we need to remember in our load computation. Branch circuit overload protection. Continuous duty motors, 1 horsepower. Each motor used in a continuous duty application rated than 1 horsepower shall be protected against overload on the following: separate overload device. Again, you have there the magic number 125% with mark service factor 1.15 and mark temperature 40 degrees Celsius, also 125%. But all other motors is 1.15 or 115%. Or we have the thermal protector. Next, sir. Okay. Usually, when we design room air conditioners, dedicated, minimum old designs, minimum pa nga, 30 amperes, 5.5 mm. But PEC says, this is Philippine Electrical Code 2017. The Philippine Electrical Code is a living document. It continues to change. So we need to follow those changes. If we are still using the old 1900s PEG, baka obsolete yan. We follow the latest. Okay. Room air conditioners shall be considered as an AC appliance. Window type, console, or in-wall type, not over 250 volts single phase. So when it is an AC appliance, you need to say, you can plug it on the wall outlet. That's what the code says. Single circuit room air condition shall not exceed 80% of the branch circuit. If you have a dedicated circuit for room aircon, the load of the aircon should not exceed 80% of the circuit rating. Therefore, we need to multiply by 125 up rating circuit. If it is combined with other loads, you have aircon and other loads, lights, outlets, the rating of the room air conditioning should not exceed 50% of the rating of the circuit. 50%. Next. Okay. Plans requirement. Let's take that there. When we prepare electrical plans, click, sir. Plan requirements. On top. Yung underline po. Ayaw? Yung underline. Yun. Click lang po. Pag may lumabas na kamay. Anyway, hello. We cannot access that through that laptop. Sana ginamit ko na lang yung laptop. Plan requirements, we know in electrical plans we need the layout plan, the load schedule, the location plan, the legends, the single line diagrams. Other than that, we also need the design analysis. That's part of the requirement. Design analysis shall be included in the drawings or shall be submitted in a separate sheet. Pwede acceptable sa code. Pwede in a bond paper. But it is advantageous to have it in the drawings, hindi mawala. It includes load computation of branch circuits, feeders, busways. It includes types of ratings and trip settings on overload protection device, which we are going to study now. It includes voltage drop calculations, supposed to be part of our topic, but probably we cannot cover. Then it includes calculation of short circuit current. It includes protection coordination, but protection coordination is only required for commercial and industrial, not for residential. Also, the arc flash analysis. Next. Okay, circuit breaker protection. Next po. When we speak of circuit breaker, we just get those important terms. Frame size. We usually call that ampere frame. A term designating a group of circuit breakers. We have 60 ampere frame, 100 ampere frame, from 10 ampere to 60, that's 60 ampere frame, 100 ampere frame, 200 ampere frame, 300 ampere frame. So those are the frame size. But it doesn't mean that it is of the same dimension, different. Especially if you have single pole, two pole, three pole. The width are different. Then rated ampere, IN, designated IN, that's the rating of the circuit breaker. Then the rated voltage, and the ultimate breaking capacity, that's the KA capacity of the breaker. That's why we need the fault current calculation to determine if it does not exceed the KA of the circuit breaker. Forward, sir. Circuit breaker, as we know, offers us an overload protection to minimize damaged components. It offers short circuit protection and also protection against electric shock. The circuit breaker can manually open or close a circuit. The overload protection is accomplished by the bimetallic strip within the circuit breaker, and the short circuit protection is accomplished by the electromagnetic strip. The circuit breaker has stripping characteristics. We will learn each of those types of characteristics next. Although there are several types of circuit breaker in the market, but basically there are only two main, AC and DC. And we will cover only the most commonly used, the MCB and the MCCB. Next. That's the breaker. Next. The miniature circuit breakers design testing are in accordance with IEC 6898, that's one, and IEC 6947-2 for type A, B, C. That's IEC 6898. Type D, K, and Z are for IEC 6947-2. The maximum rating of the MCB is only up to 125 ampere. So when you say MCB, there is no MCB 250 or 300. Maximum rating capacity of in KA is 25 KA. Thermal release rating, the non-conventional non-tripping current is 1.13 of the rating of the breaker. And the conventional tripping current is 1.45 IN. Tripping, overload tripping will occur between those limits. Current nomenclature. The design current designated as sub 1 I sub B, should be less than the rating of the circuit breaker designated as I sub N, current of the protective device. And the current of the protective device should be less than or equal to the current capacity of the cable. Remember that condition. But you have a current rating ensuring effective operation of the protective device, which is I sub 2, and must be less than or equal to 1.45 the ampacity of the conductor. Tripping characteristics. The uppermost curve, that's an overload, the bimetallic strip, overload curve. Then down below, you have the short circuit curve. That's type B, type C, and type D are shown there. Short circuit is instantaneous. Once the short circuit current will hit that curve, it will immediately trip. While for the overload, there is a time delay, minimum time and maximum time. We'll learn that as we go on. These are the types of MCB. We have Z curve, designed to protect circuits that need a very low short circuit tripping, 2 to 3 times short circuit, 2 to 3 times of IN. The B curve is 3 to 5 times used in control circuits and lighting circuits, type B. Yung mga branch circuits, type B. Type C, designed for medium magnetics, 5 to 10 times. Used for general case protection of panels. So if there's a short or fault occurs in the branch, it should be the branch circuit breaker that should trip, not the main. If you're going to use the same type of breakers, most likely it will be the main that will trip, which will be a nuisance tripping because you don't like other loads to be interrupted. We have the type C designed for motor loads, 5 to 10 times, or type D and K rather, for motor loads from 10 to 20 and 10 to 14, and also for transformer. Next one. Those are the diagram or the curve, TCC curve from the manufacturer. Type C, you have the overload curve on top, and below that is the short circuit curve. You have AC from 5 to 10 in the curve C, and then from 10 to 14, then for DC. So we seldom use that for DC, but both can be applied for AC application or DC application. Type C is there, and type K is also there. Next. Okay, factors on MCB selections. What are the factors that we need to consider to select MCB? Number 1. Next. Voltage rating. The voltage rating must be equal to or greater than the system voltage. In these pictures here, you have 2 different circuit breakers. The left one is rated at 400 ampere. I don't know if it's not very clear. Up 400 volts. So that can be used, that's a single voltage, single or straight voltage rating, straight. The other one on the side, you have 120 to 40 slash rating voltage. So where do you use the slash rating and where do you use the straight rating? The straight rating can be used in any 3-phase system or single-phase system. The slash rating is only used for 3-phase Y-connected solidly grounded system. And the upper rating of that slash should be greater than the line-to-line voltage of the Y. The lower rating of the slash should be greater than the line-to-ground voltage of the Y. Now, in that case, that's 120 to 40. Can we use that in a 3-phase 230 volts line-to-line? Yes or no? Okay. That's in the left breaker, the data is written in front. On the right side, the name plate of the voltage is also in front, but it says there 120 to 40. So can we use that in a 230 volts 3-phase system? Hindi. Why? 230 volts 3-phase system, line to ground is how many volts? 132. The lower voltage rating there is only 120. So we cannot use that. Okay, next. A current rating. Current rating, in this case, this is a 20 ampere type C, tripping characteristics. In that case, that's a 20 ampere also, with no indication what type, maybe another side. Then the braking capacity. Braking capacity for this is not so clear, but that's 6 kA. For that one, that's 22 kA. So higher braking capacity for that square D compared to this Snyder. Then you have the number of poles. You have to indicate that in your specification. 3 poles, 2 poles, or single pole. Then the mounting type, whether you order bolt-on type, plug-in type, or DIN rail type. So I put a brand question mark. Should you specify also the brand? It depends on you. But in our case, we always specify the brand because we have a list of acceptable brands, usually NRTL listed products. That's the requirement of the Americans, NRTL listed. So we have list of acceptable brands. That's why we have to specify the brand. Next. The rated current of a circuit breaker is based on a 30 degrees or 40 degrees, or there are other such as 50 degrees. If breakers are installed side by side, as a rule of thumb, 80% mutual heating, you have to rate that to 80% mutual heating. Next. That's the rating. For that circuit breaker, the left column, green, that's the rating of the breaker, 0.5, 0.2, up to 63 ampere. The upper column, that's the ambient temperature. If ambient temperature 60, the reference temperature here is 50. So you'll see 50 column is the same as the green column, the same rating. Above 50, you have to derate. The rating of the circuit breaker decreases. Below 50, the rating of the circuit breaker decreases, but here increases rather, lower temperature, decreases higher temperature. Next po. This is just one sample. Load current 32 ampere, installation condition, side by side. That's why we applied the 80%. Ambient temperature 60, that's why we have there the 60 column solution. The rating factor up to 125 or 0.80%, that's 42A. If we will see that, unfortunately, we cannot open that table PPTX. The 42 falls on the 50 ampere based from the table. So the 50 ampere breaker should be chosen next. If we choose the 50 ampere, next po. That's on that, the circle. That's a branch circuit, so type B. Catalog number, if we specify the breaker, the catalog number is next circle po. That's the catalog number. Is specify. Optional, if you have the very descriptive specification, you don't need to the catalog. Next po. That's the curve for that type of breaker, IC60, the right side, 60 to 6 to 63 ampere. Type B is the first curve. So from that curve, we will use that later to plot the damage curve of the cable. The damage curve of the cable should be on the right always. Next. Next. So we will go to MCCB. MCCB, this is an electronic breaker. You have adjustments. First adjustment is the long time ampere rating or IR. That's the continuous current rating, which you can adjust from 20% to 100%. If the breaker is rated 200 ampere, so 20% of that 40, 50% of that is 100, and so on. you can select. Next, long time delay. Long time delay, that's time adjustment. The long time ampere rating is the horizontal axis is ampere adjustment. Vertical axis is time adjustment. So that's time adjustment from 2.2 to 27 seconds. The short time pickup is 1.5. That's again current adjustment, horizontal. 1.5 to 10 times of IR. That's the knob. Next. Short time delay in conjunction with the short time pickup. When you adjust the current there, you adjust the time here correspondingly. So you have two time in second, fixed time, and the I squared T. Fixed time, that's the black knob, 0.05 to 5.5 seconds. And then the gray is from 0.18 to 36. Next. Instantaneous pickup, that's the short circuit adjustment. You can adjust the short circuit from 2 for this type of breaker from 2 to 40 times. So 2, you can have type B, type C, type D, type K, depending on your selection on the instantaneous pickup. Next, the ground fault pickup controls the amount of ground fault that will cause the breaker to interrupt the circuit. Useful for circuit breaker coordination. You have 0.1 second from 20% up to 70%. 0.2 seconds, the same setting, and 0.4 seconds. We do not go anymore to 0.5. That's already overload. So next. You'll see there, the upstream breaker is 0.2 seconds delay. The downstream breaker is 0.1 second. Downstream breaker should trip first in the ground fault compared to the upstream. That's a coordination adjustment. Next. 200 ampere circuit breaker. Next. That's the 200 ampere line from the curve. Setting is 200, IR setting. If the fault current is 600, determine the trip time. Next. At 600 ampere, trip time is the lower limit of the curve, overload curve. Next. It will trip from 25 seconds to the upper curve. Next. Approximately 175 seconds. That's the time that it will trip. If you adjust IR to 900 and the load overload, the short circuit current is also 900, what will be the tripping time? Next. That's the 900 overload. Tripping time will be next. Immediate. No time delay. Short circuit yan. Setting 900, short circuit current 900, trip immediately, no time delay. Next. Setting is 2000. Short circuit current is 900 only, but your setting is 2000. So what is the tripping time? Next. From 12 seconds to the upper curve. 55 or 52 seconds. Next. This is the selective coordination overview. You will see the circuit breaker 1, that's the upstream breaker. Circuit breaker 2 is the downstream breaker. When overload occurs, short circuit occurs, circuit breaker 2 will hit first by the overload line. So that should be circuit breaker 2, that which is on the downstream, should trip first over the circuit breaker 1. Next. These are the comparison of the uncoordinated system on the left and the coordinated system on the right. Uncoordinated system, you have overlapping of circuit breakers. that usually happens in the actual area that we practice. And then you have the damage curve on the right and the transformer curve on the right. Next. Conductor ampacity. The ampacity of a conductor is rated continuous. That's continuous current. Cable damage curve represents the maximum current that can flow through a cable. Then fault should clear before it reaches the damage curve. Next. Conductor, usually per standard, is based on the 40 degrees for on air, 20 degrees underground, directly buried 30 degrees. That's on the table that we have from the Philippine Electrical Code. Then if your ambient temperature differs from that, you have correction factors adjustment. Next. Cable selection based on current carrying capacity dependent upon the method of installation, whether you install in a conduit or in a cable tray or on open air. Next. Then the voltage drop dependent also on the root length and the load current. Then short circuit temperature dependent on energy produced during short circuit. Those are the three select factors that we select conductors. Next. Determination of minimum cable size based on current carrying capacity. Determination method for a single circuit. The method of installation should be depends on the rating. The rating application of the base or the design current. Then group of conductors, you apply the rating factors. For 3 conductors only, there is no the rating. But for more than 3, you already apply the rating factors. Determine conventional conditions, ambient temperature, depth of laying. Those are the factors that we apply before we get the design current. Next. That's the cable ampacity in a raceway based on the Philippine Electrical Code. Cable ampacity in pre-air, which we will be using as we go along. Next. That's at 30 degrees C, also at 30 degrees reference. Next po. The cable ampacity in messenger at 40 degrees C. And then you have the correction adjustment factor for group of conductors. Then next. Then you have the ambient temperature correction factor based on 30 degrees and different ambient temperature. You have to choose there where's your correction factor. You have the ambient temperature correction factor for 40 degrees if the conductor, like the messenger, hung cable that's in 40 degrees, we use the right table. For the direct buried and pre-air, we use the left table. Next. Determination of minimum cable size based on voltage drop, we will, unfortunately, we cannot discuss. But we should take into consideration the load current and the root length of the cable, plus the impedance or the resistance of the cable. Next. Cable damage curve. You have here the intermediate or overload limit curve from 10 seconds. You have 10 seconds on the vertical axis going up. That's an overload limit curve, overload. 10 seconds below is the short circuit. Next. That's the short circuit. The curve describes the conductor short circuit from 10 seconds and below. Next. This is the upper table. Table 1 is used in computing the short circuit current. The initial current on the rightmost column, conductor rate temperature usually is 60, 40 W, 75 THW, THWN, 90 degrees for THHN. And what will be the final temperature? That's the third column, 150 for TW, THW, THHN. 150 final temperature, that's T2. That table is used for solving short circuit current. Table 2 and Table 3 for solving overload current. We cannot use the upper table in solving overload. Then once we have the overload current and the short circuit current, we can plot that cable damage curve. Next po. I score T. This is the formula we use on short circuit calculation, short circuit current. Next. That's an example. You have 250 mm squared cable, that's 500 MCM, 10 seconds time, short circuit. The cable is THWN copper. We use that formula. K is taken from the table earlier. Fortunately, we can go back. Next. Oh, that's the, where do we get K? Click. Click, click. That's the 75 initial temperature of THWN. Next. That's 150, the final temperature of THWN. Wherever it meets. Next. That's the K of the conductor. 105. Next. So we use 105 there K, then we can solve for the I, short circuit. Very easy. Simple. No? May complex. Next. Next. This formula also, empirical formulas, in solving short circuit current, we have given initial temperature T1, final temperature T2 for copper and for aluminum. Well, but the A here is the area, cross-sectional area of the conductor in circular mills. So usually in the table, we have MCM. You multiply that by 1,000, that's already your circular mills. For the 500 MCM, so the area will be 500,000 circular mills. Next. There, you have that sample. 500 MCM. Then you have the current 375. Fortunately, again, we cannot see those tables in the green underline. Then we can get the damage calculated curve. This is the, if you see 10 seconds above, that's overload, no? 10 seconds above overload. Percent current based from table 2, table 3, and the short circuit current, which is this percent, 21.97% times 375 on top, you get 8,239, and so on as you go along, multiplying the same procedure. Next. For the short circuit, the lower table there, small table in black and white, 10 seconds below. Short circuit yan. Yung sa left, I just show the overload curve table. So you have, using any of those formulas above, you will arrive to that current and the right column. Next. Conductor and overcurrent protection. Next. Okay. That's the cable curve. On the ampacity of the cable, that's the blue line. On the left is the usable area. You can load any part of that area. From that vertical line to that cable curve, below is the protection area. That's where you plot your circuit breaker curve. Above that is already a damaged area. Beyond that, the cable will get damaged. Either it will melt the insulation or it will burn the insulation and break the conductor. Next. So you have this suggested overcurrent protection, set long time for LTPU at or below the ampacity. LTPU there. Next. So the LTPU is set at the ampacity, vertical line. Set protection above the cable usage area. Cable usage area is on the left. the protection is already above. That's correct. Set protection below the cable thermal overload. Cable thermal overload line is the red line. The protection is below. That's the blue curve. Set protection below cable short circuit. Cable short circuit from the 10 seconds down below. The protection of the circuit breaker is below. That's correct. Comments. If currents penetrates the limit on the thermal overload curve, cable insulation is reduced. If maximum through fault penetrates the limits, the short circuit damage curve, insulation damage will occur. Next. Pwede rin ganyan. Below. Although you reduce your usage area, but that is still okay. Next. How about that? Can we use that? Generally, no. But specifically, yes. Set long time pickup at or below. We do not meet because the long time pickup is already above the ampacity. Set protection above the cable usage area. It's not yet. It's above the protection, the cable usage area on the left. Set protection below the cable thermal overload curve. It does not meet. That's why it's red. Set protection below the cable short circuit. Yes. Generally, I say we cannot use this. But specifically, yes. Where can we use that? Next one. There. Under this emergency operating condition, currents must be much greater than the rated ampacity cable can be supported in accordance with IEEE 242-2001. Where do we use? Power loss hazard. Conductor overload protection shall not be required. Overload is not required. That's why we go beyond. Where the interruption of the circuit will create a hazard, such as fire pump and material handling circuit. Dalawa lang. That's it. That method can be used only on two. Fire pump and material handling magnet circuit. So generally, hindi pwede. Next. How to coordinate? Get the OCPD, TCC, and cable damage curve. That's the OCPD curve. Then we get the next, the cable damage curve. Usually, the OCPD curve is taken from the manufacturer's manual. You get that? That's done from the EasyPack EasyC to 400. But the cable damage curve, we cannot find that from the manufacturers. You have to plot using those formulas that we have above. You plot that on the OCPD curve. Next. Make the graphical scale of these graphs identical. In this case, we cannot make that identical unless we will plot the cable damage curve right on the OCPD curve. Ensure that the cable damage curve is on the right side of the OCPD and TCC. Next. That's the one. The result, your cable damage curve should always be on the right side of your OCPD curve. That's cable and circuit breaker coordination. If there is an overlap, then that's not right. Except for fire pump and material handling magnet circuit. Simplified fault current calculation, I don't think we can finish that short period of time. But I will brush along. The simplified fault current calculation is for three-phase voltage fault. Three-phase. In a three-phase voltage fault, we don't need the symmetrical components because they are symmetrical faults. They are symmetrical faults, equal A, B, and C. Three-phase fault. And usually, when we compute for the fault current analysis, we consider the three-phase fault. So, Did anybody has seen this table before? Did anybody has seen this table before? When I was practicing, started practicing fault analysis, I cannot find the impedance of the cable until I saw this table. This is from Westinghouse catalog. So you have copper conductors, magnetic circuit, copper conductors in a non-magnetic conduit. Magnetic conduit. We take only the impedance on the third column for the magnetic conduit. Also the impedance on the third column of the non-magnetic conduit. From there, we can compute for the impedances of the cable. That's 300 per 100 feet. Ohms per 100 feet length. Next. This one, due to the trend towards lower impedance transformer, that's why I asked a question yesterday from Chilin if they have their impedance table. When you take a look on their website, on their page, web page, wala, you cannot find. The actual transformer impedance may deviate from the NEMA standard given on the left. That's the NEMA standard. Therefore, the actual values obtained from the nameplate. So you can go to the nameplate of the transformer and get the impedance Z. For existing system, that you can easily get that from your site. But if you're still designing a system, you just have 500 kVA transformer. So what's the impedance? Wala kasi wala pa. You go on the NEMA standard. That's the NEMA table. R, percent X, percent Z impedance for corresponding type of transformer, single phase and three phase down below. Next. That's the impedance. Next. Fault current calculation. Just out. Next. So draw the system diagram. You have the system diagram, the transformers and the loads, the breakers, the cable ratings. Next. You have to determine the length of the cable, the root length of the cable. And then draw the impedance diagram. That's the impedance diagram. Obtain the short circuit level of the vicinity and select kVA base. Usually the secondary of the transformer voltage is the base voltage. kVA is the transformer rating. Next. F fault A, B, and C. Compute for the per unit value, base impedance, or the base kVA over kVA utility. That's the Z source impedance. Then the compute for the per unit of the transformer. That's 5%, so that's 0.05 per unit. Then compute for the feeder lines taken from that table earlier from Westinghouse. You can solve for the impedances. Then convert to per unit. If you have the base impedance, kV squared over kVA times 1,000. Next. Then compute per unit value of motor contribution. Per IEEE standard 141, it says that the motor impedance is equivalent to the kVA base over 4 times kVA of the motor. Usually, we only know the kVA rating of the motor. We do not know the reactance of the motor. Especially if you're doing a proposed design. So, by that formula, in accordance with IEEE 141, the impedance of the motor is kVA base over 4 times kVA of the motor. Then compute for the short circuit currents on designated points. Draw the impedance diagram, simplify diagram, combine impedance, and complete short circuit. Next. So their fault at A, that's the A circuit breaker is affected. Down below is not affected. The simple diagram is there. You have the impedance of the source and the transformer impedance only. Solve for the fault short circuit current, 14.97 kA. Use at least 15 kA IC circuit breaker. This is the time where you go to your circuit breaker rating. What is the kA rating? So you cannot use here the 6 kA, above 15. Next. Fault at B, that's the next. Circuit breaker at B, fault occurs. There is a contribution of current from motor A and motor B, 100 kVA motors. That's why we computed their impedances. Combine the impedance series parallel circuit, very easy. Ohm's law lang. And then solve for the total impedance. And we can have the short circuit. Basta we kita ice cream, sir kaya tayo. Next. Okay. That's the fault current at B, 17 kAIC. So you'll notice, greater than at the fault on the upstream. 15 lang alya, aki 17. Because of the contribution of the motor. Next. Fault at C, we go down below downstream. The fault current, next. That's only series parallel circuit, no? Lower, 9.9 kA only. Next. Summary, those are the formulas that we'll be using if there are transformers in between. Next. Okay, that's another step, the continuation. Next. IC 14.97, we choose circuit breakers higher than that. Fault at B, 17, choose circuit breaker on the table, manufacturers provided catalog. Next. That's the group that we can select. Next. 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 Okay. If the circuit breaker breaking capacity is below the fault current, what will happen? Once a short circuit occurs, the circuit breaker will blow. It will burn. It will not safely trip. So that will cause fire, arc flash. We are trying to avoid that. Next. Voltage drop calculations. We have three methods: the exact, the approximate, and the shortcut method. We will not discuss the exact. We will not discuss the approximate. The shortcut as described in the code. Next. That's the only formula. Very simple. Maskin elementary, pwede man solve. You get the data from the table. Next. That's the table. The power factor, the conductor, corresponding magnetic, the impedance or the voltage drop, rather, voltage drop. Next. And remember, we'll go back first there, sir. Down below that table, we'll go back, sir, on the table. Below the table says there, voltage drop, volts per ampere per 100 feet. Three-phase, phase-to-phase. So other than that, let's say if you have single phase, you can get the data from that table, and then we have factor to multiply. Next. There you have the factors. Three-phase, 4-wire, 0.577. Single phase, 2-wire, 1.155. You multiply to that table factor. Then, you can already use the formula. Next. Voltage drop. Example. Next. That's from the source down to the last load. You have voltage drop 1.298. Then you can solve for the next voltage, percent voltage drop. What is the acceptable percent voltage drop? 3 from the distribution to the last, or 5 from the source to the load. Next. Those are the references. Next. Next. And next. Stop. Answer uno. Okay, on this one. Conductor supplying several motor loads shall have an ampacity not less than the sum of the following: 125% of the full load current rating of the highest motor, sum of the full load current of other motors, 100% of the non-continuous non-motor loads, plus what? I will give this one. Plus what? Why, can one answer? Oh, Engineer Ducalas. Okay, you give the answer. Next. 125% of the non-continuous non-motor loads. Ano, kanya pwede saka. Next. Okay. Room air conditioners, not over 250 volts single phase, shall be considered as blank. Okay. AC appliance. Congratulations. Next. Next. Per IECEN 6898 standard, the conventional non-tripping current is 1.13 IN. What is the conventional tripping current? Buddy. Next. Tama ba? Oh, correct. Factors of NCB selection: voltage rating, current rating, tripping characteristics, number of poles, mode of mounting, and except the brand. Optional yon. And what? Yes. No, optional yon. Meron ba? Very important. Factors not there. No, I can kere. Oh, yes.
The braking capacity.
Correct. Next. Braking capacity. Meron pa. Type of MCB tripping characteristic designed for medium magnetic startup 5 to 10 times. What is that type of circuit breaker? Type B, type C, type D, type K, type Z. Five to 10 times. Sorry. Next. Another attempt. Type C, type C. Next po. Type C. Meron pa. What are the 3 methods of voltage drop calculation? 3 methods.
Wala pa, sir? Exact, approximate, at saka shortcut.
Next. Zach. Next. Approximate and shortcut. One more. Meron pa ba? Next. This is type B. 3 to 5 times. Next. Next. Oh, very easy. Three-phase poles are assumed to be symmetrical. Hence, symmetrical components analysis is not necessary. Oh. Microphone, microphone. Microphone.
False po.
He was not able to get the answer. Next. True. Next po. Thank you very much. This will go to the president and the governor.
Thank
Dito
you,
ba, Governor?
Engineer Proculo Francisco. At this juncture, we will no longer accept any questions and we will proceed to the awarding of certificates.
Again, thank you so much, Engineer Proculo L. Francisco Jr. Now, at this juncture, we would like to call off the president of the 2022 Zamba Soldier chapter, Engineer Luz Agraviador. A round of applause, please.
Appreciation. With my president, Engineer Proculo L. Francisco Jr., PE, in grateful recognition of his valuable contribution to the Institute of Integrated Electronics of the Philippines Incorporated. Technical speaker during the Ninth Western Mindanao Regional Conference with the theme Leadership, leadership rising above adversity, action and commitment. Held on the October 16, 2022 at Palacio. And Governor Western Mindanao.
Again, thank you very much, Engineer Proculo Francisco Jr. At this juncture, let us all watch a sponsored video presentation presented by the MIES Corps.
People don't have the
Ayan, so thank you so much, Ms. Cor. Now let us present the Certificate of Appreciation.
So let me read the citation. Institute of Integrated Electrical Engineers of the Philippines Incorporated, Western Mindanao Region, Campus Chapter. Certificate of Appreciation presented for Alpha Industrial Engineering Services Corporation in grateful recognition of their invaluable contributions to the a sponsored technical presenter. 39th Western Mindanao Regional Conference with the theme Leadership Rising Above Adversity Through Passion and Commitment on the Road to Recovery. Held on October 6 to 8, 2022 at Palacio del Sur Marchand Garden Hotel, Zamboanga City. Given this 8th day of October 2022, signed by the President of Zambasuta Chapter, Engineer Mark Anthony U. Sebastian, and the Governor of Western Mindanao Region, Engineer Alexander D. Ko. A round of applause.
Time, we are going to have our 5th technical product presentation on Dong-ai Technical Presentation. But before we proceed with our technical product presentation, we would like to inform the presenter that you are given 25 minutes to present. If you hear this sound, you only have 10 minutes to wrap up your presentation. Our technical presenter is a branch manager at Dong-ai Panelboard Fabrication Corporation. Let us give a big round of applause for Engineer Ro Gomez Dolanan.
Morning, may buntag Olta. Gracias sa inyong pag-imbita sa amo. So before I present, hindi pa yun natapos ang video, sir. 3 minutes video presentation. Okay, so yan muna. Thank you very much, sir. To our national officers, IAEE, led by Sir Padua and the team, lalo na sa Sambasolta, kay Sir Alex and the team. So, daghang salamat, grasya sa inyong pag-imbita sa amon sa diri sa inyong lugar. So, nara ko'y gamay lang na oras. So, this is our company, present to you. Nakaka-pressure si Sir Francisco, ha? Ang daming prizes. Pero sige lang, ato na ni siyang i-explain. Binisaya o atong sagol-sagol. Okay, so ito po yung aming company profile 2019, hindi pa po na gawa. At least sunod-sunod na lang po tayo. Yan yung po aming logo sa Dongay Enterprise. Sa Panel Board Fabrication Corporation, duwa man gud siya na company. So mao na siya ang among trademark sa pagkakaroon. Okay? Yan, mao na siya ang atong general information. So the general information, importante kay ni siya. Yan, nagkasamok na siya. Sige lang, diri sa kuha is, Dongay Company is not a Korean company. This is from Mindanao. This is from Misamis Oriental, Medina. Diya siya na tao, which is kinabuhi ni Sir Ariel Galindo. Siya ang tawag niya, Dodong Ayi. Ngayon si Ariel Galindo Radiay. So, Filipino company. So, we have our company in Potrero, Malabon, dool sa Malabon Zoo. So, sa mga igagaw nato dito, dool ra, di mo masaag sa Manila. Then, napami sister company po sa Cagayan de Oro. Ang sa Matilde, Neri Street, Carmen, Cagayan de Oro. O ako base ko sa Cebu, Punta Princesa. Then dagan na tay nasugdan nya na found siya 2005. Okay, 2005, so 17 years na in the market. Our general manager is Ariel Galindo. Tama na siya. Supply. So basig na ipangutana about install wala may installation, so supply ra gyud mi. Okay, so mo na siya ang atong description. Ang Dongay is usa siya ka base Philippine company. Specialized gyud siya sa panel boards, ECBs, cable trays, vertical elbows, horizontal elbows, telephone terminal cabinet, meter center, transfer switch. At mo ni siya ang automatic or manual transfer switch. The company start is 2005, then owned by the vision was provide to quality service and a world electrical industry and ensure the customer are well educated about the safety aspect of using electricity. So looking ahead, Dongay Enterprises is the confident about future because it believes that it can continue satisfactory service and provide the demand of marketplace. And the company also believes that the excellent economic condition will help to achieve significant growth and sales. So yan po ay nangyayari na sa tibuok Philippines because Dongay is all nationwide na ang atong delivery o dagan-dagan na ang atong serbisyuhan. So mao ni siya ang atong mission. So it provides to improve our product with speed. So far so good sa Cebu. Wala pa ko'y case na late. So naagyod ang paspas karon na service. So nami kanang recent na nagisupplyan sa Basilan o sa Zamboanga. Dili na ako i-mention, okay? So number 2 is to meet our clients' demand and gain and maintain their trust and loyalty. Hopefully sa mga nakagamit na makita na ninyo. Ikadua, to grow together with our customers and partners by offering themselves the best quality technology and services. So, inani ni siya. Kung mag-grow mo, mag-grow sa me. Okay? So, ang among vision is to meet our clients' demand to give the best quality and service we can provide. We believe and the asset of the company is not the name, but the products and service we render. And our earned clients' trust will follow the principles. Mao ni siya ang principles to innovate our products for better performance and a better quality. Our company does not only needs to provide better quality products but needs to improve them and bring forth future for us and our clients. So lahat tayo, sama-sama tayo dito sa pag-unlad ng ating mga industry, especially sa ating mga electrical needs. Next po, ang product natin, yan, ang ating makita niyo yan sa boat. Salamat di ay sa nagbisita sa boat dito sa number 14. O nakita na ninyo, mudiritso ta kay gamay na lang akong oras. So next is our brand name. That's the brand which is mo nang among gidala na mga circuit breaker. So meron kaming ABB. Sige na. Next, meron kaming LS. Meron din kaming GE. Meron din kaming Chent, Jewish, Snyder, Himil, Dilixi, and Fujikiden. So anything na gusto nyong mga brand, sabihin nyo lang, through speaks lang, meron tayo. So kompleto yan. Okay, next. Yan, yun yung nakita nyo kanina sa video. Ayun yung mga machine namin na ginagamit. That's why, pag sinabi natin sa Manila ginagawa, marami tayong mga competitor sa Manila. So kompleto kasi sila ng mga machine, kaya ang bilis at ang quality medyo kakaiba. Okay? So, next, ito yung bago namin na machine na ginagamit ngayon sa Dungay, sa Potrero, Malabon, which is our competitors have that. So si Dungay, si Ariel, Dong Ariel ay nag-dream siya na magkadunasad siya ini. So last year, before pandemic, nagkaroon na kami ng Euromac MTX Plus Flix 6 Hybrid na yan sa pinakamabilis na pagtrabaho ng panel boards. Next po, sir. Yan, meron tayong press brake binder, hydraulic bus bar binder, machine. Next is our copper bus bar binder. Kompleto siya. Shearing machine. Kompleto tayo. Sa spot welding machine. Kanina nakita nyo, welding manual pa. Meron na tayong spot welding machine na ginagamit. Next is our product information. So, diri ilado ang Dungay sa ETS, MTS. Tapos, yan, tuloy-tuloy na sir. Pastrada lang na to, fast track na to. Product information about motor controls, nata, daghantana. Cable ladders, no? Mga cable ladders. Product information about panel fuse sa disconnect. We have that. And about wire ways, elbows. So far, mamaya sa akong mga reference, mabasa na ninyo kung asa ta na about kutob. So wala na ako gi-appeal diri ang sa Luzon project. Ako lang gi-appeal diri ang Visayas and Mindanao. Okay, next sir. I-continues na nato ang product information ato ta sa certification sa Snyder. So ang ating manager sa Snyder nag-visit kanina o kahapon about the certification. Okay, next. Yan po yung post tagamay diha because that certificate is from DTI. So nakita nyo dito sa akong booth na sa DTI, we have gauge na sinusunod. Ang gauge natin ay gauge 18, 16, and gauge 14. Kaya hindi namin makompromise pag ang specs ninyo sa ECB is gauge 16 talaga, or gauge 18 talaga. Dili ta pwede mo compromise na kay kasabanta sa atong gobyerno. Nya pwede mo reklamo pud namo sa amo ana. Next is our duwa ka 2303 sa Dungay Enterprise o sa Dungay panel board publication. Then we have DTI and SEC registration. Then ang aming business permit namin ay sa Potrero, Malabon pa. Kasi po kami po ay satellite lang. Hindi pa po kami totally branch out. So satellite lang muna. Hanggang sa, of course, gikan sa gamay hantod sa padako. Okay, our mayor's permit. Then yung mga partners natin kanina, pinatanaw na sa video. Okay, so let's continuous na lang, sir. Okay, ato ta sa mga reference. Yan. So sa reference namo karon, na ako'y project karon sa Zamboanga del Sur. I don't know kung tinuod Zamboanga del Sur ba ang Sagaysano Capital Mulabi? Yes, Zamboanga del Sur. Thank you. So we have 600 cable trays with a person of Engineer John Baldonado, a former president of IIEP sa Cebu. So og Sagaysano, Balingasag, Surigao City, dali pod na deliver po nato mga cable trays po dito na yang gi-order. Last year pa na og ang update karon ang sa Zamboanga del Sur sa Mulabi kay ginahimo man na karon. Okay? Next is our Pacific Mall and Mandawi City, Tambuli Beach Resort, Lapu-Lapu City sa East Mall sa Cagayan de Oro City by Engineer Jaime Magsayo, ang atong champion pod sa Cebu sa electrolyte. So ang gin-order niya sa MUA is breaker gutter, cable tray o mga pull boxes. Wala pa siya sa panel board, kaya na siya amigo sa Cebu na wasig mo balhin na to sa Dungay. Next is sa SRP, Cebu City, San Remo, Mabulo City, lahat po ng PhilInvest sa buong Pilipinas, sa Davao, sa Ortigas, Santa Mesa, Marikina, Arroyo Highway, Cebu City. Ang ginakuha nila sa Dungay is meter center, breaker gutter, busbar gutter, pull boxes sa mga wire gutter. So pag may nakita kayong PhilInvest sa lugar nyo, so hopefully, nandyan yung long reads na kami po ang nag-supply sa ilaha. Next is yung sa Ostal Cebu, yung malaking company sa Ostal, sa Rapi, dito sa Cebu, sa Balamban, sa Ostal Balamban, Gutter, ECB, ETS, Snyder brand. Even sa Iloilo, Philippine Science Auditorium sa Iloilo, Haro City, so we have contact there from Angel Gabriel Builders, si Engineer Paul, MDP, ECB, ang kanilang in-order sa amin ay Chent na brand. Tapos yan, Horizon 101, so nakato na mo sa Cebu, pinakataas na building sa Cebu City now, in the person of Christopher Kapul, PE nato, siya po ang atong contractor dito. So naka-deliver ta og mga pilot lights with emergency and normal sa Snyder brand LS at the same time ang yang gi-order sa tuwa. So sa Limkit kay dili kagay di oro Limkit kay Mandawi o sa ACT sa ACT College sa Cebu City by DGD. So MTS, ETS, breaker full gutter. This is only for Cebu for 3 years na operation nato. San Miguel Corporation, we have Mandawi City in San Miguel na by Engineer William. Mahimo sa di siyang PEE. So mao na siya ang atong gipang deliveran dito through GS Engineering Panel Board ni 3R full boxes. Diri sa Ismol, South Cotabato. So muna na dili gyud kayo layo, dali ra kayo South Cotabato diri sa Ismol, Gaisano Capital gihapon og sa Iloilo City. So we supply that from RMT Engineering, si Engineer Roel Tapil ang atong madasigon po na PE sa Cebu City. RMT Electrical Works. So i-order siya sa tuwa og mga breaker gutter, thermoplastic panel, natay Electra diha, Nima 3R full boxes. Okay, so dagan-dagan na kayo ni para makita ninyo kung gaano ka-stable na ang atong mga kliyente sa Ayala, Cebu City, sa Funay Electric Cebu, Mactan, sa MIPSA. Naasa diha ang atong engineer, si Engineer Ronilo Villaflores from Tudila, Misamis Oriental, siya ang atong technical. Wala lang siya nakakuyog karon. Oh, so napo sa Nima 4X. Ang Funay Electric is very grabe ka strict tungod sa ilang compliance, but we serve Nima 4X fabrication sa ilaha. So ang installation namo diri, sister company gihapon, ang RAB Construction. So sa DFA Region 7, Pacific Mall, Mandawi, no, sa atong mga amigo dito sa Cebu, ang Trifle Well sa Lahug. Then we have IT Park, TGU Tower. Asa na sir? Nakasunod na sa ako sir? Limkit kay pa lang na sir. Okay. Limkit kay pa lang di ay. So, sorry. Ano lang sir, fast track na lang. Yan. IT Park, yan. IT Park, TGU Tower, Apas Lahog, Cebu City. So naadiha sa IT Park ang pinakadaghan na mga building karon, nakasulod ta diha sa ilaha. So natay transformer pod, dry type at saka oil type, no. Nakita nato Nima 1 kWh. So nakasupply po ta sa mga Nissan showroom, sa mga Nissan sa Utis, Paco, Manila, Alabang, Makati City, sa Gili, Mandawi. So ang ano diha, ang Fortune Builders mao'y nakatabang nato diha. So ang Meridian Tower karon sa Mabulo, sa pinakataas po na building, nakasupply ta og cable ladder, vertical, horizontal karon. Sa Panglao, sa Bohol, so we have MDP ni 3R. Then sa University of Cebu, main campus, through sa ating PEA kay Engineer Dennis Lopez, General Manager. So lahat ay mga ano pa noon, mga cable ladder. Pero sige lang, diha man gyud na magsugod. Next is our Mang Inasal, Hall Mang Inasal sa Manila. We have that. O ang ilado na hospital sa Cebu, ang Chonghua Hospital. We have panel boards, Nima 4X, power panel, main distribution panel. Ang contact person nato diha ay waylain kundi si Sir Dijus o even si Sir Brian Pasilan. Next is sa Milk Tea sa Mactan. Sa SMDC Iloilo, medyo dako kayo na siya sa SMDC Iloilo through Pilmacro Development sa Cebu. Okay, sa T-Shine Hotel sa Mactan, this is Korean company, they use basta Koreano, they use LS. Next. Our Gaisano Super Mactan sa Mactan gihapon, no? Built by Equilibrium Engineering. So mga ano naman, mga hot dip para dili mataya ang mga horizontal and ladder hot dip. Balamban Commercial, yan ang medyo bago karon na center sa Cebu pag moadto mo sa Kulon. Na ay iconic center bago na siya karon direkto gyud mismo sa atbang sa Colonnade. Mao na siya bago dito na talan-awon iconic. So kita nakasupply diha sa Snyder, all their mechanic, electrical, MDP, ETS, MTS, yan, kumplito. Then sa primary structure, so kakaiba mo sa primary structure, salamat 1 year ago na-approve mi sa primary structure sa Almon, Talisay, Minganilla, lahat ng mga dagko nila ng mga company. Thank you sa pag-lead ni Engineer Rafael Ryan, karon PE na sad siya. Sa Roma Condominium sa Lapu-Lapu City, niya ang Unitech Builders mausasad sa pinakadako nato na partners. Sa pinakadako pad nato na mining sa Coral Bay sa Palawan. To be led by HBL Engineering sa Cebu City by Engineer Jeffrey Glico ang atong sa HBL. Sa Fuji brand. Medyo lisod mi anak kay nangita gyud mi ana sa Fuji brand pero salamat kay nakakita gyud. Timely siya sa pandemic, nakatabang gyud siya. Okay, sa Mapulip. Mapulip is bago na siya na hotel sa Banawa, RMT gihapon, LBSG, Himmel brand ang ilang gi-order, so 2,000 ampere. So natay freestanding, 5 cubicle, then dako gyud siya kaayo. Then sa Suda Escapade sa Hudson Mactan Island, so mao ni siya ang problema namo sa Mactan kay pangitaunon kay naay relay protection. But anyway, nasulbad sad ETS MDP 400 ampere. Okay, sunod ana sir is ang IPI. So lahat ng mga nagagamit og alcohol diha na IPI sa Mabulo. So EGS Multi-Victor Solution kay Engineer Erwin Salvador. Salamat sir. Cable ladder NIMA 3R, NIMA 4X o mga panel boards. Og so far, thank God sa Friends Warehouse. Karon ang Friends Warehouse diri sa Samoa ni kuha karon sa Camotes Island, sa Tanawan, Tacloban, Leyte, sa Dibcon Structure Incorporation kay Engineer William Serdan. Okay, so ETS, MTS, ang Camotes dai namo nagkadunay problema but pag-abot sa technical ayo mo kabalaka kay amo gyud ipatawag ang technical padung sa inyong site, padung sa inyong lugar og dunay problema to troubleshoot. Okay? So ayaw kabalaka about sa technical kay dali ra kay na eroplano ra na, di na siya lugay. O bagong talan-awon karon sa Monterrasas Residence sa mga Mountain View, napunta diya sa Monterrasas, daghang tay na suplayan. Then Pacific Traders Warehouse sa Tayud. Dool sa mga katong dito sa NIMA 4X sa Tayud, puro na siya mga NIMA 4X. Rafi Foundation by HBL Engineering, napod sila yung mga MTS na Samoa na order. Citywide construction still work, so muragdako-dako ni sila. No? Ay kabala ka, habang nagkao mo diya, hapit naman kumahuman. Ako gi-proud na ako to present to you the Argao Beach Resort because of GBR, our General Manager Sir Brian ni amang karon sa GBR Electromechanical Services. We have Engineer Brian Pasilan, PE. NIMA 4X pagyod ang ilang gi-order. So medyo dako-dako gyud siya tungod kay nindot man gyud pod ang NIMA 4X. Okay, sa Naga City Nature's Park, pag moadto mo sa Nature's Park sa Naga City, nagyod kayo kita nag-supply diha og mga panels. University of Cebu Extension by Engineer Ray Jubay, padung na sad ni siyang PEE. ICCT Colleges even sa Caloocan, even sa ano di ay UST Manila, diri po sila nagkuha sa Dungay. Ni kiniho bago lang ni siya, bago ko nila kaw nag-PO jud sa La Nueva Inayawan, Cebu City sa kay Sir Engineer Marcelo Canitan Jr. So nag-order siya og MDP, MTS, panel board, ECB. So Snyder brand. Sagol-sagol, no? Key Engineering sa Manila ni siya. Manila siya na part. Yung Skyrise ay meron ni siya sa Cagayan de Oro, sa Cebu, sa Manila. Dako-dako ni siyang Cagayan de Oro ang Skyrise Builders. Okay, so for your information, ang mao ni siya ang among mga address. Next, sir. Wala pa man ako gipang butang diri ang sa Luzon na projects, pero dako-dako siya. So far, kung karon nakaibaw mo sa dungay, ako kamong gihagit na sulayi gyud niyan dungay. Kay para makita nato na the Filipino company will rise up today kay para nasad kita magkinabangay, especially diri sa Mindanao. So, thank God kay nakaari ko diri. So, gitabangan ko ni Sir Brian Pasilan to talk with Ayi kay Kuya Ariel Galindo na para maka-sponsor sa inyo. So, it's our privilege and honor na to serve IEE bisag asa sa Philippines kay mao ni siya. So mao ni siya ang among mission gyud na so far pag maadto mo Manila, just tell me kay pwede gyud ta maka plant visit. So hopefully sa Mindanao mag-open may karon sa by this month, ma-open mi sa Davao, Dungay Davao. Cagayan de Oro is F&L existing na siya. So na siya sa sa Caloocan sa monumento. Paglapas nimo ng monumento, diretso lang gamay padung sa Karuhatan. Nya pagliko nimo na malabunso, so nana diha ang dungay. So walay lisod pag-abot sa transportation, kaya gyud nato ma-deliver on time basta ayaw lang gyud ko in taon ilapas sa timeline. Kanang ayaw tawon og dinalian kay magkayamuka ta ana og atong dinalian electricity ra ba ni siya. So ato gini siyang tarungon. So far as of now, mao ni siya ang akong presentation na akong gigiarian na hopefully someday somehow balik-balik na ko diri sa Mindanao tungod sa ato mga transaction. Og daghang salamat sa inyong panahon og sa inyong oras na gipapil mi ninyo hopefully og wala pa mo yung mga information about calling card sa kuha. Just ask calling card. Nahurot naman gud ang akong catalog, mga brochures o ang akong mags. Pasensya na kay gitry na ko try to travel to Cebu. Wa na ako nag-eroplano, nag-bus gid ko, nagbarko og bus. Pero timbog ata nya na ako duol-duol ra, na ako 6 ra di ay layo man day kayo. Mo na gihangak gid ko nya. Salamat naka mga ikong dispensa kung wala ko kaayog daghan mga previous. But by the way, paabot niya ang panahon. Pagbalik na ko, og imbitahon ko ninyo balik sa Samba Sulta. Willing to na ma-invite mi ninyo para next time makaandam ko. Hello, okay ba 'yon? Okay ba? So, hopefully masabtan namin ninyo. Og dako kayo mong pasalamat na kay Sir Ku na yun mi gi-invite especially sa mga participants na you are there to support us. So, dagang salamat og God bless Samba Sulta IIEE og see you next year og see you in the top. God bless po.
Thank you, Engineer Ro Gomez Dalanon. At this juncture, we are going to entertain only 1 or 2 questions. So, do you have any questions po? Clarifications? So, I guess there's none. So, we could proceed to the
Awarding of the certificate. So at this juncture, may we call on our 2022 Zamba Sulta Chapter VP Internal, Engineer Joseph P. Makindang. A round of applause, please.
Kung I, Panel Board, Public Authority, grateful recognition of their invaluable contribution to the Institute of Integrated Electrical Engineers of the Philippines Incorporated, a sponsored technical presenter during the 9th Western Mindanao Regional Conference with the theme, Leadership, Rising Above Adversity, Passion and Commitment Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur, Martian Garden Hotel, Zamboanga City. Given this 8th day of October 2022, signed by Engineer Mark Antonio Sebastian, President, Sambasuta Chapter, and Engineer Alexander Dico, Governor for Western Mindanao.
All right. Once again, thank you, Engineer Ro Gomez Dalanan. As for our next guest speaker, we would like to inform you that you are given 1 hour for your presentation. If you hear this sound, you only have 10 minutes to wrap up your presentation. To present to us a technical seminar on the interconnection facility study, let us all welcome our guest speaker, who is our 2009 Northern Mindanao Regional Governor. Let's give a big round of applause for Engineer Marlon F. Parrot. Once again, a round of applause, please.
Mic test. Hello. Hinay kaayo, murag ka gutom. Hello.
Hi!
Ana. First of all, I would like to congratulate our regional governor, Alex, and our host chapter president, si Mark, as well as the support of our other chapters from Zamboanga del Sur. Ito naman tong grupo sa Zamboanga del Sur. Then you have sa mga Sibugay and Zamboanga del Norte and Misamis Occidental. Nabit, ikan so Samis, good, ma'am. Nakita ta. Walang ko kabot sa Samis, naramang ko Aurora. Tago na ko diya sa bukid. So, I was called up by Gov. Alex to deliver something na mahipaluang daw dire. Now, pagkakaroon ka rin, tigulang-gulang na ta, my work is on something dili na usual sa una. So, I don't know if most of you have heard about the interconnection facility study. Sa una, way back 1980s, 81, 82, dyan kita sa WEMSO, wala ko kadung aning unsa ni siya. Ko kabalo karon nga tigulang na ta kabalo ta namre kwarta dinhi. No? Muna importante nga naa kwarta aning atong i-present karon. Hopefully somebody from the group will learn something about sa kamay lang kasi it's always satisfying to find and know somebody later on. Ano bitang makakuha gamay sa imong istorya diri bahalag nagakaon mo karon. Kasi way back 2008 I was asked by Sis Puruganan Nuemso to speak about something in front of the WEMSO honor students ana nga batch 2008. So I discussed something about how to succeed. Then I discussed something about DHWD. I don't know sa inyong past diri naabay na kinundom og DHWD during that time, bakit siguro. But isa ka tao way back before pandemic 2019 nagkita mi sa airport. Kailan niya kay tanon pagod siya. So siya approach me, sir. UM suyo. Kabar? Remember sir DHWD? Ako. So for me, naagyo day isa ka tawo nga nakibalo sa remember sa akong speech kay kung mas DHW that is about determination, hard work and discipline. So sa po na for the young ones now that are trying their best to prove their worth as an electrical engineer, hopefully 5 years from now, ay kwartaan eh. That is why I told Bob Alex I will discuss something that I have been doing for the past 6 years. Hopefully you can get something out of this one because you can do this para pa ng offline. You just have to study the some of the subjects kasi wala na sa ato ang
undergraduate studies, some of this can be taken from the literatures, and some of this, most of it, is from our experience. So I submitted this one so that it can be incorporated in the handouts katong sa ano, pero I think murag wala ko nakita gabi eh. So another question facility study is a report submitted to the grid operator. I will discuss the grid operator with the in GCP at ano lang fukon distribution utility or electric cooperative, no? This is undertaken kung if you are going to construct now a generation project, including the solar projects, I think it is up to 100 kilowatts because you have net metering. Some of the utilities, some of the DOs are requiring facility study and the system impact study. Tandem na silang duha. You have the system impact study and you have the facility study. So it is, as we go along, you can see it is part of the grid code and the part of the distribution code. The grid code is for the transmission. The distribution is mga utilities sa co-op. That is the one that is being followed. So the company, the generation concerned company encapsulates all the mandatory facilities and their facility-specific requirements. Facility-specific meaning those facilities that are needed for their generation, for their plant. Then the study covers the different apparatus and equipment needed for a safe and reliable interconnection at the maximum capacity of generating asset, including the study as well as the adequate protection of the system. This one is very important to maintain stability. During operation, to avoid unwarranted disturbance of the grid and other directly or indirectly connected installations, in case the generation facility encounters faults or problems while supplying power. This one is very important, approval. You have to prepare the study so that the entity, NDCP or the DOs or the ECs will approve it. Next, Sir Woody. Yan. So as I have said, it is part of the grid code. So according to the grid code requirement, that is procedure under GCR 4.3, under connection agreement. Any user seeking a new connection to the grid shall secure the required connection agreement. So that connection agreement is a document where you have to comply all the requirements by in GCP, for example, na kung sa NDCP, you have the list of all the requirements before you will be given you will have the connection agreement. And one of that is the interconnection facility study. Then under 4.3.1.2, the connection agreement shall include provisions for the submission of information and reports, safety rules, the test, commissioning programs, electrical diagrams. Then everything will be submitted to ERC for their assessment. That is just part of the process sa connection agreement. The connection agreement, the document that NDCP will require you, takhan ka na siya mga sub-compliances. Next, sir. So this one. Tandem na ang system impact study and the facility study. By the way, kayo sa kanang interconnection facility study, kasi namin nakadungog na be before karon. No? Gamay ra. Na ay ang uban ay no kanang mga DUs 3-4 years ago kami ni Ken, president karon sa Sibugay, we submitted a study katong sa hydro dire sa it's part of Vitali under Ever Hydro. We prepared it. So nakabalo na sila, pero the others murag basig karon pa mo nakabalo, but this is naay kwarta din he. Akong ingon ninyo, naay kwarta din he. Ang kwarta pod ani dire dili sinsilyo. Mind you, dili sinsilyo. Okay. So the transmission provider shall develop and maintain a set of required technical planning studies for evaluating the impact on the grid of any proposed connection or modification to an existing connection. These planning studies shall be completed within a period prescribed by ERC.
The transmission network provider shall treat this period as the maximum acceptable planning duration. Sa ato karon isa lang man. We have only NGCP. So you go to NGCP, you write a letter for regarding your project, but you'll be required to have the system impact study. Now, that system impact study and the facility study, na siya duration. Say for example, you will be given 2 years to complete the study. Kasi sa horizon, sa planning horizon sa NGCP, kana nga 2 years, if you have, say for example, you are going to put up a 50 megawatt plant, then you have identified the location. NGCP will provide you a 2-year, say for example lang, 2-year study period to submit to comply. Because it might be that in the 3rd year, NGCP will have another improvement, will have another line along the location or near the location that you are going to put up the project. So the timing is required by ERC. And I have 2 projects na which was given in 2012 to conduct the facility study up to 2015. Come 2015, wala, nahuman 2017. And there were already improvements along the Tayabas, Naga, 230 upgraded. So, ang facility study, you spent around 7-8 million, tapos isubmit. Then they have to redo, postpone na pod because of the lapse na, naglapse. So, importante is to comply the study within a specific time frame as mandated by ERC. So under 4.3.3.2, the transmission network provider shall specify which of the planning studies described. It's an GP 5.3 is an attachment of the Philippine Grid Code. So in GCP, in this case kasi sa grid, in GCP lang man yuta, part of that will be the interconnection facility study, tandem system impact study. I don't know if some of you have already attended some of the lectures provided for system impact study. I know si Primo Beltran is giving lectures on system impact study. Hopefully, some of you can attend so that you can have at least a grasp. Nalang kay idea, silang kita idea how a system study is being done and the requirements. We have 4 for system impact study. We have at least 4 aspects, no? Okay, Sir Woody, next. So here also in the Philippine Distribution Code, this is for the co-ops, for the cooperatives. Enante for NGCP. For portion lang say, this is the portion wherein it requires the studies, no? So under 4.3 of the Philippine Grid Code, procedures for distribution, connection, or modification. Any user seeking, igual-igual lang masay kung igual-igual lang ang wording, but it is distribution code. Any user seeking a new connection to the distribution system shall secure the required connection agreement. So, the same, na NGCP, connection agreement, sa distribution utility, connection agreement. So with the distributor prior to actual connection. The connection agreement shall include provisions for the submission of information and reports, safety rules, mamao lang, no? Test, commissioning programs, electrical diagrams, statement of readiness to connect, then certificate of approval to connect, and other requirements by the ERC. So the wordings, igual-igual lang, bisinos lang sila, but the one is Philippine Distribution Code and the other one is Philippine Grid Code. Okay. So here under the PDC 2016, 4.3.3 distribution impact studies. So the distribution utilities shall develop and maintain a set of required technical studies for evaluating the impact on the distribution system of any proposed connection or modification. So it is either a new connection or a modification of an existing line. We have one in our proposal in Samsoreco 2 is to, Kenneth is here, so we have a single line 13A upgraded to 3-phase going towards the plant in, that is just an example. So it might be that if you have, for the grid, in GCP, you can have a 69 kV line, you might have to upgrade it to 138 in case of
here in Mindanao. Na-detect na, upasa, may pa sir. Stikol ka lang. Kumain ka na? Ako sir, hindi pa, mamaya ba? So the technical studies required under section 4.3.3.1 shall be completed within the period. So this is important. If you are given a time frame by ERC or the utility, you have to comply within that period because we do not know the modifications or upgrading of the line where you are going to connect. No, the distribution utility shall treat this period as the maximum acceptable impact study duration. In cases where the distribution utility is unable to complete the distribution impact study within the time specified, it shall notify the proponent. Kaya baka, if you are going, as I've told a while ago, if your study will lapse, it might be that you are going to spend another one. Kasi revise, redo. Yes, sir. Next page. So this is part of the EBOS ng NGCP. May taga NGCP dito. So this is part. Wala man tayo, ano. So under next tandem for NGCP, you have the system impact study. Meron kang ganon? Meron. You have the system impact study, then lower is the facility study. Then you have the connection agreement. That is why the connection agreement is only granted, is only approved and given by NGCP. Ano to, sir? Wala. Makita ba nyo dyan? Ituro natin. Ano ba yan? Paano ba yan? Ibabaw sa itaas. Hindi maklaro. So, ayun na lang. Green kasi yan eh. As you consider, under NGCP, you have the system impact study. Next is the facility study. Before that, after that is the connection agreement. That is why, as stated before a while ago, yung connection agreement, you have to have the interconnection facility study approved before the connection agreement. Yes, sir. Under EBOS yan ha. Yung NGCP kasi ngayon, ang NGCP, you have the online, no? Virtual na sila. Energy virtual one-stop shop. You don't have to go there personally to apply and submit the documents. Through their EBOS, you submit virtually everything so that they can assess. Yes, sir. Next page, sir. Here. So this is step 3 of the grid connection procedure of NGCP, system impact study. So NGCP conducts or review the technical studies, the system impact study to determine the adequacy. As I've told you, if you want to have some idea on how a system impact study is done, the IIE National Office is conducting some seminars about SIS. So hopefully you can Woody, magkano ba yung ano natin? 300 lang online? Mga seminars natin online? Mga 300 lang? 100. Oh, so ano lang? 2 voting beer lang yan. So if you can spare that, so that you can just have a parang ano lang idea of how the system impact study is done. So for facility study, at least you can have an overview now how it is being done. So the facility study is to determine the bonification of NGCP facilities. An example of this one is we have a project in along Pagbilao for a 1,200 megawatt project. That's why it was given an approval in 2012 to finish the facility study in 2015, but the study was completed in 2017, so medyo nag-lapse. And here comes NGCP. Sabi ng NGCP, we have already modified an upgraded line going Nagatayabas, and we are going to do the 500 kV. So instead of the 230 kV na as prepared in the interconnection facility study, na mag-iba na naman because the time granted for the study naglapse na. So si planta will have to, there are already existing ongoing construction now for the receiving structures, pero the facility study nag-usap na po, nag-revise. Okay, so that's why si NGCP, once you have already approved, finished the studies, you will submit it to NGCP, then they are given around 3 months to make the assessment, then approval or disapproval or revision. Okay, so request for interconnection to the NGCP or the DO, we will say the operator, shall be in accordance with the reliability requirements and standard utility practices. The proposed interconnection shall not downgrade the reliability of the existing system. That is the purpose. You have an existing system, then you are going to connect. So you have to specify, sample, the sizes of the wires, natural na, then what are the breakers, the sizes, and the connection point. All arrangements for system studies, engineering design, construction, ownership, operation, maintenance, replacement equipment, and metering. Importante ng metering kasi naadihang kwarta. No? Facility controls and telecommunication shall be agreed between the operator and the applicant. Si NGCP, based on my experience, hindi masyadong problema, although they are going to give you the basic requirements, basic specifications for their SCADA, for the breakers, 230 or 138. So not much of, unless you have special requirements for the plant. No? Then you have the cost associated with the connection facilities. Initially, if your generator is only one, that is intended body sa'yo lang talaga, that will be a dedicated line for your plant. Unless there will be another plant that will be connected to that line, then it will be reclassified by NGCP into a transmission asset. So the operation and the maintenance in the facility study should be only charged. Meaning, ang gastos is for you only. Bali, ikaw ang charge niyan. Now, unless it is reclassified, then the expenses for the operation and maintenance will be under you. Next, sir. So, ito yung mga requirements. So, natural, if you are the applicant, you should have a close coordination with the co-op or the NGCP kasi you are going to request data. Say, for example, unsa kadak-an ng linya na adiha, unsay mga breaker na adiha. So you have to work closely with the operator, the DO or the NGCP. So number 2, as I've said, it is in tandem with the system impact study. Shall be required to evaluate the electrical system performance of transmission system with the requested facility connection on some of the alternatives to demonstrate adherence to established reliability criteria. More or less, ang DIOs, they have their own set of reliability criteria kasi naaman si NEA, but si NGCP, sila lang yun na. You have to follow their requirements. After approval of the system impact study, a facility study shall be required to determine the detailed facility interconnection requirements. The facility study shall identify direct assignment facilities, network upgrades, cost estimates, and typical construction requirements. Next page, sir. Then you have the evaluation of alternatives to the requested facility connection. There are instances wherein the gantry or the substation receiving structures of the operator might not be able to accommodate. So in our project in Cagayan, what we did was to purchase the adjacent plot and construct the receiving structures. Kasi paminsan si NGCP, wala lang na available bay. You cannot connect. So we purchased the adjacent plot. Those are some of the options. Pag sabi ni NGCP or your operator, wala na kaming bay available. So you have to look around the area, sabihin mo, we have to negotiate yung the nearest, kasi you have to connect the nearest lot na wherein you can connect to the facility of NGCP or your operator, you better negotiate or else lalaki ang gastos. The transmission planning process for a proposed new facility connection shall also be included, coordinated in the studies with all entities. In all interconnection studies, it is important to monitor neighboring systems for criteria violations such as overloads or voltage criteria violations to determine if the proposed facility results in any impacts on neighboring systems. All interconnection reports should document the impacts on the neighboring systems. I have a project in 2019 before the pandemic in Leyte. There was already an approved facility study wherein the 70 megawatt plant will cut in. Sabi nila cut in kasi may cut out, may ano yung term in GCP, wherein they are going to cut the line, a double circuit 128 kV line. Tapos you have a tension structure, then you have a suspension structure, suspension tower, you have the other one is suspension. And they are going to cut in between the suspension and the tension structure. I don't know why it was approved, but the district in Leyte, the district personnel in Leyte did not approve of how it is to be done because only one phase, it is only one circuit is to be cut, the other circuit is live. So it took 9 months for the contractor and they were not able to proceed with the connection of the ancillary facility. So we have a problem on why did this facility study was approved when in fact it is problematic. So that is what you mean. You have to study. It is connected. The other line is connected by PASAR. The other one is for the Leyte grid. So those are things that should be included in the studies, no? The neighboring loads or the neighboring generating capacities. Next, sir. So the applicant shall be responsible for resolving any impacts prior to implementation. So one of that is the right of way. So in the facility studies also you consider yung mga ruta. Ano yung dadaanan if there will be example, yung pinakamahirap is if there are existing lines na mag-cross, not much with if the lines will be going along, pero if it will cross, you have to resolve how it is to be done, whether overhead or underground. So you include that in the facility study. So basic, mura na siya, executive summary, overview of what you are going to do. You tell the narrative. In the narrative, you express the probable contents of the facility study. Then the next is the introduction. And you introduce the company. So for example, the company is a joint venture 60-40 solar for Alpha Solar Project, 50 megawatt located in some place. Hopefully, this will alleviate the voltage supply or the voltage fluctuation and the additional supply, sort of thing for the introduction of the company. Next, sir. These are the parts. Then you have the location and the connection point. The connection point is very important because in the connection point, that is usually where your billing meter is. And as I have said, ang billing meter, ang pinaka-importante, that is where the money is. So the lesser is your losses along your interconnection line, the better. So it is in the connection point. May CNGCP or the DO will tell you, dito yung connection point natin. So that is where you are going to put your breakers because according to the grid code, at the connection point, you have your breaker. So you have to prepare the single line diagram. No? Then next is the interconnection facilities. Dito na. So you prepare the single line diagram saan ka mag-tap. Then the different data, breaker switch configuration. So what is the breaker configuration? Usually we have now, in our the present time, ano lang naman, you have the radial and usually the breaker and a half scheme. So you discuss and what are the ratings. Next, sir. So basic na, no? You have the megawatt inverter capacity or the demand at the connection point. Sa connection point, not at the generator side. So including any special operation consideration or constraints. Then transformer data, the basic winding configurations, voltage levels, thermal rating, available tap ranges. Then generator, sa imuhang generator side, nameplate. And this data also will be used in the system of study. That's why tandem yun na silang duha. Then you have the generator, rotor, governor, the data, everything. Generator, megawatt, and bar levels. Next, sir. Itong transmission line configuration, usually ang rating dyan is to be given by the operator, CDO or si NGCP. As I've told you, they are going to tell you, dito ka mag-tap sa 138. Then you make the study within 2 years. After that, baka may upgrading kami, gawing to 30 as in the case of our Nagatayabas project. So we studied initially at 230, then later on, in 2017, naging 500. So, iba na naman. Then breaker arrangement. So, ikaw nang bahala. The least cost. No? Ang pinaka-mura, pinaka-barato. Kung pwede lang palagi radial, kasi yun ang mura, but you cannot always make radial. You don't have any flexibility. Then next, 4.8, breaker ratings and surge protection. So, sa amin, sa case, actually, sa NGCP, you just have to follow the requirements. Sa DO naman, we usually have, kasi we ask data from the DO, from the distribution utility for the ECs. We discuss with them, is this breaker brand or is this breaker rating suitable? Yung initial mo lang ha, initial pa yan. You are preparing your report. Yan ang mga, that is one of the techniques. Or else, you are going to design and specify your own. Pagkatapos, when you go to NGCP and you go to DO, sa DO, hindi sir, mababa yan. O, mababa yung rating na yan. O, ang specs na yan. We are not using that one anymore. 19 kupong-kupong pa. So, it's better that during your studies, you coordinate with the NGCP and the DO so that more or less, harmonize na yung data mo. O ano yung nalagay dyan? Anong kaik yan? Ito ba? Pwede. O, so, hindi na malalayo. Or else your study will be parang nagde-design ka talaga from the very beginning. Wala na. Shortcut na. Next, sir. Then, this one. Very important yung protection system coordination. That is why you have your facility study. After that, in the project implementation, si NGCP, in the case NGCP, very strict. So you have yung relaying team nila will have different yung loop test before your generator is can be placed online, before testing, before commissioning. So ilang days yan testing of the coordination of the protection system. No? Operator shall not assume responsibility, meaning the NGCP or the DO shall not assume any responsibility for protection of the generator mo yan. So you have to, within the generator premises, it's your setting, but that setting should be coordinated with the setting of the operator, the NGCP or the DO. Okay? So, ayaw nila yan. No? Any disturbance or damage that will be brought by say for example, mag-tank out yung generator, just like this, a perfect example was the case of yung sa Cagayan sa Villanueva na generator na nag-tank out 100 megawatts. So we have a total blackout of Mindanao, no? The generator na-tank out. Hindi coordinated yung relaying nila sa grid sa NGCP. So 100 megawatt nawala, biglang nawala, the whole of Mindanao went on blackout. Yes, sir. Next. Metering until all applicants current trust cities. Ang city ni DO or city ni NGCP, alamin mo na yung anong specs para hindi lalayo yung specs ng equipment mo, cities and PTs, no? The applicant shall be responsible for telecommunications facilities sufficient to meet operators' remote meter reading and EMS SCADA requirements. Now, you have in a small project in Caraga, a 145 turbulent small hydro. When we made the study, we made the study, katapos isinabit namin yung costing sa proponent, medyo umatras sila. We already finished the studies, medyo umatras kasi malayo na doon sa bundok yung small hydro, 145 kilowatt. Later on, when we submitted the costing, sabi nila, parang ang laki ng telecommunications and telemetering expenses natin sa percentage of the project. Until now, it is discussed by the proponent kasi medyo malaki nga. Tapos maliit lang yung planta, 145 kilowatt. Maliit talaga. Then, may nag-lecture natin yung grounding and safety issues. So this is important. Also, no? All interconnection equipment shall be operated and maintained in accordance with manufacturer's recommendations, then prudent utility practices and applicable environmental and safety standards. The interconnection substation shall have a ground grid that solidly grounds all metallic structures and other energized metallic equipment. This grid shall limit the ground potential gradients to such voltage and current levels that shall not endanger the safety of people or damage equipment located within or adjacent to the station under normal and fault conditions. So we have topics on the grounding. Siguro kahapon, we just follow all that provisions. Then you have insulation and insulation coordination. The applicant shall ensure that all equipment is adequately protected from excessive system over voltages. The facility study shall determine when a transmission line switching study, if needed, transient analysis part of the study. Such a study may be necessary to evaluate transient over voltages caused by switching operations and to achieve proper insulation coordination. The study shall determine basic BIL, search arrestor requirements, and breaker closing requirements for a proposed facility. Next, sir. Then we have this one. That is why, as I've said, you might be required, si operator will require you kung anong voltage ka magtatap, especially if there are multiple lines. Applicant may be required to install their own voltage regulation equipment and coordinate with voltage set limits with the normal transmission voltage bandwidth. In GCP, you have sa 69 from 60, Latumar, 68 to 72 or 69. Those are the bandwidths. The reactive power. Applicants' facilities shall produce or absorb reactive power in power factor set by operators. So kung mag-indion sa NDCP, ang power factor mo dapat 90, dapat you have to install your facility to maintain that power factor. Sample lang, no? Then you have the power factor control. Applicant may be required to install equipment for power factor control or the operator may construct it. So pwede si DO or if you don't have any power factor control, kasi delikado yun, if you cannot maintain your voltage, ang power factor mo mag-fluctuating. So si NDCP or si DO might have to install that equipment for you. Pero magbayad ka rin. Hindi yan libre. As always, especially pag si NDCP gagawa, babayaran mo rin yan. Remember that. So, hindi yan. Walang libre. Walang libre. Next, sir. Then you have the synchronizing facilities natural. Whether it will be controlled by you, mostly it is controlled by, for NGCP sa grid, it will be controlled by NGCP. Ayaw nila yung ikaw mag-control, ikaw papasok, lalabas. Hindi pwede yan. No? So, sync check relays shall be required on all breakers. The connection transmission facilities to the operator's transmission system and shall be utilized to supervise the closing of those breakers. Usually, ang supervision kay NGCP or kay DO yan. Sa kanila yan kasi that is their system. Then, for the towers, basically standard na yan. You cannot, or else if you have a special special type of towers na yung special type of foundation. Normally naman ngayon, we have CNGCP, they have their own specs. Kaano kakapal yung coating ng structures nila for galvanized. So meron na yan, those are standard, fairly standard. No? Including their grounding conductors and the all aluminum, or in your substation, sub-generation side, you can use the tubular or the all aluminum. Then you have the optical ground wire. For the maintenance and coordination in the studies, those are just initial because in the actual, yung nagawa na yung generating facility mo, there will be still several meetings prior to the establishment of this one, which is very important, yung maintenance. Now, we have project in Surigao, a 12 megawatt diesel plant. After we have energized and connected to the grid, wala may kabalo nga naman problema tong there was a portion of the 69 kV line nga wala pa din mabayre. So during the first 3 months na mga kahoy dito sa ilalom, no, there were already trees, mga growth ng trees. Dili mi kasulod gihanan mi og our group gihanan mi og pusil dito kay di mi kasulod kay wala na bayre. So those are small things that was not included in the studies kay wa man mi kabalong, wa man bayari. Wala man gibutang dito sa study nga wala ni bayari. So and also the switching and closing of all breakers dapat in the maintenance, the operator and the proponent should have close coordination. Nakasulat yan lahat. Everything should be written. Hindi pwedeng sabi niya ganito, ganyan. So everything should be written. Next, sir. Matagal pa yung ring. Bakit? Sino yung nagbabagting-bagting dyan? Huwag mo gigutom. Ako gigutom ko. Dalion na na eh. Next, sir. Operational issue. So, during operation, we have here the group of si Ray from NGCP. There are operational issues. So, establish nyo yan. No? The facility connection studies shall identify impacts, deficiencies, operational issues, including abnormal frequency and voltages, and evaluate potential solutions. Sa papel pa lang, sa planning. Study pa lang. A proposed facility connection shall not degrade the reliability or operating flexibility of the existing. Yan ang importante. That is why it should be included in the studies. Yung degradation ng grid. Yan ang importante. Then you have communications and procedures. Nakasulat yan lahat. During normal and emergency operating conditions. Yan lahat. So, in the preparation of the interconnection facility study, kabaga-baga man kaya ng detalye sa example sa transformer, unsa na yung mga data diya, sa breaker, unsa yung mga data. You not include that in the content of the study. Usually, it is the annex. So that is why I placed there. Masayon siya nga, you say, the details and specifications of the breaker at the connection point is can be seen in Annex A of this study. So that is for each year, you are not going to include that na breaker, katapos specs, baga ka istanan, daghan. No? Yes, sir. Next. Marami pa yan, sir. Ito, example. So, kasi in the interconnection facility study, you are going to make your implementation. Portion lang na sa gihimo nako na, saan na siya? That was, kapan na siya? November 2019. So, this one is part of the approved interconnection facility study in Pangasinan. Portion lang na siya. So, you have to start. Kasi, financial. So, and the schedule. So, implementation is schedule, including first is the impact study, then you have the asset study, this one, facility study, then the engineering. So, these are just example. You provide there the number of days, kano sa mag-start, then kano sa nag-finish. So, this is an example of because this is also part of the facility study, yung implementation schedule. Para si NGCP, si ERC, will know your, see, for example, in 2024, you are going to put up a 100 megawatt plant in somewhere in Ipil. So kabalo sila nga naami butang mo na ang schedule. And more or less, every 6 months, they are going to kulit-kulit sa imo. Oy, engineer, anong nangyari? O Mr. Proponent, what is happening to your generator? Not only for their own consumption, but especially if the project is big, 600, 500 megawatt, there is a significance on the supply on the national level. Not only for their nagtrabaho sila, but it is the significance of that generating facility in relation to the supply. No, muna siyang kulit na sila sa inyo. Na if you are not on time and if there are problems, the pandemic na delayed kag pa, so that is reasonable, no? Next, sir. Ano pa yung next dyan? Estimates. So you have, this is part, yung estimates sa facility study. Implementation schedule, yun the estimate. Ito mga, this one is for a, I don't know, for this time, kung medyo malapit ba itong mga prices. So, okay pa ng presyo hato? Barato ra. This was a project in 2019. So, this is already approved by Panel Co 3. So, muna, you are going to silingan na estimate or an estimate na maugod sa market price because your client will tell you, oy, medyo mababa or medyo malaki yung price mo. So, and also the utility, magsabi sa'yo na, oy, parang mura yung presyo mo or mahal yung presyo mo. So, it is not within a certain range, market price. Okay? So, nandyan yan. It's just an example. Magdakan na siya kayo. Costing. Conclusion, natural, sa libro na po yung conclusion. Sa imong report, you have the conclusion, but the conclusion should be well written so that si operator, si NGCP or DDO, mag-believe sa imuha. And it will, in the studies, in your presentation, what you are going to do or what you are after is the approval and the endorsement. Because without the approval and endorsement of your study, wala, you are not going to go to the next step. Sa NGCP side, you cannot have your connection agreement. If the facility study, although they are going to advise you, this portion is to be revised. Parang ganon. This rating is to be revised. Parang ganon lang yan. So, ang sa akin, hopefully, some of you will learn some of these things na, mind you, doing this thing is dili na barya-barya. Pwede tanin, manguyab og pito ka buok. Minaw si Mamo. Sabot baka Ma'am unsay uyab? Saya ka, Ma'am? Okay, so, sir, ano moderator? Human naman dain. Muchísimas gracias na. So, if you have, sir, question pa, sir, wala na. Pwede pa mag-question sila? May tagula na. Pwede pa? Sige. Sir, if you have some questions, ilang ka minutes? Yes, sir. Yes, sir. Yes, sir. Ayaw, gisura namin question, kaya gutom ba ako? Klaro kayo negosyante ba? Napatay mga customer online ana sir basi mabukot ana imong question. Narabay BIR nagkuan, nabay BIR nga BIR na minaw. Facility study. Yeah. There are before the process in the interconnection facility studies, you are going to make your proposal and you have to include everything. Diba? Distance sa location ng plant, then usually unsa kadako, so how many kilowatt, how many megawatts, Then you have the timeline. Kaya usahay,
Hello, here.
dali-dalion kag himo. Inon ka sa customer, can you finish this one in 2 months? So, those are the things. And there are ranges. There are costing considerations nga mga ibutang. So, magbari na siya. Usay dako-dako, usay gamay-gamay, pero dili sinsilyo. May dili sinsilyo. Na kami kay may grupo mo na. So, there are charges including taxes. Na siya. Ay na lang kag pangutana og tagpila kay basing mingon niya ako 100 million ingon mo BIR yawa ni kumre ng income impasta. Okay sir. Gipanggutom na sila apil ko. Yes sir, yes sir. Usa ni mga tigulang may question ani I was expecting nga kaning mga batanon na mga tigulang mag-question.
Good afternoon.
Yes sir.
Usually sa SIS, after completing the data, we need to do some computer simulations to see the effect of the new system into the existing. And my question is, who shall do the computer simulations, the operator or the applicant?
Usually now, kwarta gihapon na kay system impact study separate man ang kwarta. Basta tigulang lang ita kwarta-kwarta naman kuna. The system impact study is to be done. You should have an application because ERC or the DOE now si DOE you have to go to DOE and process all your application requirements. Then you have to coordinate sa grid. Usually sa grid, you have to go to NGCP. You will be given the timeline because you are going to get the data. Example sa Luzon, you have to get the data from the entire Luzon grid. Sa una, NGCP is charging you, I don't know, it's around 200,000 to get the data. So there's a third party, NGCP can do it. In the case of the DO, if they have the capability to do the system impact study, just like Davao Light, just like Meralco, they have the capability to do the system impact study, and they have the schedule to do it, so they will do it. Si NGCP, because of the numerous projects that they are facing, sometimes they will allow a accredited third party to do the system impact study. So, yan ang proseso. You'll be given the timeline. That's why if NGCP will tell you, 2 years lang you finish your study, or else there might be another changes in the configuration of the line. That's why we have a case nga that we have a problem nag-lapse ang study, ang lapse on the duration. So usually, for your question, it is usually sa NGCP now, sila gumagawa, but they allow accredited third party to do the system impact study and the interconnection facility study. Kaya mga batanon po, natulog ni mga batanon siguro, huwag mo kasabot. Kung may question nyo, mga tigulang mag-question. Dali, yes sir, 5 minutes sir. Tagadian mo ka sir. Kasambuang gara. Ito sir, ito.
Good afternoon, sir.
Afternoon.
Francisco po. Yung question ko, sir, regarding sa DIS, regarding doon, kasi sa solar industry po ako, normally, nag-apply kami for the accreditation sa ERC.
To do
No.
application project. Okay.
So, para sa sa compliance sa ERC. So, yung DIS, normally sa net metering, ay sa solar application, they require the DIS, yung mga PU. Pero instances mga yung higher than 100 kilowatt peak sa solar, say 100 and 200, 500 kilowatt, or maybe 500 kilowatt and plus. Does this require DIS pa rin, sir?
If the net
naman, sir.
If sa net metering up to 100 kilowatt it is needed, the more na kung ako si Dio, the more that I will require you. The more that I will require you. Kasi sa net metering, if you're going to apply net metering, you have to do the DIS. So the more that you have 250 to 100 kilowatt, the more that you will be required. Kasi mas malaki yung impact.
Sir, yung ruling kasi sir, ko sir, is 100 kilowatt and below. That's what's required na metering yung GIS. Pero yung 100 kilowatt and up, so we will apply sa DO yung tinatawag na self-generating facility or solar own use.
Own use, yes.
So, sa regard, pa-rin sa GIS, sir. Kasi own use naman,
Meaning to say, ang facility is for your own consumption. Walang...
consumption. And then, kung maglalagay tayo ng solar installation, nag-require din sir yung tinatawag na anti-export or yung
Yes. Oh.
current limiter. So,
I don't know kung siyong taga Samsoroy ko to, Samsoroy ko, ano, see if they require. But usually, yung sa ibang co-ops, they will require DIS and facility study. Kasi kung ako si co-op, I have to be sure that when you connect, whether it is for your own use, say for example, kung malaki yan, 1 megawatt yan, katapos yung transformer ko dito, malapit, mga 5 MVA lang. So there is an impact when kahit yung consumption mo sa'yo lang. So on the part of the DO, you cannot claim that they are going to require you a DIS or the DAS. Kasi I have to be sure that when you operate, walang operate or mag-operate ka katapos normally or abnormal conditions, babagsak, lalabas. Although sa consumption mo yan. So yung sinasabi, for example, solar, for DDO, it is better. Bakit? Nire-require talaga kayo?
para sa ano lang sir, ERC compliance. Okay, we will submit.
Hindi naman si ERC kasi si ERC naman, they will receive the documents. Anong sabihin ni DO sa inyo? Yun ang susundin nyo eh.
The problem is sir, gaya dito sa local DO natin, walang pa silang capability to do GIS.
O, yung taga-Samselco dyan, naririnig ng taga-Samselco, ano, birahan yung taga-Samselco. You can settle all those things actually with the DO. Yung sa project mo, although that is on use, but kung ako si DO, I will require you all the standard studies, especially kung malaki. Kahit on use yan, ha? Kahit on use.
Follow up on the question. Knowing kasi nag-apply ko sa Samselco, they're not capable pa sa GIS. It's not acceptable from them to
Yes,
third party.
ang Samselco?
Yes, sir.
We can do it. Kung hindi kaya nila, the DIS, we can do it. Just, we will talk afterwards. Tingnan mo to, nanakoy customer to.
Gob.
Ayan tayo mamaya, sir. Okay. Ano yun, sir?
Hello, Gob.
Online? Yan, sir. Oh, yes, sir. Sige. Yes, sir. Oh, Gob. Yan, sa solar yan. Yes, sir. Go ahead.
Yeah, Gob. Naano ko kasi yung tanong para dun sa DU. It is a must kapag naka-grid connected ka, any solar installation, it is a must na mag-a-apply ka ng DIS. Kasi facility nila yon. Then, if that is 100 kilowatt and below, you apply for net metering. Ngayon, kung ayaw mo mag-apply, you have to apply for zero export. That is, so either of the two lang. Kaya pag more than 100 kilowatt, it is a must that you have to apply for a zero export or own use.
Yes, sir.
That is a must. Kapag hindi ka nag-apply, that is illegal. And that is very, very problema, sir. Baka masira mo yung distribution utility o kaya during power outage, meron ka lang limiter. Limiter is not the answer, no? Meron lumalabas po na napakalaki na voltahe, lalo na yung mga ganyan 200 kilowatt. I think that is a commercial industrial. 1,000 volts po yan. Kaya dapat, it is a must, either you apply for net metering or zero export. Salamat po.
Yes, sir. Thank you, sir. Tama talaga yan. So, sir, okay yan si Gob Hill. He is in the solar industry. Yes, sir. Wala na. Gigutom na ko. Okay na, ma'am.
And there we have it.
Congrats, Bob.
Thank you so much, Engineer Marlon Parot. Now, at this juncture, we are going to award the Certificate of Appreciation.
Okay, so again, we would like to call on the presence of our 2022 Zamba Sulta Chapter Officer, VP Internal Engineer Joseph P. Makindang, who award the plaque of appreciation.
Is hereby presented to Engineer Marlon Paro. Grateful recognition of his invaluable contribution to the created legal years of the Philippines Incorporated. As technical speaker during the 9th Western Mindanao Regional Conference with the theme Leadership, Rising Above Adversity Through Passion and Commitment, Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur Martian Garden Hotel, Zamboanga City, given this 8th day of October 2022. Signed by Engineer Mark Anthony U. Sebastian, Chapter President of Zamba Sulta, Engineer Alexander Dico, Governor for Western Mindanao.
Once again, thank you, Engineer Marlon Parot. At this point in time, for the information of everyone, there is an ongoing simultaneous activity, the chapter president's meeting from 1 to 3 p.m. at Barcelona Function Room, Martian Hotel. After which, an electrician's forum from 2 to 4 p.m. at Barcelona Function Room, Martian Garden Hotel.
Ayan. So at this point in time, may we call on Engineer Victor Labad, a solar development consultant at UGE International, to present to us the next technical seminar. A big round of applause for Engineer Victor Labad.
Mayong hapon sa tanan. And I promise I will not keep you. It's on my word. I will not keep you for more than 2 hours. Okay, just 15 minutes tops. My topic today is about climate change. Anybody familiar or already doing research on climate change? One thing I'd like to say is right in our generation, we have the greatest, biggest problem of all. And yet at the same time, we have the greatest, biggest opportunity of all. I represent UGE, Urban Green Energy. And we would like to say, I'm sure you know that climate change is happening right now. I just got back from the US 2013, hoping that I would start my retirement life. And then in Bohol, well, you knew what happened, the great earthquake of over 8.2 Richter scale. And then not after a few weeks from there was the great Haiyan monster storm. Ang climate change po ay hindi na panaginip o hindi na ishangkat-hang isip, but it is reality. And the worst thing about it is anthropogenic, meaning it is a problem caused by humans. And all over the place, hindi na, nandoon din ako, may bahay ako sa isla sa Mindanao, sa Surigao, Dinagat. Hindi na nila alam kung ito ay habagat o amihan. Nagkakagulo na po, no? When going out of berserk talaga itong ating situation ngayon. And alam ho natin na it is due to the current warming has increasingly posed considerable challenges to man and the environment. Yung na-capture yung heat, and I was talking to some of the engineering students here, And I wanted to tell you, climate change to me is like cancer. This past year and a half was probably my most sorrowful time of my life because my wife and I, our close friends that we thought were even healthier than we, went to be with the Lord because of cancer. But the problem with cancer is hindi nyo po alam, no? Lalong-lalo na kahit na nung previous year na meron na pala kayong cancer. At karamihan nung namatay kong mga kaibigan na mas bata pa naman sa akin, I mean, it's completely baffling. Ganun lang ho. Wala na sa tabi namin. Nung makita na nila, stage 4 na. Kaibigan namin sa Amerika, nakasakasama namin. Ngayon, pagbalik ko sa US, wala na siya doon. Yun hong aming mga kaibigan na kasing edad din namin dahil hindi mo alam na the previous years pala unti-unting kinakain na, unti-unting sinisira, unti-unting pinapatay. Ganon din po ang climate change. Actually, sa next picture po natin sa graph, ang intensification na for hundreds of years, Earth's average surface temperature steadily increasing. Over the last decade, this global heating appears palala ng palala. Since 1880, the global average temperature has risen to an average of 0.08 degrees centigrade every 10 years. And then over the last century, the last century and a half, there have been fluctuations in global surface temperatures, with some of the coolest years on record occurring in the late 19th century and early 20th century. Pero heto po ang kagimbal-gimbal, no? The last 2 decades, we have seen the unprecedented warming with the 10 warmest years on record occurring only for the last 20 years. So, siguro natandaan niyo yung Odette, natandaan niyo rin ho yung Haiyan, and how unprepared are we? Noong 2013, I was talking to the governor of Bohol. We've got to go solar. We've got to go renewables. Gawa ho tayo ng tinatawag nating microgrid. Let every LGU, let every municipality develop a microgrid. Hindi nakinig. And then, meron ho kaming in-install sa seminary sa Sinong taga Bohol dito? Na ba'y taga Bohol dire? Okay. Nag-install me of the very first hybrid solar to an evacuation center. Patuloy ho akong nagpipreach, about global warming, wala pa rin nakikinig. Boom, Odette. Pagdating ho nung sakuna, saan ho sila nagpunta para mag-recharge, magawa ng relief operation? Doon ho sa aming microgrid na pabuti naman finance ng Vatican. Kasi it's common sense, no? Palala ng palala na, hihintayin mo bang magkaroon na ka ng stage 4 cancer? I think this earth, as we all know, is, that's the reality of life. We're all dying. The planet is dying, but it doesn't mean na bubulagta ka na lang, wala ka nang gagawin. We can do something, friends. And in the Philippines, do you have any idea ilang factories we have in the country? Listen to this. We have over 24,000 factories. Every single year, day, billows of smoke i-release sa ating environment. So, ang dami ho tayong mga ordinansya ngayon. Marami na ho tayong, actually, iba, yung latest ni President Duterte, yung microgrid, no? Hindi ako makapaniwala, wow, sinabatas ito. Ang daming meron tayong GEOP na pwede na nating i-follow up yan, pero without mentioning any political thing, no? Nauuwi sa corruption eh. Kung talagang susundin natin ho yung GEOP, yung microgrid system, yung renewable energy, ito hong masasabi ko sa inyo, no? Sinabi ko kanina, the greatest problem, it is also the greatest opportunity. Meron tayong 500 engineers dito. Ito hong challenge, hindi lang sa UGE. Naniniwala ho ako na we are going to see the greatest paradigm shift in our economic and power industry. Kung saan nagsimula yung problema nating climate change way back in 1930s, di ba, nung umusbong yung machinery, development, pero hindi nila binigyang pansin ang waste. Hindi nila binigyang pansin ang consequences ng releasing ng mga dangerous gas. Pero ngayon, we are shifting from fossil fuel to renewable energy. Ang kinabitan ho namin sa, kunyari, Nature Spring, naka-save ho sila ng 30 to 40% ng kanilang kuryente. Pero ang aking tunay na kaligayahan, yung na-avoid na carbon dioxide. Dahil that is the only way when we can fight it. So ang aking hong challenge ngayon, siguro sa group na ito natin, sa aming company ho, no? Pero I'm sure lahat ng solar companies magtutulungan dahil pag pumutok ho itong renewable energy, I'm telling you, mangangarap ho tayong lahat. We need all the solar companies to come and band together. Sinong gustong kumita ng pera dito? Okay. Very good. Kung magre-refer kayo sa akin ng isang planta, manufacturing, whatever, mall, by the way, I just signed up 4 Shopwise malls in Parañaque and signing up the other malls for Centro Mall. If you can refer 1 megawatt, your commission is 1 million. Ay, hindi kayo excited ng 1 million, ano? Okay. So, siguro naman sa 500 engineers na ito, kaya nating ilikom ang 100 megawatt, di ba? Why? Dahil ngayon, ang aming umuuso na itong business model na we are pushing, which is called no cash out. We will install at no single cent dahil walang capex, no? So yung company, kahit na may pera sila, magagamit nila yung pera nila for other business purposes while they can begin to enjoy yung solar, saving them 30 to 40% sa kanilang bill over 20 years. Alam niyo ho, magkano ang tinataas ng kuryente every year? Nung wala pa itong mga kalokohang nangyayari ngayon sa mga prices, 4% a year. Garantisado ho yun. Nagkakaroon na tayo ng problem sa calamity, nahihirapan pa tayo economically. Pero with this program, ilibre yung kuryente sa araw, ang inyong rate for the next 20 years. Pero mas lalo na kung binili nyo dahil ang rate nyo magkano na. Pag sa inyo na yung solar, magkano na. Dito yata sa Zamboanga, 11 pesos per kilowatt hour, tama ba? Pero pag nag-solar ho kayo, 14. So, sorry, tubig nga. Pero kung nag-solar kayo, magkano ang rate nyo? Ha? Magkano ang rate nyo pag nag-solar na kayo? Ito naman, grabe. Libre. So, zero. Libre nga, magkaka-rate pa kayo. So, ang point ko, nakasave na kayo ng pera, nakatulong pa kayo sa Mother Earth, at etong maganda, meron pa kayong pamana sa next generation. Dahil ang maghihirap, ang maghihinagpis, ang magkalisod-lisod, dili kita partly. Pero ang pagkatinood ng akong anak o ang akong mga apo, mauna sila'y maigan sa worst anger ng climate change. Now, I think you are responsible parents, right? So there are things that we can do together. So kahit na mag-ban lahat ang mga solar companies, which I hope, we are going to see a renewable energy explosion. Actually, right after my meeting here, I'm going to see a site now with 100 acres. And they're going to, I'm hoping, that they can begin at least 2 to 5 megawatts. So I am leaving you my cards. I think they are distributing it already, You can give me a call and you can start saving not only Mother Earth, but your bank account. Kasi the opportunity is there. Kung nagawa ko, na I'm just, a regular person. Pero if you are the business owner, like I've spoken to MEPS, I've spoken to an association of the malls. At first, medyo nagda-doubt sila. Kaya 2013, it took me a while to convince people. There's even a company in Cebu spending 72 million pesos a month. Would you believe that? And we can cut it like right in half. So the thing with it is, this is a challenge for you. Okay? I don't care where company you go to, pero kami, we have a no cash out option. So yung kanilang binabayarang kuryente from the solar, which is siguro nasa sa 5 or 4 pesos per kilowatt hour against your 14, okay? So that's where they're gonna get the savings. And then I am also excited with anybody familiar with the carbon credits? Carbon credits, anybody? Okay. Napakahalaga po niyan dahil maraming companies sa Europe required by their governments to stop emission. Hindi nila kaya. So ano gagawin nila? Bibili sila kasi we're in one global village, di ba? Kunyari yung company ni Brad dito, nakasave ng 10 cubic tons ng carbon dioxide na certified, he can sell that credit to Europe. And I know that Land Bank is a broker. Hihingi lang sila ng 15% commission. The opportunity is there. Let us help our Mother Earth. And the best way we can do is, kung hindi gagawin ng gobyerno, gawin na natin, no? Let's push towards a green, renewable energy environment. I can help you, but the most important thing is educate yourself, read as much as you can. In fact, if you're going to go to Facebook, there's a ongoing contest right now. The prize is $250,000. If you come up with an idea, just an idea on how you can mitigate climate change, on how you can reduce your carbon, on how you can sequester the already existing carbon, $250,000 po. And that's why I really, in closing, I want to let you know, I think, correct me if I'm wrong, but the salvation of our country, of our world, sa emerging crisis is right here. Kayo po. Lahat ng mga kinakausap naming companies bago namin ilatag yung solar na yan, dadaan kami sa mga engineers. Kayo ho ang mayroong dunong. You have the wisdom, the skills, the ability that our planet needs. Of course, we need to collaborate with other engineers as well. Pero I think I want you to go home with a mission in your heart. No, it's not just to make money, but with a mission in your heart, because God gave us this beautiful home. Na because of greed and uncontrollable growth and technological advances way back in the Industrial Revolution, nakaligtaan po nating maging stewards. Dapat lahat po na ginagawa natin, alamin natin kung ano yung consequence ng ginagawa natin. Ngayon, tayo ang magbabayad ng consequences ng ginawa nila noong 1930s. But I hope kumilos tayo dahil mayroon tinatawag na tipping point. Meaning, pag dumating ho sa point na yon ang climate change, irreversible na po. And we're talking about 30, 50 years. So I'm talking to this generation. Please educate yourself. Read as much as you can. And then if you want to make money, give me a call. If you want to help in a contribution, give me a call. Or go to the nearest solar company na kilala nyo. Magtulungan ho tayo because it will overflow. Ang tanong ko, isipin nyo ho, no? Sa 20,000 na mga factories, isang factory, isang mall na lang na Nature Springs, naka-hire po kami ng mga over 100 people. Eh kung bawat factory magpa-solar, magpa-renewable energy, could you imagine yung labor, yung job creation? Meron na tayong pangbayad ng utang. Ay, sorry. We will be able to pay our debts. We will be able to have disposable income. Ano bang mangyayari? Yung faktorya na gumagawa ng sardinas, ng pagkain, nakasave sila ng 30%. So guess what will happen to the price of their commodities? So if ang price ng commodity bumaba, ano mangyayari sa mga mamimili? It will be within their reach. There will be an economic boom. I'm telling you right now. And you, my brothers and sisters, are the ones that are in the very front line of this change. Please, I beg, I implore that you are gifted with such knowledge and skills and help save the planet. Okay? So thank you very much and giving me this time. Maybe I'll entertain you.
Hello? All right. Thank you so much, Mr. Victor Labad. So are there any questions from our participants? So there's none. So how about in our Zoom? Okay. So let's
Okay.
proceed.
So again, thank you so much, Mr. Victor Labad. At this juncture, we would like to call on, once again, our 2022 Zomba Sulta Chapter VP Internal, Engineer Joseph P. Makindang, to award the plaque of appreciation.
To be presented, Sir Victor L. Lapan, grateful recognition of his invaluable contribution to the Institute of Integrated Electrical Engineers of the Philippines Incorporated, a sponsored technical presenter during the 9th Western Mindanao Regional Conference with the theme, Leadership, Rising Above Adversity Through Passion and Commitment, being on the road to recovery, held on October 6 to 8, 2022 at Palacio del Sur Markham Garden Hotel, Zamboanga City, within this 8th day of October 2022. Signed by Engineer Mark Anthony U. Sebastian, President of Ambasuta Chapter, and Engineer Alexander D. Governor for Western Mindanao. Thank you, sir.
Once again, thank you very much, Mr. Victor Labad.
To proceed with, just a reminder for our next guest speaker, we would like to inform you that you are given 1 hour for your presentation. If you hear this sound, you only have 10 minutes to wrap up your presentation. To proceed with our program, we are going to have a technical seminar on types, characteristics, and applications of electrical bus conductors to be presented by our guest speaker, who is the Central Eastern Regional Governor. Let us all welcome Engineer Brian A. Pasilan. Let's give him a round of applause, please.
Okay, good afternoon, everyone. And I would like to thank
first and foremost, the host governor, Gov. Alex Ko, and for the host chapter, Zambazulta chapter, for inviting me and having me, to share with you some insights, regarding our ethical practice. And again, congratulations, to the host, for the successful ninth Western Mindanao Regional Conference. And to everyone, thank you for actively participating in your conference. Okay, so with that being said, I would like also to thank Gov. Richard Lizardo, my very good friend, who has also been my mentor in IIEE since 2013. No? My father and him are really good friends, really close friends in IIEE. So thank you, Gov. Thank you very much, for all the guidance. Okay, so I will not be taking too long. I will be now sharing my screen. Okay. So it's okay, Molly. Okay, so our discussion this afternoon, medyo palahita, We've had discussions this morning about short circuit calculation, voltage drop, and sizing of electrical systems. So this one, it's not quite common, We'll be discussing about what are electrical bus conductors. So usually high-rise systems nowadays, are utilizing what we call the bus ducts, But before application of bus ducts, we need to be familiarized what are its characteristics and what are its advantages and disadvantages, and what are the different types of material for certain situations, for certain circumstance. Okay, so this is primarily our topic this afternoon. Okay. So this lecture is usually takes 2 hours, but I will have to try to compress it as much as I can. Perhaps I will just set the limitations. There are some sections, calculations na I will not emphasize na. It's your homework na lang. Anyway, you can follow through with my slides. Okay. Here's our outline. Okay, so some objectives and introduction about bus conductors, and what are the conductor materials for bus conductors, and the design considerations, the ampacity, the ambient temperatures, altitude limitations. So there's also the altitude consideration. It's not the circumstance from above the sea level to the mountains is different now. Skin effect, and proximity effect, and what are its impacts. Again, we discuss about short circuit stresses. We've discussed short circuit calculation this morning. So it's not only on circuit breakers that is applied, it's also for the bus bar bracing, and insulation strength, and methods of making connections. So these are the topics that we'll be discussing this afternoon. So here's our objectives, then familiarize, the characteristics and application. Okay. And the design considerations, we will be familiar how to specify bus conductors. Is it going to be copper? Is it going to be aluminum? Is it going to be flat bus bar, tubular, or round? And the proper methods of connection. Is it going to be mechanical type of connection? Is it going to be crimp type, etc.? Okay, so firstly, we have to define what are electrical bus conductors. As per definition, comes from the Latin word omnibus. So what's omnibus? It gives the idea of a universal system of conveyance or transport. For in this case, in electrical, it's a transport of current from one place, from point E to point B. So that's the etymology of bus, omnibus, Latin word. So it's used to describe the junction of circuits, usually a few inputs and a lot of outputs. So in graphical presentation, let's just have this simple presentation, no? So you can see there, walang light. Okay. You can see there, no? Inputs, few inputs, sorry. Few inputs and a lot of outputs, no? Simple presentation. So there's a lot of forms, no, of bus conductors. We have bar or bus bars, usually found kana mga high-rise na to, no? If you are, it's a mga contractor of high-rise buildings, that's the usual form. We have the round or square tubes, usually found in substation, no? Mga switching stations, mo na ginagamit, no? And we have cable bus, no? So these days, nanapoy bagong riser distribution system, hybrid between bus duct and cable. That's what we call cable bus or branch cable, no? So it's also being considered as a bus. It's a group of conductors, no? But arranged in a way they have the benefits of a bus conductor. So there are three types, no? Bus bars, flat bus bars, round, and power cables or cable bus. Okay. So in a typical generating station, if you can see this picture, no, we have here a generator in a power plant niya, and a station transformer and auxiliary transformer. So if you can see, we zoom this in, no? So from generator, then if you can see the generator below, no? Then you can see this thick conductor, no? Usually the distribution is from generator to station transformer, it's bus duct or bus bar, no? It's no longer cables. So that's the practical application. Then other units transformers, no, going inside the plant, auxiliary transformer, then still using bus bars and the station transformers. So usually, previously, these are the common applications, no? But now, with the advent of very high-consuming demands of high-rise buildings, nasood na po siya sa commercial application. Previously, sa industrial plants lang ni siya o power plants. But now, we have commercial applications now for bus bars, okay? And going out, transmission lines, so naturally, transmission lines na ang mo transmit of power to long distances. Okay, so in the Philippine setting, we have these nominal voltages, no, for distribution, medium voltage, 2.4, 4.16, so on and so forth, no, up to sometimes we have 69 kV, no, up to 69 kV. So these systems, no, usually employs power cables or solid conductors, depending on the size of the transformer. So may distribution na tayo na at this voltage level. So depende na yan sa assessment ng design engineer, no, kung it merits the use of bus conductors, especially for high demand systems. Okay? So ito, no? So pina-zoom in ko na lang further from 13.8 down to the transformer step down. So it's a cable or bus duct. Then low voltage again, cable and bus duct. So it has to apply sound engineering, no? Di nang pwede na diretso-diretso bus duct. So you need to determine kung kailanganin ba yung bus duct. So we will learn that as we go on, no? How to determine. Okay, so for practical lang na assessment, no? For ratings up to 600 to 8 amperes, typically cables are preferred, no? Mas cheaper ang cables compared to bus duct to a certain extent lang, no? So as a guide lang na to, usually up to 800 amperes practical pa ang cables. However, 1,000 amperes above, economically practical na ang bus systems, no? compared sa cable. I don't know here in Zamboanga, Gov. Richard, nung for high-rise, kung meron ng high-rise, no? You can really evaluate the difference, no, between having a cable system compared to a bus duct, no? Mas smaller yung footprint ng electrical room, mas economically po siya ang bus duct, no? We will learn later on why. No? Okay. Due to cost, appearance, and safety and ease of handling. So you could imagine, no? Magparallel ka o 15 sets of 250 squared cables. How would you handle that up to the 30th floor? Piting bugata. You need a chain block, you need, so difficult to maneuver talaga. But with the bus duct system, sectionalized, ito yung practicality ng bus duct, no? Easy to handle, and yung electrical room mo, you can reduce by as much compared to a cabling system. Okay? So, that's one advantage na of having bus duct. Okay. So, disadvantage lang of bus duct, no? Sometimes, kung medyo larger na talaga, kaya nga, we have to assess again if we retain the same voltage, system voltage, no? Sometimes, kung malaki na talaga, in terms of 10 MVA, sometimes, kung high-rise, let's just kuan lang, assess, no? Kung practical pa rin. Problema talaga, major problem is locating faults in bus duct, no? So imagine if you have this riser system, my ground fault, no, in one of those phases, how can you do meager test? No? It's a continuous system. How will you isolate? No? So that's the major disadvantage of bus conductors. No? Unlike cables, pwede mong i-isolate, pwede mong one by one, pero dito, mahirap. No? So that's the major problem with bus duct. So meaning to say, pag mag-implement tayo ng bus duct, during the first installation, talagang ensure nyo na walang lahat ng test na conduct talaga to ensure na walang instances of faults na mangyayari. No? So yun lang yung trade-off ng bus duct system. Okay, so common types of conductors or materials, it's either copper and aluminum, which is the only materials also allowed or permitted by PEC to be used as conductors. No other material except for silver. Sometimes it can permitted, especially on contacts. No, but for distribution of currents, copper and aluminum lang yung permitted ng PEC natin. Okay. So, we all know in every electrical circuit, whenever there is current present, meron talaga yung heat, no? The presence of heat, hindi natin yan maiwasan because of resistance of the material. So, I don't know if may perfect material na bang na-develop na walang resistance, there is really some form of resistance, no? Kahit konti. So, that's why there is always the heat or heat loss. And heat loss are wastage, no? They are converted to heat without any value in the system. So we need to reduce that as much as possible. And heat also could impair the performance of system if not controlled, no? So meron tayong temperature limitations pa rin in our system, okay? How much we'll discuss later. So equation for our heat loss, no? It's I squared in RMS times the effective resistance, no, of the conductor. Okay. So IRMS, root mean squared, no? So ito yung heat loss, I squared R. So alam naman natin yan, no? When we conduct systems loss or line losses, ito yung formula natin. So low resistance equals lower energy loss. So we need talaga to determine kung talaga bang importante natin yung pag-control ng losses. So far, ang copper yung medyo superior yung performance. No? Okay, so again, industrial plants and commercial loads having large loads, no, would give rise to very large forces or currents, no. So They must be able to withstand the said forces without damage. So meron tayong vibrating stress during continuous or normal load at short circuit stress during short circuit conditions, no? So malaking force yan, magnetic tsaka thermal stress. So we have to have the best mechanical properties, no? Designed to operate within temperature limits. So meron tayong table dito, mamaya pakita, doon sa temperature limits of specific conductors. Okay. So we go now to the selection. Okay. This is the very, kanang intriguing kaini siya na section. Because if you are designers, may mga clients tayo talagang gustong, sir, pwede bang aluminum? O talaga bang copper lang talaga? So which is which? Paano natin madidetermine? So, ito talaga yung pinaka-bottom line, no? Low wiring costs. Okay. But we have to have these design considerations before we select, no? Depende on the environment. So, we have to assess the conductor material by these characteristics. High resistance to corrosion, low electrical and thermal resistance, so madali siyang mag-dissipate ng heat. High resistance to fatigue failure, so mechanical strength. Okay? And low electrical resistance of surface para ma-reduce yung losses. Ito yung mga factors natin and ease of fabrication. So, to determine which material and which system, is it going to be cable, is it going to be bus, ito yung mga factors nating ibabalanse. Huwag nating diretso, basdak, then copper, basdak, aluminum. We have to gauge those criteria based on this, no? Then we select which one is applicable, no? There's really no superior talaga yung copper in all areas, no? Let's have that mindset change, no? As engineers, we have to have the responsibility to assess which is the very practical for our clients. Okay? Copper talaga best meets the combination of all those previously mentioned, no? Comparing copper to aluminum, copper has the best protection from corrosion, no? If you go with ito yung oxidation bitaw na table, no? So, ito yung copper. Ang medyo nasa dalawang kwan yan, anodic tsaka cathodic, no? So, aluminum is lesser, no, in terms of corrosion protection. Okay? But because of cost, no, we can allow, it is permitted, but it's still permitted by the code, but still it's engineering judgment ang mag-prevail. Okay? So, copper and aluminum are both used in these scenarios for flat bus bars and tubular and red and structural shapes, no? So, pwede yan, either copper and aluminum. Okay. So, ito yung conclusion, no? We have to use our engineering judgment, no? To choose between these types of conductors, depende sa practicality. Okay? So, another factors, no, na we need to be concerned with, no, is the ability to dissipate heat losses, no? But it's not only on the material, it's also on the area and the enclosures. Okay. So for indoor installation, heat dissipation depends on these two factors, the radiation and the convection. So yung radiation is sa material na yan, no, how it radiates heat from one place to another. Convection is through ventilation, no? Through air, no? Paano yan mag-dissipate? Okay, so it also matters with the ampacity. For indoor, for outdoor, it's exposure to wind and exposure to sun, no? Ito lang, exposure to sun, medyo mahirap yan, no, i-address. So dapat talaga yung material natin has the thermal resistance for this one. Okay, so copper, let's state the advantages, no? Low electrical resistance, sabi ko kanina, meaning translating to low losses, low rate of corrosion, and high thermal conductivity, meaning to say, madali siyang mag-transfer of heat, no, from one place to another, no? And good mechanical strength. Okay? Mas matigas yung copper compared sa aluminum. Copper alloy pala, hindi pure copper, no? So again, we all know that copper has the highest conductivity, or the as it is the benchmark for our conductors, no? So for annealed coppers, it's 98%, and for hard drawn, it's 97%. Okay? So mayroong alloys yan. Ito yung mga alloys na pinaghalo para it can give a more strength, no? Phosphorus, aluminum, iron, tin, zinc, okay, and cadmium. So as per IACS, the International Annealed Copper Standard, the presence of copper is no indication of its electrical conductivity. No, as long as there is copper, there is still that conductivity. However, I observed that sometimes it has an effect, no, but not linear yung proportion, no. So importante lang meron yung copper. Okay. So if you really want to dwell on that, how to figure out, no, meron tayong table how much yung conductivity niya with certain alloys mixed. Okay? But again, it is stated that if the total impurities, including oxygen, is less than 0.1% by weight, no, this type of copper is known as the high conductivity copper. Pero medyo mahal ito, no? Siguro for certain applications that needs high conductivity. But for normal applications, we can do with lesser. Aluminum. Okay. Medyo na-disarrange yung... Ang advantage ng aluminum, it has the greatest current capacity for any given weight. Meaning to say, for the same ampacity of copper and aluminum, mas magaan yung aluminum. Isang advantage yan, no, for handling. No, that's the main advantage aside from cost. Disadvantage lang is has lower conductivity, meaning to say you have to upsize your conductor, its cross-sectional area, to have the same ampacity of that copper. No? So ito lang, disadvantage, malaki yung conduits mo, malalaki yung trench mo. So you have to again balance out especially for civil works, no? Kung mag-offset ba yung cost ng reduction of cost, the conductor material with that trenching. So if you are underground, ibabalance nyo lang. Okay. And for erosion, no? Aluminum erodes faster than copper in humid and corrosive conditions. So mas inferior yung aluminum compared sa copper. And again, conductivity is only 63%. Okay? So these are the advantage and disadvantage of copper and aluminum. Sa akin, practice, I have a client, no? Its installation was near the sea. It's a desalination plant. And they've requested me if I can specify copper or aluminum conductors. I just explained to them, ito yung disadvantage. No, can you gamble with, if you say you operate your plant for 50 years, then what's going to happen to the aluminum conductors that will be installing in that area, no? So those are one of the examples on how to address that dilemma. Should we use copper or aluminum? So that's one area that you can justify the use of copper. But for any other circumstance, like building, no, indoor building, aluminum is fine, no? As long as you have the proper termination or terminal lugs na aluminum copper, or mayroon kayong yung kuha natin, protection for corrosion, yung Penetrox, no?
So, para walang heating na, kasi dissimilar materials, no, nagko-corrode yan. Okay. So, other issues, ito yung problema, no? Pag mag-design tayo, pag malaki na yung system, nagkaroon ng large current, ang i-apply natin low voltage pa rin, no? You can see sometimes mid-rise buildings still employing 230 volts. That's why nga, every time when our system capacity increases, i-increase natin yung system voltage. Then pwede na yung 230 volts lang. Let's go up to 400 volts, 380 volts. Yun talaga yung practical na solution, no? Para mas maliit na yung conductors na kailanganin natin. So usually, for high-rise buildings, nandun na yung 400 volt system. Hindi na nagagamit ng 230 volts. Oops, sorry. So again, we have to be reminded that currents are more difficult to handle than voltages, no? So dapat talaga mas particular tayo sa current handling of our material. Yung voltage natin, yung insulation, standard na yan. 600 volts yan yung mga natin, no? For 230 volts system and 400 volt system. Pero yung current, ito yung hindi natin ma-determine. So we have to be very careful, okay? Again, select the correct size and select the bus enclosure for required rating and voltage system. Okay? So pag malalaki talaga yung bus conductors natin, let's make sure yung enclosure natin has the proper ventilation, provision for convection, heat convection, no? Properly sized also para mas mainam yung ventilation sa loob, no? And is it going to be for low voltage and medium voltage system? So we are very fortunate. We have VPX this afternoon. VPX June Herrera is from Fujihaya, so he can, I think, give some examples on this application for panel enclosures, no? Okay. So what are the design considerations? Okay. So basically, unang-una talaga is ampacity or the current carrying capacity. So how do we size up our bus bars, no? Kasi wala yan sa PEC, yung ampacity ng bus bars. Nakita na ba kayo ng table sa PEC ng ampacity ng bus bars? Wala pa, no? So just cables lang. So we have other standard handbooks, no? But again, it's not a hard rule. Talagang dapat we have to be resourceful enough to get those, especially mas mabuti pag may yung catalog ng supplier, no? Yung tingnan natin, yung kunin natin. Okay? Next, we need to consider is the short circuit stress. How do we brace our bus bars to withstand the forces and methods of making connections? Okay? So let's start with the ampacity of bus conductors. Okay. So yung capacity natin is dependent on the heat produced, no, by the current in the conductor. Okay. So for generating stations and substations, temperature is permitted without danger of overheating equipment. So dapat particular tayo sa limit of temperature rise of our conductor. So we have a table for that, no? Kasama na yung joints and connections. Okay. So what are the factors affect the heating of the bus? So material type, the size and shape. Importante pala yung size and shape, no? Is it flat? Is it round? No? Is it tubular? Meron tayong ipakita mamaya ano yung difference ng flat bars and round conductors. Okay. And the surface area of the conductor is condition. Skin effect, ito yung skin effect, no? Medyo curious tayo dito. Alam mo ba yung conductors natin, ampacity? The bigger the conductor, no, for the certain square area, the smaller na iyang ampacity. No? That's why it's practical, magparallel tayo ng smaller cables compared to one big conductor. No? Because of this skin effect. We'll discuss later on. And proximity effect. Ibang effect na din ito, no? If you are going to be paralleling bus bars, ito yung kuha natin, mangyayari, is proximity effect. There's still also the conductor reactance. So kasi pag AC systems tayo, may frequency tayo, no? Nandun na rin yung reactances, no? So it is dependent on the frequency, yung conductor reactance natin. It's not only resistance, no? If you look at the peak table, dalawang values yan. Resistance tsaka reactance at impedance, no? The thickness of the bar and the type of insulation. Yung type of insulation sa mga temperature limitations yan, no? And ventilation and inductive heating, no? Caused by this proximity effect, no? So inductive heating, ito yung hindi natin binigyan ng pansin, no? We'll be surprised na bakit mainit yung enclosure ko, yung switchgear ko. Yung load ko nandito pa lang, hindi pa umabot ng 70%. Yun pala induction heating, no? So there are configurations in our conductors na mag-produce nito, yung induction heating. Especially magnetic materials, no? So current density of bus bars, no, depends on the per square inch area. Okay, so that's what we call the current density, amps per square inch. So how to size up bus bars again? Rule of thumb lang ito, no? For heavy current carrying buses, 600, 700 ampere square inch. And for light buses, it can go as high as to 1,200. Meaning to say, no, parang dinirate natin yung bus natin, no? If magkakaroon siya ng heavy current bus bars. This is just a rule of thumb. But if you can have your data from your manufacturer, so much the better. Meron akong tables din maibigay, no? Para naman mas klaro yung kuan, no? Ang pag-size up natin ng bus bar. This is for copper, ha? So sometimes, sino ba yung nag-design ng bus ducts na hindi nagkuha ng table? Usually, ginagamit is 1,000 amperes square inch, no? For a single flat bus bar. Sir Jun, ano sa atin? 1,000 ba? Okay. So pina-average na, no? Usually of our panel board makers, no? So 1,000 amperes per square inch. But again, for aluminum, it is lower. 75% of these values. No? So dapat mindful tayo pag nag-order tayo kay Sir Jun. So we have to be mindful kung aluminum ba yung gusto nating ipagawa. Pero may aluminum ba kayo, Sir Jun? Busway lang. Okay, so mas kuan yung switch gears kasi, no? Mas kuan yung heating doon sa loob. So the heating again, mag-increase yung rate of oxidation, no? The higher the temperature, mas mataas yung rate of oxidation. So mas superior yung copper. So that's why sabi ni Sir Jun, sa mga switch gears, copper lang talagang ginagamit. Okay? So previously, copper, no, is being selected because of its rigidity, high conductivity. But now, aluminum is also being slowly being used, no? Easier availability and cost, no? So ito lang yung advantages din ng aluminum over copper, no? So it's not surprising na medyo naging popular na, especially yung copper natin. Kung nag-import tayo ng copper, ilan na yung dollar ngayon? Almost 60, no? So talagang dependent yung kuan, yung copper natin sa dollar. Even also aluminum, but because of its cheaper material talaga compared to copper, so mas volatile yung copper because of limited supply. No? Okay. Uses of aluminum, no, are the following, no? If it has to carry power, simply carry power, no, from transmission, distribution at any voltage, ito yung pinagamit. So yung mga utilities natin, Yung NGCP, di ba yung mga conductors nila is aluminum usually? Hindi sila gumagamit ng copper, di ba? No? So, yan, pwede yung aluminum dyan, no? And again, power distribution equipment, pwede rin, no? And high current at low voltages, no? Pwede yung aluminum. But again, we have to assess if talagang concern yung heating. Okay? So, for switch gears like circuit breakers, fuse, copper talaga yung ginagamit, no? Kasi nandun yung mga high switching arcs, yung current natin, malalaki. So, copper. And it also has the harder metal. Nakita na ba kayong contactors na aluminum yung ginagamit sa mga contacts, terminals? Wala pa. No? Because of these reasons. No? Okay. Copper is also recommended for more humid areas and chemically aggressive areas. So sa mga sulfuric plants, no? Sa mga geothermal plants, wala tayo makikitang aluminum dyan, no? And even those conductors, they are silver-plated for added protection, no? So, no yan sa mga ganyan klase na plant, no? Yung aluminum. Highly oxidizing areas. So, it may loosen at the joints, no? So, ito yung problema talaga ng aluminum. Okay? So, we go now to the temperature, no? So, ito yung ambient temperature natin na allowed na rise, temperature rise, 85 to 90 degrees. This is the safe end temperature for aluminum na yung metal niya hindi pa mag-deteriorate or mag-oxidize. And it will not change its properties. So, it will not warp, hindi masisira yung properties niya. Ito lang, no? 85 to 90 degrees for longer periods of time na operation. So, ito yung two vital factors, no? Na i-select, i-criteria natin for longer hours of operation. Yung rate of oxidation, tsaka yung mechanical strength, no? Pag talagang matagal yung mag-operate yung planta nyo, 24 hours, 7 days a week, mag-isip-isip tayo kung gagamit pa tayo ng aluminum. Kasi yung rate of oxidation yan, because of higher temperatures, aluminum is inferior talaga. No? So again, for notes lang, no, it should be maintained yung same end temperature. Meron tayong tables yan. To, no? So for 85 degrees, for an ambient temperature of 30 degrees, we are permitted to have a temperature rise up to 55 degrees. For example lang if lalagpas ito ng 55 degrees or more than 85 degrees, mag-derating na tayo. No? Mag-derating na tayo. Okay? So pag 40 degrees, ito na. No? So at least we all know na paano pag-assess yung capacity ng bus natin in these temperatures. No? I don't know ngayon kung ano na ba talagang ambient ng Pilipinas. No, they say yung temperature is 31, pero yung heat index daw aabot na ng 40. No, it is a challenge for us to really determine ano ba talaga yung temperature na i-subject natin yung material. Anyway, we have this guide. So for conservative, pwede natin ilagay sa 40 degrees. Ang impact lang dyan, mas costly na yung system natin kasi palalakihin natin yung mga bus bars because of the rating. No? Okay. Meron pang time? Okay. So may table din tayo for graph. No? Pag hindi tayo gustong gumamit doon, meron din tayong graph for ambient temperatures and the applied rating factors, no? Sa left side. So we can still have those values. I've tried comparing this one to the table, tumama talaga, no? So try practicing, no? Intersect mo lang yung linya dito tapos sa rating factor sa kabila. So ano yung effects of higher maximum operating temperature? Ito na, sinabi ko kanina. Rapid increase of rate of surface oxidation, no? So, yun yung problema pag aluminum. Mas mabilis yung rate of oxidation pag nag-go beyond, no, sa maximum temperature. Excessive heating of joints and contacts. So, anong mangyayari? Mag-oxidize na yung contacts din, no? Mag-heating, mag-arcing, andun na yung mga problema lalabas. Okay? So, yung temperature limit talaga is much more important consideration to aluminum than copper. Because copper has a lower rate of oxidation. Yun lang yung main point natin, no? So, additional information, at 90 degrees is the temperature where aluminum and copper starts to oxidize. Mag-oxidize na yung dalawang material natin. Pero ang diferensya, yung rate of oxidation. Mas mabilis yung aluminum, no? So anong yung problema pag may oxides na yung conductors natin? Magiging poor conductors na of electricity. Affected na yung bus conductors at the joints. Yung sabi ko kanina, mag-loose connection na, mag-arcing, magpo-fault, no? Okay. And it will reduce the ampacity of the conductors over time. No? Kasi marami ng impurities, no? Ano ba yung value kanina na high conductivity? Less than 0.1%, di ba? Pag may oxidation na, marami ng impurities, hindi natin ma-expect yung 0.1%, no? So maglo-low na talaga, mag-less na yung ampacity niya over time. It will lead to overheating, which will cause failure. So mag-overheat na yung conductors natin, yung bus natin, especially for cables na nagkadikit, ano mangyayari sa insulation? Insulation damage, then magka-fault, no? So, yun yung problema ng excessive heating. No? So talagang ilimit natin yung operating temperatures as much as we can. 85 to 90 degrees for all ratings. At least in the medium loading up to 3,200 amperes, no? So, pag meron tayong mga busways na ganyan, talagang i-take care natin, hindi ito lalagpas ng 90 degrees. No? The problem now, no? Anyway, pag talagang gusto nating sasagad pa, pwede tayo mag-apply ng silver oxide, no? At the joints, no? Para hindi mag-experience ng excessive heating. Pag-protect siya ng oxidation yung silver oxide, no? Okay. So, gamitan natin ng silver oxide kung gusto nating ilagpas, no? So, yan. Now, for mechanical strength, the conductors up to 125 degrees lang, no? Aluminum conductors. Beyond 125 degrees, mag-weaken na yung aluminum, no? So, pwedeng magsasag na, magdi-deform na, no? So, mas marami ng problema, okay? So ito yung table, no, showing tensile strength of aluminum. As you can see, oops, sorry. So the horizontal column, no, the left is the unit for stress of kilograms per mm squared. Okay. Now, as we increase our heating period and our temperature at the right, na makita natin na yung tensile strength niya, nag-reduce talaga dito, no? Hindi lang makita. Mabasa nyo yan, no? Itong region na to, no? So after this region, at 125 degrees, nag-reduce na talaga ng tensile strength. Okay? Ito yung setback talaga ng aluminum. So again, in whatever material, ito yung problema ng high temperatures, no? So, endangering operating personnel, no? Pwedeng makapaso, experience ng burns. It may be even a source of fire hazard. And inside the enclosures, magda-damage. So talagang ang kontra ng electrical equipment is heat heat tsaka water. No? So, especially ngayon, mga electronics na yung mga trip units natin, mas madaling masisira. No? And other effects would be the gaskets and other hardware sa bus system. Talagang malilimit na yung performance nila. No? So, i-control talaga natin. Okay. So, 105 degrees, ito yung maximum operating temperature of a bus system, either aluminum or copper, with silver-plated or welding joints. So, pag gusto nating palakihin yung 90 degrees at the contacts, apply tayo ng silver-plated welding joints. No? Pag talagang necessary. No? Pag hindi naman, huwag na natin i-apply. Pero pag talagang it will be operating at high temperatures most of the time, paniguro tayo. Gamit tayo ng silver joints. Okay? So, the 80 degrees to 110 degrees temperature limit is at the locations na safe. Pwede pang ipa-operate, pero hindi ma-access ng human body. Meaning to say, ipa-allow natin to operate at that temperature as long as walang makapasok doon na tao sa enclosures. No? Mag-withstand pa yung equipment natin. So ito yung table natin for maximum operating temperatures, no? So for example, bus conductor with plain connection joints, maximum temperature limit is 70 degrees. With silver plate, pwede nating increase 105. For enclosures, kung accessible yan sa tao, up to 80 degrees lang talaga. But not accessible, pwede nating pa-operate to 110 degrees and so forth. Okay? So at least we have this guide. Ano yung mga maximum temperature limits natin. Next consideration is the altitude. No? Saan ba natin ilagay yung bus ducts natin? Is it on the ground or is it on the mountains? Is it going to be high-rise? Is it going to be low-rise? So meron tayong altitude limitation. Not because of the material, but of the insulation. No? Kita natin mamaya, no? The electric strength yan sa insulators ang maapektuhan ng altitude, no? For low voltage system, yung rated niya na insulation or the electric strength up to 2,000 meters lang, no? For medium voltage, mas maliit, 1,000 meters lang. So meaning to say, pag lampas tayo dyan, yung the electric strength na rated ng supplier na itong manufacturer natin na specified, instead of makahandle pa siya ng 400 volts for low voltage, paglampas ng 2,000 meters, nag-reduce na yan. Hindi na yan kakayanin yung insulation niya. No? Ito yung problema pag nasa mataas tayo na area. Sa mga bundok, no? Mga skyscrapers, no? In the US, so dapat we have to be aware of this one. Okay? So pag hindi tayo lalampas ng ganitong mga values, wala tayong i-apply na derating sa the electric strength, no? Pero pag maglampas talaga, anong gagawin? Okay. Ito na. We have to increase the clearance and creepage distances to ground. Ano yan? Okay. So meron tayong illustration para makukuha talaga natin. Okay? By how much? 1% for every 100 meter rise. So meaning to say, pag aabot kayo ng 2,100 meters, so increase by 1% yung dielectric strength natin. Or creepage talaga pala. Creepage at clearance. Both creepage at clearance. So anong ibig sabihin ito? No? So you have these two terminals. No? Imagine lang, ito yung terminal ng circuit breaker natin. No? Yung clearance is the distance between. No? Kita nyo? Air clearance yan, air gap. No? So, oops. Yung creepage is the shortest distance along the surface of the insulation. So magkaiba yan. No? Mas longer yung creepage compared sa clearance. But the standard says that yung dalawa ang increase natin by 1%. No? Paglampas doon sa values. Okay. More examples, no? Creepage tsaka clearance. So, dapat tandaan natin yan, ayun yung diferensya ng clearance tsaka creepage. So, if you are making yung terminals ng mga breakers natin, no? Ngayon, compact na yung mga breakers natin. Yung mga terminals niya mas closer na to each other and sometimes to the ground, no? So, anong mangyayari pag ganyan yung apply natin, tapos nandun sa taas yung high-rise natin, nandun sa bundok, no? So, pag may overvoltage dyan, mangyayari, anong expect natin mangyayari? Mag-flash over na yan sa kabilang phase. No? Kasi na-compromise na yung dielectric strength niya. So what to do? Yun nga, kanina. Increase creepage and clearance. Okay? Ito, may table. So for enclosed indoor air insulated bus bars, so up to 400 volts, 415 volts, minimum clearance, ground in air, no? Walang insulation, 16 mm, no? Between phase, it's 19 mm. Pero anong impact yan sa panel board? Pag ganyan yung i-treatment natin, yung circuit breakers natin medyo malalaki na. No? Kasi dapat natin pa-increasein yung clearance. Sometimes we use the barriers, yung ano bang tawag natin yung Sir John, yung between terminals, insulation barriers. Yan. Yun yung isang pwedeng natin gawin instead of palaparin natin yung circuit breakers natin, no? Or apply yung mga insulators na rated for that system voltage. Okay? Ito lang yung importance diyan. Okay? So, yun sa clearance, no? For creepage, yung along, ito yung distances dapat natin ilalagay. So, we have values in mm. So, paglangpas doon, ano yung 1% ng 19? So, i-add natin yung mm dyan, no? Yung surface along. So, meaning to say, haba or malapad na yung circuit breakers natin. Okay? So, ito lang yung batayin natin. Hindi ito sa bus bars din natin, no? Not so much on the opacity, but on the insulation, the electric strength. So, that was for the mechanical, no, properties. Now, we go to the skin effect. Sino yung mga bagong graduates or bagong passers? Tatandaan po mo yung skin effect ng material? No? So, ano yung skin effect? At anong impact niyan sa conductors natin? For DC currents, may skin effect ba o wala? May leakage reactance ba yung DC current system? Kailan pala mag-show yung reactances natin? Pag may yung XL, yung inductive reactance, pag may frequency, no? AC system. Ito DC ito, resistance lang talaga ang present, no? So parang nakalimutan yata yung fault calculation natin. Sino ba yung mga bagong board passers, no? So, yung wire natin, yung conductor, pag AC system, dalawang yan, unit of resistances. The resistance and the reactance, di ba? R at saka XL equals Z. Impedance. So, sa DC, resistance lang yan. So, wala yung skin effect. Wala tayong problema. Ang problema, pag sa AC na tayo. Yung skin effect would cause a non-uniformity of distribution of current on the conductor. Ano mangyayari sa current? Ito. Instead of flowing at the center or all throughout the surface, because of skin effect, wala na current doon sa gitna. No? Nandun na sa outer edges of the conductor. So, if you are mindful of our spec table of the ampacity, makita nyo dyan, no? Magparallel ka ng dalawang 8 mm squared. compare mo dun sa ampacity ng isang 14 mm squared, no? Ano yung mas malaki? Yung dalawang 8 mm squared, yung capacity. Di ba? Kasi mas malaking cross-sectional area, mas pronounced yung skin effect. Yun yung problema sa EC system. So sometimes that's why it's economical to parallel conductors instead of using one big conductor. No? So ito yan. Hindi natin ito maiiwasan talaga. Meron talaga yung skin effect because of frequency. Okay. So the more or the higher the frequency, the more pronounced yung skin effect. So yung mga high frequency systems talagang problematic yan. Tapos power loss yan, no? So what's the principle behind, no? Let's just imagine meron tayong round conductors. May filaments yan, no, from the center going outside. Okay. So the flux linking the filaments progressively decreases as we move outwards. Meaning to say, yung reactance, no, from the center going out decreases. So ano yung relationship ng current tsaka resistance? They are Ohm's law, inversely proportional. Meaning to say, yung reactance pala dito, no? Pag ma-imagine mo, no? From the center going out, mag-reduce yan. So saan yung maraming current? Mas lesser na yung reactance sa labas. No? Hindi yan even yung reactance natin from center to outside. Mas malaki yung reactance dito sa center going rather than going out. So, na-concentrated na lahat ng current dito sa outside. So that's why, kung pwede lang, hindi na sana lagyan ng strands yung sa gitna ng conductor kasi walang gamit yan. Problema, mechanical strength. No? Maluma yan. So, yun. Waste yun, no? Yung mga inside strands ng conductors natin, walang kurente dyan. Almost lahat nasa outer layers, no? So, hindi natin maiiwasan yan. So, anong impact yan ng system? Okay. Na-discuss ko na yan kanina, no? Okay. Effectively reduce the cross-sectional area in terms of capacity, no? Meaning to say, pag may, let's just say, no, 8 mm squared yung cross-sectional area. Pag mag-times 2 ka, let's just say, almost times 2, no? 14 mm squared. Anong relationship ng capacity? Is it going to be proportional? Directly proportional? No. No? Magkano ba yung 14 divided by 8? This, pag may nakakompute, is it 1.5? No? So pag ang 8 mm squared is mag-carry ng 60 amperes times 1.5, magkano yan? Hindi yan 120. No? Hindi yan 120. What is 1.5 of 60? Is it 100 amperes? No? So yun yung impact ng skin effect. No? So dapat talaga we have to be aware when you design systems, ano yung pinaka-economical? Gagamit ka ba ng isang malaking conductor or maraming maliliit na conductor na pagsabay-sabayin? Okay? So ito yung behavior ng skin effect, no? Pag DC, walang, yung current natin lahat evenly distributed. Pag high frequency AC, ito, yung almost all of the currents nasa labas, no? Pag low frequency, walang current sa gitna, no? So ito yung relationship lang between DC and AC, high frequency and low frequency current, no? Okay. So again, power loss kasi nag-increase yung resistance. Okay. So mayroon tayong relationship between DC resistance and AC, no? Resistance. those who are taking the PEEs, if you have computed your impedances ng cables natin, tapos wala tayong data sa AC, pwede natin masolve yan pag may skin effect tayo na table ratio, no? At may DC resistance, no? So, usually greater than 1 yung skin effect ratio, no? Kasi mas malaki yung resistance compared to sa AC compared dun sa DC. So magagamit natin. Okay. Sit 1 minute. Wala kaya. 1 minute na ba? Mag-bell na ba kanina? Okay. Mataas talaga ito, no? So, dalhin na lang ko kayo sa impacts. Dalawang kuha na lang topics. So, proximity effect din. Okay. Sayang. Okay. So round tubular mas kuan siya, mas lesser yung skin effect niya. So, usually in substations, no? Pasensya, medyo mataas talaga itong topic na to, no? Okay. Ito, proximity effect, ibang effect din ito, no? Pag mag-parallel kayo ng bus bars, ito yung ma-experience natin, no? So, how closer they are, mag-unbalance yung kuha natin, yung distribution of currents among the phase. So pag mag-RYB ka, tapos ito yung arrangement mo, usually yung Y phase natin, mas maliit yung reactances dyan. Meaning to say, nandyan yung concentration of current sa gitna. No? Ito yung proximity effect. Tapos, unbalance, voltage unbalance din. Voltage drop unbalance. No? Okay. So, ito yung relationship between current and spacing sa proximity effect. Okay. Ito rin yung isang problema, voltage drop unbalance. So, pag-address dyan, paano? Okay. Either through transposition. Okay. Ito, pag long lines, transposition, ginagawa ito ng grid, no? At long kilometers, or sa mga high-rise buildings, pag talagang mataas, over 50 meters yung building natin at tapos 2,000 amperes, ito yung usual solution. Gumamit tayo ng reactor core. Insert natin sa phase Y, no? Para mag-introduce ng reactance sa phase Y. Parehas na sila ng reactance. Yung voltage drop values parehas na din, no? So balanse na yung tatlong phase, no? Ito lang yung criteria, no? Pag umabot na talaga ng 2,000 amperes and above yung system and lengths of over 50 meters. So 50 meters pag hindi umabot ng 50 meters yung length ng bus duct, di po na i-apply, no? Kahit ilang amperes pa yan. Pero pag lumampas na or umabot ng 50 meters, ito yung reactor core na sinasabi natin. Okay? So meaning to say, ang proximity effect in bus barring dapat tingnan din natin, no? Kung may impact ba talaga. Yung skin effect at proximity effect talagang problematic, but we have ways to address that. So sa skin effect, let's just, pag parallel tayo ng conductors, ang advisable lang yung bus bar up to 4 bus bars lang ang advisable, no? Para hindi natin ma-pronounce, hindi masyadong pronounce yung skin effect. And hindi yan 1:1, For example, if you have 1,000 ampere na bus bar, magparallel ka ng dalawa, anong capacity niyan? 2,000 ba? Hindi. Tama si Sir Richard. Because of skin effect. Skin effect pa rin. Kasi pinamalaki mo yung kuan mo. Pero, pwede yan ma-reduce yung skin effect pag may gap yung dalawang bus bar. Huwag mong i-close spacing yung bus bar. Skin effect na tapos heating effect pa yung problema mo. So you have to give a gap, at least one thick bus apart. Kung 1 inch yung bus bar mo, 1 inch din yung spacing mo in between two bus bars. And meron tayong table dyan, no? Kanina nalagpasan natin, as a guide nyo lang, ano yung capacity if you are going to parallel 2 or up to 4 bus bars. Meaning to say, pag lagpas na ng 4, ang system mo malaki na yan, no? I-kuan mo na yung voltage mo. I-upsize mo na. Kasi hindi na yan practical, no? Yun lang yung impact. Okay? So I think, may time pa ba? Wala na. So that's it. Hindi ko na natapos yung sa methods of connection tsaka enclosures, but I hope you have gained something. Thank you very much.
Ayan. Thank you, Engineer Brian Pasilan. At this juncture, we are going to entertain 1 to 2 questions. So, do you have any questions po for our topic? How about in the Zoom?
Okay, so it seems that there are no questions. So to award the plaque of appreciation, may we once again request the presence of the 2022 Zamba Sulta chapter. May we request the presence of Engineer Richard O. Lizardo to award the plaque of appreciation.
Allow me to read the content of the plaque. Is hereby presented to Engineer Brian, grateful of his valuable contribution to the electrical engineering as a technical speaker during the 9th Western Mindanao Regional Conference with the team leadership rising above adversity through passion and commitment, leading on the road to recovery. Held in October 8, 2022 at Parsian Garden Hotel, Zamboanga City. Signed, Engineer Mark Anthony Bastian, President of the Sulta Chapter. Signed, Alexander Ko, Governor, Western Mindanao.
Once again, thank you very much, Engineer Brian A. Pasilan. Now, let's proceed with our next technical seminar. Again, for our next guest speaker, we would like to inform you that you are given 1 hour for your presentation. If you hear the sound, you only have 10 minutes to wrap up your presentation. To discuss about switchgear testing equipments with partial discharge, may we call on our guest speaker, who is our 2022 IIE National Vice President External. Let us all welcome Engineer Alberto R. Herrera Jr. A round of applause, please.
Thank you. So, good afternoon po sa inyong lahat. So, congratulations, Western Mindanao chapter, no? Western Mindanao region, I mean, on your 9th. So, it was very successful. So, I'll be discussing 2 topics actually. Switchgear testing and with partial discharge. Okay? Sige, itry lang natin kung po pwede. Sige, presentation mo na, hindi pwede. Okay? So, paki-presentation ano mo? Okay, so I'll be discussing substation maintenance. So as mentioned by our governor from Eastern and Central Visayas, my expertise is I've been in the business of switchgear since 1991. So pag computin nyo, wag nyo na, alam ko mas matanda pa ako sa inyo. So 31 years na ako, but right now, I'm the one doing, yung tapos na kami sa manufacturing, I was transferred noong 2015 as the general manager of Fujihaya Audit, Inspection, and Maintenance, doing the preventive maintenance dun sa mga switchgear and substation natin. Pwede. Okay, so general standard. So, ang mga pinipm natin sa substation are the first private pole, the transformer, the switchgear, circuit breaker, and switch. It shall be tested, no? Clean and check, correct defects depending on the condition, at least once a year. So dun sa Luzon, sa amin, sa Manila, particularly sa Luzon, is medyo mahigpit ang PESA at OBO na dapat when you apply for the permit to operate, you must be able to produce the minimum, yung preventive maintenance test report. No? This one is being required. Sign and sealed pa siya ng PEE. So this topic, you will be able to yung mga i-discuss ko, magkakaroon na ng tip yung mga gustong pumasok sa substation maintenance testing. Kasi, as mentioned, napakaraming factory, no? Luzon, Visayas, Mindanao. And yung nakikater lang namin is napakaliit na porsyento. Kasi nga, ang gusto, shutdown, di ba? Ang mga shutdown natin, December, October, yung Holy Week. So, hindi mo naman makikater lahat yan. So, there is a lot of opportunity. So, in this topic, unang-una, makikita natin ano ba yung procedures ng pagtetest, ano ba yung itsura ng mga testing equipments, and then ano yung standard. So, itong tatlo na to, I will have the presentation given by Oliver and Woody para lahat ng umaten makakuha. And then later on, lalo na yung mga PE o yung REE, pwede na kayong mag-business later on. So definitely, as per IEC, switchgear is a general term covering switching devices and their combination with associated control, measuring, protective, and regulating equipment. Also, assemblies of such devices and equipment with associated interconnection, accessories, and closure, and supporting structure. So, Brian discussed a little bit about switchgear, pero dito, it's more of yung preventive ang i-discuss natin. Yung pinaka-visual, ito yung nakikita natin. This is a 34.5 kV switchgear. So as you can see, dun sa taas, nandun yung indicators, ano yung status ng vacuum circuit breaker natin. Andun yung nasa left side is the protection relay. At yung nandun na may ilaw is the digital meter, and then the control switch, the PTT and the CTT. And then sa gitna niyan is the isolation or the vacuum circuit breaker, no, na ginagamit. As mentioned, sa Luzon kasi 34.5 kami. So I think here, yung is 13.2 kV ata kayo. Yung nandun sa left side is just for dun sa mga bago pa lang, yung RME natin or yung mga newly graduate natin na BSEE, yun yung control natin, normally the battery and the battery charger. Itong switchgear na to, inano namin in a very famous na casino dun sa Makati. So yung Resorts World. Okay? Basically, dun sa substation natin, this is the normally pinaka-single line natin produced by ETAP. So yung mga nag-PPE dyan, our Board of Electrical Engineer, they want a study on the ETAP na, yung nakukuha nating short circuit, tapos sa theory, yung manual calculation, i-compare na natin. So sa testing, you will start dun sa taas, the first private pole, a vacuum circuit breaker. Ang tawag namin dito is double-ended, meaning may dalawang transformer, tapos may tiebreaker kayo. So yung transformer nito, 34.5, down to 400, 230. So ito yung pinaka-system. Normally, I do not know kung meron na kayo dito, yung mga watermark, no? Na ito yung pinaka-design ni Mr. Jess Santos. Wala. So, yan. Palagi ko itong dinidiscuss, no? Kasi in substation testing maintenance, you can see may kulay pula doon. So 34.5, may instrument transformer tayo, then may protection na rin. That is the under and over voltage relay. Kasi as you can see, sa substation testing namin, sa tagal ko sa switchgear business, palaging basta na lang biglang nagkakaroon ng problema, I ask yung isang governor, si Gov. Alex dito, yun daw yung system nyo rito ng Zamboanga Electric Corporation. Electric Cooperative is medyo hindi rin maganda yung quality ng power. So ang tendency, kapag ang switchgear nyo may under voltage relay, automatic, ma-sense niya, no? Kapag nag-under ka o nag-over ka, plus or minus 10%, yun yung PDC natin, automatic, magbibigay siya ng signal to trip your BCB. No? Ganito yung mga nakikita nating electrical ng substation dun sa mga famous mall dun sa Luzon. So ang tendency, pag nag-trip, syempre automatic yan. May transformer tayo dito sa baba. And then transformer natin, pupunta sa low voltage, 400, 230. Meron din tayong ATS doon, di ba? So pag nawalan ng power, pwedeng yung sa taas, mag-trip dito sa magti-trip din sa ACB, bibigay ng signal sa generator to run, di ba? Ang tendency, gumana na si generator, siya na yung nagsusupply ng power, bumalik yung power sa 34. And normally, yung sinasabi ni Go Brian, pwedeng yung 34 mo, nandun ka sa outdoor, nasa labas. Or pwede rin, nandun ka sa indoor. Pero kapag yung 34 natin, wala kayong provision na may mag-on automatically pag bumalik yung power, ang tendency, yung mall na sinasabi ko, pumatakbo yung generator, bumalik na si Meralco, nag-brownout siya ng mga 10 p.m., wala nang tao sa mall, ang natitira na lang guard, hindi niya papakilaman yung substation, di ba? So, ang tendency, tumatakbo si generator for 24 hours. Pagbalik na lang, tsaka lang malalaman na hindi pa na-on yung high voltage switchgear. Okay, yun yung sinasabi ko. Pagdating sa low voltage, may under-over ulit tayo. So yun yung nagbibigay ng signal. Anong solution doon? Dati kasi, ang ginawang solution ng isang mall na yon, nag-hire ng RME na magbabantay lang na if ever biglang nag-brownout sa gabi, pag tumakbo si generator, nalaman na may power na si Meralco, punta siya doon sa substation, i-on niya lang. No? Ganun yung ginawa nung una. So later on, napag-isipan, nagbabayad ako ng isang tao para lang bantayan kung magba-brown out. Kasi kung hindi, 24 hours tatakbo yung generator. No? O kaya mag-hire ako ng facilities na 24 hours. So ang ginawa nila, pina-auto na lang yung sa taas. Okay? So this one is the basics control circuit, no? For dun sa mga basic, yung sinabi ko, this is a DC 110. So pag switchgear namin, automatic, alam ko na kung kami nag-supply, sa tagal ko sa switchgear business, DC 110 kasi kami. So pag ang supply ng BCB natin, DC 110, mas malamang kami nag-supply na. So pictorial view. So automatic, pictorial view, may instrument transformer, be it 34.5, here 13.2 kayo. Magbibigay ng signal, 110 volts, may under-over, automatic magbibigay sa industrial relay ng signal, ititrip niya yung BCB. So ito yung pinaka-normal function, basic function nung switchgear natin na BCB. Now, let's go to the, ano ba yung mga ginagawa sa preventive maintenance? The pinaka-minimum, kung maliit lang normally ang planta nyo, the office of the building official may require you baka at least may thermal scanning report kayo dun sa mga panel boards natin. And this is being done before and after PM. As mentioned, papakita ko sa inyo ang procedure. So this is the one being done nang naka-live, no? Live ka. Kasi thermal scanning, kailangan may load ka in order to determine kung talagang may mga nag-hit na doon sa ano natin, sa mga panel boards natin or sa mga substation equipment natin. So general inspection, at least 50% unload. No? Kung mas maganda, naka 80 to 90% kayo ng load, mas maganda mag-thermal scanning. You open the back panel, capture the electrical equipment, either using fluke, then return the acrylic, and then of course, create the report using nga yung thermal imager natin. So as mentioned, procedure, pagkatapos ng procedure, ano ba yung instrument? So you can use, right now kami, I'm not brand, no? Pero ang gamit talaga namin fluke. Okay, thermographic, of course, kailangan may clamp ammeter, and then anomaly classification. Ito yung standard. Okay? So dito sa standard, you can see temperature difference based on comparison between similar components. Kaya kailangan live is 1 to 3 degrees normal. Temperature difference upon comparison between component and ambient temperature, 1 to 10 degrees. Then low overheating, 4 to 15, tertiarious, and then critical. Nandiyan yung temperature niya. So ito yung pinaka-standard. Okay, so this is based on NETA, table 100.18. So you can see, kaya may current transformer. Kasi hanggat maaari, makuha nyo yung load, RST. No? Kaya kailangan talaga live. So you can see here, automatic, 39.0 dun sa isang pase, 36, then 34. So dun sa standard natin, findings, rated load in ampere. So this is just an MCCB, no? 41.4. So kita nyo na kagad. Hindi balance, no? Medyo mataas yung load ng R phase. So possible loose crimping lugs or unbalanced load. So recommendation, yung mismong may 39 degrees na yon, bago pa man mag-PM, kasi PM is shutdown works, so mapape-prepare nyo na. You need to recrimp it. I-retighten din nyo. So, dun sa unang single line na pinakita ko, we'll start first with the first private pole. Okay, the test procedure, I will not go into detail ng item 1, 2, 3, basic na yan. Ang testing natin will start dun sa 4, 5, 6, 7. So conduct physical and visual inspection, perform greasing, cleaning, bolt retightening, conduct painting, the metal pores of the pole, perform, ito yung testing ngayon. Perform simulation of the mechanical operation of the LBS, and conduct contact resistance on the load brake and the fuse assembly, and then also conduct continuity tests for the power fuse units. So after test procedure, ano ba yung equipment? So later on, medyo bibilisan ko na to, no? Kasi almost pare-pareho siya. So you can use for contact resistance any tester. So ang sample lang namin dito is the Megger. We also have the insulation resistance, either Metrel or Fluke ang ginagamit namin. We have the fuse continuity test, an ordinary tester. Then the ground resistance test. Then pagkatapos ng equipment, ito naman yung mga sample test report para maipakita natin ano yung basis ng passing, pass or fail natin. So for contact resistance, you can see test standard contact resistance in each pole shall not deviate above 50% compared to each pole. So pag nagko-contact tayo, kailangan more or less magkakalapit yung reading natin. So that is based on ANSI NEMA MTS 2011. That contact resistance should not have a greater or a 50% difference between the highest and the lowest reading to each pole. IR. So itong dalawa na to, mapapansin nyo mamaya, palaging yan. So ibig sabihin, yung test equipment ng contact at saka insulation resistance. Yan yung mga una nating bibilin. If you're wanting to go to a PM business. So sa IR at shall abide as NEMA MTS Chapter 7 and Table 100.1. Ano yon? Ito. So, given voltage, kung 250 volts, use minimum test voltage of 500 volts, 25 mega ohm. Kung 35,000 volts tayo, o yung 34.5, you can use 2.5 na DC tester, kV, or an insulation resistance of 5 mega ohm. Sample test report, again, after is the ground resistance. Kasi normally sa first private pole, may ground doon, di ba? So you can measure the ground resistance na. Grounding resistance shall not exceed more than 5 ohms. This is based on NEC 50.56, 5 ohms. Pero, sa PEC natin, inallow as per PEC 2017, Article 2.5.3.3.4, that's 2, it must be 25 ohms or less. So definitely, pag first private pole, for safety natin, mas magandang meron tayong basket, no? So now, let's go to high voltage and medium voltage, PM. So yung mga basic 1 to 4, sa testing na tayo, item 9. Conduct electrical testing. So nandun na naman si contact resistance, of course BCB naman, no? Meron ding LBS. Conduct IR na naman, BCB and high voltage main buses. And then of course, since may vacuum circuit breaker na tayo, may protection relay na tayo. So conduct testing of protective relay. So after the procedure, we have the testing equipment. So BCB, sa main bus, yan yung mga tinetesting natin, contact, IR. Sa main bus, IR. Sa LVS, contact, IR. So you can see, you can start na pala, contact and IR. You can start na doing preventive maintenance. Instrument transformer, ito medyo additional equipment to, TTR and IR. And then of course, yung mga lighting arrestor natin, IR pa rin yan. Standard, sample test report, ganun pa rin, katulad nung dati. No? Since may contact tayo, yan, IR tayo, now may nadagdag. Kasi nga may PT na tayo, the TTR. And then, of course, may protective relay na tayo. You have a protective relay tester. So, ito ang medyo mahirap matutunan, protective relay testing. Kailangan talaga medyo may training tayo dito. Contact, upaulit lang to, ganun pa rin yung standard. NEMA MTS, not more than 50%. Sa IR naman, table ng NETA, 100.1. Sa TTR, ito, percent error should not exceed plus or minus 0.5%. No? Kaya lang dito, ako sa tagal ko na sa testing, minsan, tinitignan ko rin, ano ba yung from yung output ng PT natin, potential transformer, kung okay pa rin naman siya, ginugo ko siya. So, protective relay, ito naman ang standard natin. It will be dependent kung ano yung manufacturer's relay test report niya, yung curve ng relay. Again, sa low voltage, we will go procedure. Na item number 9, contact resistance again, ACB naman. Kasi hindi na siya vacuum circuit breaker, air circuit breaker naman tayo. Then conduct IR again. So ACB and LBSG main bus. Ito nadagdag. Kasi low voltage ACB na siya, meron na rin tayong micrologic testing for each ACB. Kung ano yung brand na ginamit natin. And then if you have a capacitor, since low voltage na to, you can do capacitance measurement and IR for each capacitor units. Sa mga equipment, as mentioned, contact, IR. So sa ACB, yan yung mga testingin natin. IR, contact, trip test. Sa main bus, IR. Sa capacitor, of course, IR and capacitance test. Sa series reactor, IR and winding. Sa protective relay, calibration ng protective relay, the trip test. And then sa IR, the mga picture ng equipment, ito. So trip test unit, as mentioned, since ACB natin, wala na siyang protective relay, nandun na mismo built-in na sa ACB. So kung ano yung brand ng ACB nyo, may pan-test doon na microburst trip. So yung nasa taas is using the LSIS, the one from Korea, yung dala dito ng isang exhibitors natin, yung UNCAO, at saka ng TriStar. O ito namang sa baba. So kahit kami Fuji Haya, we're the one, dala namin is Fuji Electric. Meron din kaming pang-test ng Fuji breakers na Micrologic. Pero since nasa PM business ako, may mga customer din ako using Mitsubishi, I need to buy also para makapag-test ako ng Mitsubishi Micrologic test. And of course, the capacitance test and the protective relay. Standard, ganun pa rin. Ito, hindi ko na ulitin to kasi bibigyan na lang kayo ng copy. No? Yung table 100.1. Standard, yung sa contact resistance. Sa capacitor, so measured kVAR of the capacitor under test shall not deviate 10% from its rated kVAR. So this is based on IEC. Pero syempre, capacitor, lalo na yung dala namin na capacitor which is coming from Japan, the Suzuki brand, ito talaga, yung capacitance niya. In fact, ang capacitor, you can test kahit live, di ba? Just use a clamp ammeter, mariread nyo yung current, compute nyo yung kVAR niya. No? Baliktarin nyo lang. Pero hanggat maaari, ito yung sa standard natin. So for the trip test, it will be based doon sa brand na ginagamit nyo as per manufacturer. Sa protective relay, as mentioned, ano pa rin yan? Manufacturer standard. Now, let's go to transformer. So sa transformer, test procedure, yung mga nandito, item 6, ito yung mga standard testing. So dito pa lang, lalo na pagbago pa yung transformer ninyo, ito yung minimum. TTR, winding resistance, insulation resistance and PI, conduct oil DBM, and conduct excitation current test. Yung mga iba na are optionals. No, kapag medyo hindi maganda yung mga result na nakuha nyo dito, you can do the Furan test, different test pa, or the DGA. You can also do that. So equipment testing, so sa mga oil immerse, ito yung standard na 5. IR, winding, TTR, oil DBM, IPF. Actually, IPF, medyo optional din siya, no? But you can request it, lalo na pag medyo lumang-luma ng transformer natin. Then for mga dry type, ang nawala lang of course, kasi dry type na siya, wala na yung oil DBM. Testing equipment choose. So mga pictures lang to. So mga ulit lang siya nung dati. Ang nadagdag lang is the oil dielectric breakdown voltage. And then of course, this is our new equipment, the IPF, insulation power factor test. So sa sample test result and standard, IR, yung pa rin, yung table 100.1. Sa winding is winding resistance must near or adjacent windings. That is as per IEEE C57 or NETA. Winding resistance must near or adjacent windings. The adjacent winding shall not exceed 1%. For the TTR, as mentioned, it's plus or minus 0.5. IEEE C57 or NEMA MTS standard. For the oil DBM, test result are average value should not be less than 26 kb. So that is as per NETA MTS ATS standard. So sample test result for IPF, this is very new. percent IPF should not exceed 2% at 20 degrees. So, but this one, may table, depende kung ano yung klase ng oil na ginagamit natin. Oil maximum, silicone maximum, or tetrachloroethylene maximum, and hydrocarbon. So, may standard siya. So, ito yung latest ngayon sa preventive maintenance. So, you can see, para siyang thermal scanning, no? So, may mga tumatango-tango dito. So, kung meron na kayo, lalo na yung NGCP o yung mga nasa cooperative, so ito talaga ang bago na kailangan ngayon natin. Anong tawag dito? You can see, meron din siyang image, no? Pero nakikita nyo, ito ngayon yan. This is called partial discharge. So, ibig sabihin, doon sa matataas na voltahe natin, 3 kV and above, bukod doon sa thermal scanning, kasi thermal scanning is load. Kapag medyo, natin, talagang nagiinit na, loose connection na, doon natin makikita yung temperature. Dito, 3 kV and above, meron nang ibibigay sa inyong image, no? May ganyan. May distance, may image, no? PD count. So, partial discharge is pulse counting. So, meron siya. The invisible threat. Ibig sabihin, 3 kV and above, kapag ginanyan nyo, pinidi nyo yung equipment nyo, yung substation ninyo na live siya, may makikita kayo. Pag may nakita kayong invisible threat, automatic. Nagkakaroon na ng arc flash yung ating substation. So ito, yung frequency and range of spectrum, tinataas, tinababa nyo lang in order for you to see kung ano yung effect natin. So yun yung frequency band para mas luminaw yung invisible threat. Sige, yung next na. So nakita nyo doon, yung partial discharge, ito na yung second topic ko para medyo marami akong masagutan na tanong sa inyo. Kasi medyo nag-exceed sigo, Brian. So hanggat maaari, alam ko naman, second to the last topic na ako para na natin yung closing din. Tsaka maganda yung last topic din ni BPI. So as mentioned, ito na yung bagong latest, we call it the partial discharge. You can see dun sa likod niya, no? It is sound. Partial discharge siya. Hindi siya katulad ng thermal scanning. Pag inano nyo, ang ini-emit niya is the sound. So, ibig sabihin, yung hissing sound na, no, na nagkakaroon na kayo ng hissing sound sa switchgear, sa transformer, 3 kV and above na live portion natin. Kapag nagkaroon kayo nung nakikita nyo may image na gano'n, na may invisible threat, there's a possibility, lalo na kung mga component yan, malamang sasabog na yung switchgear natin. Nag-i-start na yung hissing. Ang hissing sound is yung mga ganyang naririnig natin. Medyo ma-alarma na kayo. So hanggat maaari, kung meron kayo ng ganitong equipment, you can prevent talaga yung pagsabog. Kasi ngayon, normally, reactionary tayo, di ba? Pumutok si PT, palit, di ba? Kaya lang, pag naputukan kayo ng PT, nasa line side yun yung una kong single line. Nasa line side siya. So, hindi siya makikita ng protective relay natin, di ba? Ang magtitrip, yung cooperative, yung fuse sa first private pole. Pag pumutok sa amin, lalo na sa Luzon, pag naputukan kayo ng PT, pumutok si Meralco fuse sa first private pole, si Meralco, hindi kaagad kayo bibigyan ng power. Ang sasabihin nun, pa-testing nyo muna yung switchgear nyo. Kahit identify nyo na, ay hindi sir, PT lang May stock yung aming PM provider ng PT. Palitan na namin, tapos, i-energize na namin kagad. Hindi, ang Meralco sa Luzon, papatest muna ang kable, no? Papatest ang transformer, patetest yung switchgear nyo. Sign and seal pa ng PE dapat bago siya magbigay ng go signal na i-on uli kayo. So medyo magastos. Pero dito, sa partial discharge, you can see, ang taas, di ba? First private pole yan. That is a 34.5 kV na first private pole. Ang thermal scanning, kahit ganyanin nyo yan, mahirap, di ba? Pero ito, yun, nag-i-emit na pala ng sound yung isang component nyo sa poste. With this partial discharge, ma-aware na kayo na bago nyo po siya ipa-PM, kung gaano kalakas na yung sound na yon using this equipment. So mga topics natin dito, ano ba ang partial discharge type, anong consequences, and then yung ginagamit namin ngayon is fluke. Then mga partial discharge project, magsasample ako. Kasi baka ito, na-experience ng mga nasa facilities dito, o yung mga nasa electric cooperative, o yung doing the preventive maintenance of substation. Sample project, and then finally, ano ba yung mga basic recommendation namin? Para at least kayo, kung kayo yung PE na na-consultant nitong planta na to, you can recommend the correct solution kagad. So dito na naman tayo sa single line na una kong pinakita. As mentioned, 3 kV and above. So kapag low voltage na, balik kayo sa thermal scanner. No? Hindi pwede ang partial discharge. 3 kV and above. Eh dito ata 13.2 kayo. So you can use partial discharge. So kanina, since 34.5, definitely, kahit matataas na voltage, kahit 4.16 pa yan, sa Luzon may 4.16 kami doon, may 6.6. Hanggat maaari, syempre, yung safety. Kailangan talaga qualified yung personnel kasi minsan pagbukas nyo, baka yung pinto, no? Minsan yan, may 3-point lock rod. Baka pag nasa likod, bumaksak yung 3-point lock rod. Wala na yung mga glass or mga dead front doon. Bumaksak sa live part. Diba? So, be very extra careful. So, nasabi ko na to. So, pag partial discharge, pati yung PT doon na 34.5 o 13.2 sa inyo, pati yung CT na yan, the BCB, yung nandito sa baba ng mga surge arrestor, no? Yung mga lightning arrestor din. And then the XLPE. Pwede nyong gawin yan. Kasi pati yung XLPE, pag yung contractor ninyo na nag-terminate, medyo hindi maganda, may lalabas na partial discharge doon eh. Magkakaroon ng hissing sound. Ma-identify niya. Okay, ayan, no? So, what is partial discharge? These are small electrical sparks that occurs in various points of equipment insulation that are rated 3 kV and above. PD creates corona, electrical trees, or surface tracking in an imperfect insulation and arcing that deteriorates equipment until failure. Since PDs are not unnoticeable by the naked eye, yung equipment will help you trace these insulation imperfections and discontinuities in an optimal way that thermal scanners cannot see. Kailan nangyayari? Or saan, no? Yung high voltage line natin, transformer, turbines, busbar inside of cabinets. Pero dapat busbar inside of cabinet, 3 kV and above, ha? Hindi pwede sa low voltage. So electricity generation facilities, transmission networks, and distribution networks. Effects ng partial discharge. Mechanical, thermal, and chemical damage to insulators, conductors, that may end in catastrophic arc flashing. Ano ba yung mga type ng partial discharge? So may 4 na type yan. This one, the void or the internal discharge, usually occurs due to manufacturer's defect, solid insulation, highly destructive to insulation. If a void PD is discovered, the insulator should be replaced. So ibig sabihin, kung yung switchgear manufacturer nyo, 3 kV and above, pagka-deliver, pagka-energize, ipa-PD nyo na para makita nyo kung meron ng mga component o equipment doon na medyo defective pala yung mga insulators. Mapapalitan nyo na kasi under warranty pa. Yan. Isa naman, surface discharge. Also known as surface tracking. Ito yung nakikita natin normally sa mga potential transformer natin na parang may mga gumuguhit-guhit, no? Potential transformer, no? Current transformer. Surface discharge ang tawag doon. Or kaya yan, that is a vacuum circuit breaker, pwede rin. Yung pinaka-bushing. Ito, corona discharge. Is a discharge to air from the sharp surface of a conductor. Ito, medyo 2021 lang namin binili yung partial discharge namin. Pero hindi kami kasi nag-PPM sa mga electrical utilities. Yung may gases na, no? Yung parang may kuryente na, arcing electrical breakdown, producing a plasma discharge. So plasma na yan. Consequences, alam na, as mentioned ko kanina, switchgear failure. Sabog. Sabog kaagad. Kung hindi nyo na-correct, yung nag-PM sa inyo, hindi rin na-correct, minsan nga, ka-PPM lang kasi nalinis, lalo nang may tendency na kung may partial discharge na yon at hindi na-correct, automatic, pwedeng ka-PPM lang, sumabog pa rin. Major disruption. Major disruption at saka very expensive. Kasi biro mo, December 30, 31, sarado lahat ng mga, ano yan, di ba? Electrical supplies. Bigla, nasabugan kayo. Or nung nag-PPM, inabot. Automatic. Kung nyari ngayon, kahit pala hindi shutdown, pumutok, si PT nyo, sumabog, maghahanap kayo ng stock. Buti kung yung contact ninyo, kung 34.5, 110 na potential transformer, may stock siya. Normally, wala. Pag meron man, medyo tatagain kayo, di ba? So, ang tendency, malaking cost, very expensive. Eh, kaya lang, pinupukpok ka na, ikaw yung facilities manager. Nawalan tayo ng power, kailangan namin ng power. So, ang tendency, stress na stress normally ang PM yan. Kasi, tumatakbo yung generator, magdamag lang na tumakbo yan, nagkukos ka agad yan. No? Lalo na dun sa mga malls. Automatic, kailangan mapalitan. Eh minsan, hindi na kayo makakatanggi dun sa pinaka-supplier natin. Ayan. So, yan yung pinaka-ano niya. As you can see, yung nandun sa likod, sound. So, sound ang kinukuha niya, kino-convert niya yung sa sound, at kaya dito, nakikita nyo yung image. So, ang kinakapture niya pala, partial discharge, yung ini-emit na sound. So hopefully mamaya, marinig nyo, makita nyo no, yung isang sample ko. Frequency range, 2 kilohertz to 100 kilohertz. Distance, ang taas up to 120 meters. Kaya yung first private pole, di ba, normally, mga 15 to 16 feet yan eh. Andito ka sa baba, gaganunin mo. (25 frame per second) and then reporting functionality. Itong PD na to, may leak at PDQ mode. So presently ngayon, nandun lang kami sa PDQ mode. Kasi yung leak, pwede rin siya dun sa mga gases, yung SF6 natin. Or any gases for that matter. Minsan nga, yung sinasabi, yung mga sa semico na may gas sila, ma-identify niya rin yung leak. Pero right now, I'm more focused kasi nga sa PM kami, nandun kami sa PDQ mode. You can see, as mentioned, kapag nagkaroon kayo ng image, partial discharge. No? Yun yung una. Kapag nagkaroon kayo ng image, may partial discharge. PD count, 30,122, pulse counting, invisible threat, the frequency range spectrum, then the palette. So frequency band. And then yung sa taas at sa baba, may nakalagay dyan decibel. So yan is 29 decibel and 27 decibel. So sound talaga yan. So susunod na dito yung mga sample projects. Yung mga nagawa na naming companies when we started this one on 2021. So the URC, sa Goto, these are Japanese. Yung isa is Denkerry. Honda, o Honda cars, o tsaka yung Honda motorcycle, Brothers, yung printer, JMS, Bandai, and then ito, baka ano nyo, Petrowin is yung sa Nabasaklan, yung wind ano nila doon. Yan yung mga ano namin. So JMS Healthcare. So mag-sample tayo ng projects. So ito, project number 1, first private pool. Normally, first private pool, basket lang tayo, di ba? Cleaning, at hindi nyo yan makikita. Kasi normally, yan, makikita nyo lang yan pag shutdown na. O gamamit kayo ng basket. Malapit na malapit yan, di ba? Kinukunan natin. Kitang-kita nyo dito pa lang. Hindi nyo yan makikita kung hindi kayo nagpapa-PM ng first private pool. Kalawang na yung mga bolt. No? Siyempre sa PM, you need to replace that hanggat maaari stainless bolt ang gamitin para medyo mas tumagal. Traces of rust and condensations are found in multiple parts of the first private pool. Yan, yun. Yan, no? Bago pa man kami nag-PM, pinidi na namin, buhay siya, 34.5. Ayun, may nakalagay na kagad, oh. May 30,580 na PD count. Distance, medyo mabilis yung pagkuha ng engineer ko. Hindi niya na i-reflect, no? Pero ang PD count na 30,584 pulse count per minute, it was detected sa rightmost and middle phases of the first private pool. At 40, frequency band is to 60 kilohertz. PDQ is coming from the bolted connection of the arrestor porcelain where the bare copper is connected. So, hindi pa kayo nag-shutdown, i-schedule nyo yan normally during December, April. Alam nyo na kagad, kailangan pala, may PD na ako doon. Kailangan mag-prepare ka na. Kung ano man yung papalitan doon, magpa-code ka na para during your PM, automatic, mapapalitan na kagad. Hindi yung after PM, magbibigay ng recommendation sa inyo, sir, sira na yung strain clamp nyo doon sa taas, palitan na. So medyo nagtatagal. So ang susunod nun, next PM pa uli kayo. Pag natsambahan kayo niyan, pumutok si fuse ng Meralco o yung utility nyo, ang i-require sa inyo as mentioned, testingin mo kable, testingin mo yung switchgear, testingin mo yung transformer, sign and seal ng PEE. Bago kita bigyan ng fuse uli, bago ko yan ipon. So dito, yung recommendation namin, of course, rectification and replacement ng multiple parts ng first private pool. So alam nyo na yung gagawin kagad during the PM itself. Kung pwedeng mag-shutdown yung planta, kung Sabado, Linggo pwede, papalitan nyo na kagad. So ito naman, vacuum circuit breaker. So ang mention ko sa inyo, kapag may invisible threat, may problema. Nag-umpisa na ang hissing. So dito, you can see, the high voltage was scanned. This is also a 34.5. The PCB showed PDQ in its bushing na ng BCB. 28,000 to 30,000 pulse count per minute was detected at phases S and T, Fuji BCB. So supply namin yung switchgear. Yung switchgear kasi na to, 25 to 30 years na. So recommendation namin being, kasi product namin to, ayun, remember this recommendation. Baka maka-encounter kayo. Ang nakalagay lang, the installation of space heater and hygrostat will help protect the switchgear from varying weathers and temperature that will deteriorate the electrical equipment inside. Yun lang pala, space heater muna. So space heater, lagyan natin, additional, mawala yung pinakaano niya doon. Tapos, itry uli namin na i-PD. A week or two for monitoring. BCB again, you can see, yun, kitang-kita nyo, basta may image, may partial discharge. Yan, as mentioned kanina, yung hissing sound na yan, hindi nyo naririnig. Ha? O hindi nyo nakikita sa naked eye. Sound yan ng PD. Kaya doon nyo lang siya makikita. So, 28,739. Recommendation namin, same pa rin. Installation ng space heater. Pero kapag nilagyan namin ng space heater, after 1 week ng paglalagay, pinili namin, ganun pa rin, papapalitan na namin yung BCB. Pero immediately, hindi naman kagad siya palit. O ito, meron kami, wall bushing. Pag sinabing wall bushing, normally, kung 3 vertical kayo, may mga BCB, may bus bar na tatawid, may wall bushing mo na siyang nilalagay. Yung wall bushing na yon, nag-i-emit din pala ng partial discharge. So, PD count niya 30,000 to 30,898. So, recommendation namin nung una, space heater pa rin, pero after almost 6 months pinatry namin tumagal. Ganon pa rin siya. Ito mismo, yung project namin na to, ginagawa nila today. Pinapapalitan namin yung wall bushing. Ayan ang delikado. Pag ito nakita nyo na, no, PT or CT, current transformer, ibig sabihin yan, meron ng yung surface tracking na sinasabi ko. Medyo kapag hindi nakuha ng space heater, kasi palagi yun muna-una. Pag hindi siya nakuha, automatic magpa-schedule na kayo ng shutdown. Kasi baka maputukan pa kayo. So, can we try this one? Yung video? Yeah, i-play mo. Pwede? Yan, sige. Ito lang yung sa gitna. Ito, di ba?
Ayun, no? Ano na siya?
Nakita kayo may nag-spark?
Nadiklap?
Hindi kong babae. Alam niyo naman ang babae, di ba? Pag medyo excited na, medyo ando na yung konting response. Ayun, no? Nakita nyo? No? So, hissing sound yan. Di ba sabi ko sa inyo, pag narinig nyo na, mas delikado. Kasi yung pinapakita ko sa inyo, ano pa lang yung instrument pa lang, PD. Pero dito nakikita nyo na, no? Yun na, identified na kagad siya talaga. BCB bushing uli. Kasi ito, nung sinupply namin siya bago mag-pandemic, 5 years na, tapos nag-pandemic, never nakapag-preventive maintenance. Tapos, yung substation, indoor siya, yung pala pinasok ng tubig. Almost inabot yung substation. So, tapos 5 taon. Yun yung pinaka-ano. Sige, paki-play din to. Mas lumakas, di ba? Lumakas yung, nagpiprito na talaga. Kalilinis lang namin ito. Kalilinis lang. No, yung kanina, piniem namin, automatic. Kasi nga, 5 years Nung nilinis namin, bakit mas lumakas? Nung ipidi namin, napag-alaman namin, talagang yung BCB, yung draw-out cabinet niya, ang dami ng rust. Kasi nga, pinasok siya ng tubig, walang nailagay na space heater, tumagal ng matagal mga 2 hours daw yung tubig doon. Hindi naman pinasok mismo. Pero yung doon sa substation area, ang taas ng tubig. So yun yung naging cause na. Upper bushing, emits partial discharge. Ayan. Yun yung nagkukos. No? You can see here, discharge type. Ito yung report ng PD. External, internal, BC bushing, 26,000 pulse per minute, and recommended to install additional space heater. Pinalitan na namin, pero later on, medyo ganun pa rin. Pinapalitan na namin yung BCB. And nung buksan namin yung BCB, marami siyang traces ng rust. Doon mismo sa cradle at saka sa BCB bushing. Napamahal kasi 5 taon lang yung BCB. So supposedly, hindi ganun. Napabayaan kasi. No? Hindi siya nagpa-maintain. So another one, ganun pa rin. Basta, pag nakakita kayo, ngayon tatanungin nyo ako, Sir, kanina panay ang pakita mo. Testing procedure, equipment, standard. Ano standard sa PD? Kahit saan nyo po hanapin, including yung principal namin na pinagkuhanan ko nito, wala pong standard. So parang ngayon, since nung 2021, lahat ng project namin ito, parang ginawan ko ng table. No? na ano yung nagiging experience namin. So yung pag may mga range na nga ng 30,000 and up, no, pag hindi siya nakuha ng space heater, automatic palit po yun. Palit, be it PT, be it CT, be it XLPE, kahit po XLPE. So matitrace din po nito. So you can see, before and after. May partial discharge siya doon, nilagyan namin ng space heater, wala na siya after. So yan. What could have caused this? Yan yung sinasabi ko. Ito yung unang single line ko na nasa line side yung PT. So automatic, ayun, putok. So pag pumutok yan, sabog, sumabog, line to ground una yan, pag sabog, line to line na, hindi magtitrip ang protective relay natin kasi nasa line side to. Ang magtitrip, fuse ng PT at saka yung fuse ng electric utility nyo. At pag yun ang nangyari, automatic. I-require kayo, ipatesting yung high voltage cable, ipatesting yung transformer, at saka yung ating switchgear. Yun namang isa, nag-PM na nga kayo. Yung nag-PM sa inyo, nakita nyo, may surface tracking na. Lalo na yun, puti-puti lang yun sa baba. Kala nyo, normal lang yun. Baka na alikabok, na umano, nag-i-start na po yun. But without the PD, at naked eye lang ang gagawin ninyo. Hindi po. Yung isa, medyo nakaka-alarma na, kulay itim na di ba? Pero pag pinidi nyo yan, ang taas na niyan. Ang taas na talaga ng pulse count per minute niyan. Okay? Ito yung isang project namin. Hindi namin yung supply and switchgear, pero kami yung pinag-PM doon sa electrical contractor. Outdoor siya. Ito, outdoor. Automatic, kaya lang kami tinawagan kasi contractor namin siya na palagi kaming kinukuha. Hindi kami nag-supply ng switchgear dito. Outdoor siya, BCB, pumutok si PT. Pagpunta namin doon, wala pa kaming partial discharge during that time. Wala pa. So, nakita na namin. You can see, panel to panel yan, tatlong vertical section, outdoor, yung dalawa load break switch, yung main vacuum circuit breaker. Tignan nyo in between panel, di ba? Walang barrier or walang metal. So, kumbaga, pag tumingin ka dito, first BS, hanggang doon sa feeder niya, tagos na tagos yung bus bar. Nandito yung BCB. Siyempre, pag may BCB ka, may CT ka, may PT ka. So ito, yung tatlo na yan, lahat dyan, outdoor ka, ulan, araw, bago pa lang yung switchgear. Pumutok si PT. Kasi nga, wala siyang space heater na nakalagay. Ang daling nag-deteriorate yung potential transformer, yung 34.5 kV nila. Pumutok nga, yun yung sinabi ko, pumutok muna yung utility doon, 34.5 yun. Bago, syempre, pag pumutok yun, tinawag kami. Sige, quotean mo kami. Testingin si XLPE, testingin si switchgear, testingin yung transformer, bago pa papalitan yung PT. So, dalawa yung cost niya na. At immediate siya. As in, switchgear manufacturer kami, minsan, may stock kami na PT. Or kaya, pag may isang project, gawain ko to Kasi, siyempre, medyo matagal na ako. Pag may isang urgent, hinihiram muna yung isang naka-install na sa switchgear, tapos dinadala muna namin sa site. So itong naka-install dito, in-order na lang uli namin. Minsan sa site na namin, kami na nagkakabit para ma-install siya. Okay, so this is my company, my company, Fujaya Audit, Inspection, and Maintenance. And yes, marami akong babaeng electrical engineers. Kasi mas magagaling at saka medyo mas masisino pag babae. Pag lalaki kasi maya-maya ang bilis umalis. Kasi gusto ka agad ng ibang challenge. Okay, that's all. Thank you very much.
That's right. Guys, so thank you so much, Engineer Alberto R. Herrera Jr. So at this moment, we are encouraging everyone to raise their questions regarding the technical seminar on switchgear testing equipments with partial discharge. For the on-site participants, you may step in front of the microphone to ask And for those online participants in Zoom, you may raise your questions in the Q&A box for it to be acknowledged.
Oh, may questions ba? Yun. Sige, sir. Sir, dito na lang para mabilis.
Thank you, sir. Sir, I just want to make a comment on the grounding resistance that we mentioned earlier about the 5 ohms and the 25 ohms. The IEEE 80-2000 specifies that the transmission substation should have a impedance of 1 ohm or less, and the distribution substation 5 ohms or less. Why do we have this very low grounding impedance or grounding resistance? It is because those substations are made up of grid grounding. So grid grounding should have very minimum 1 ohm for distribution or 1 ohm for transmission substation and 5 ohm or less for the distribution substation. This includes for the communication facilities like radio station, TV stations. The 25 ohms, according to NEC 250-56, also PEC. Yeah, kinopya natin yan sa NEC. The grounding resistance for rods, pipes, and plates is 25 ohms or less. So if we have transformer station pole mounted, we only have one grounding conductor and a grounding rod. The resistance of that is 25 ohms or less. Thank you po.
Tama po, tama po. Kaya lang, as mentioned, I specified 2 standard. Kasi normally, yung 5 ohms or less, ito yung sa akin, no, sa tagal ko sa pag-PPM, ito yung mga normally bago. Kasi pag tumagal na po, minsan, yung grounding rod natin doon, napo-corrode na rin, yung mismo yung nakakonekta. No? So, doon sa PEC kasi, talagang nakaspecify, pwede siya 25 ohms or less. Kasi, as mentioned by sir, tama po eh. Ni-refer po natin yun sa yun po yung pinaka-standard. Pero hanggat maaari po, kasi, di ba, yung sinabi ko doon na grounding tester, ito na rin po yung latest. Kasi normally, meron tayong tinatawag yung 3-point, di ba? Yung tinutusok. Ang problema doon sa tinutusok, minsan, kapag semento na, wala kang tutusukan. So itong bagong equipment na yon, either, hindi po siya block talagang yung mismong grounding na yon, current po ang minamention niya. Tapos yung current na yon, nagre-register siya doon kasi may voltage yun. Magko-compute siya ng ohms. Kaya ohms na. Tama po sir yung comment niya. Any more?
Ayan, so we have one question online po, sir. Let me just read the question. If the adjacent resistance of the winding is more than 1%, is the transformer need to be changed? What is the possible problem scenario that would happen in the electrical system?
So tama po ito, no? Napakahigpit po sa winding resistance. But as mentioned, lalo na po pag oil, may nirefer po ako na limang standard testing ng transformer. Hindi lang po sa winding, TTR, winding, contact, excitation. So yung 5 po na yon, pag medyo nakakita po kayo ng ang tawag doon, ng results na medyo hindi na akma sa standard, doon po tayo nagbibigay ng recommendation. O can we do current test? No, additional? Or kaya yung very basic, pag oil, DGA test. And then, pinaka-worst case, pag after ng DGA test, meron pa rin pong pangit na result, is automatic. Palitan yung oil. Yun yun. Papalitan natin ng oil. Pag hindi pa rin po pwede, kasi alam naman natin ang transformer, di ba? Mahal. Pero sa naging experience po namin, kung po pwede, yung mga transformer natin, lalo na po yung mga hindi nagpapa-PM, pag 25 years na po, at may mga result na gano'n, better if you are the facilities manager, if you're the later on, pag gano'n na po, mag-start na po tayong mag-budget na talagang kailangan na po nating palitan. Pero since transformer po yan, hanggat maaari, yung mga standard testing natin, mag-optional tayo pag may nakita tayong hindi na siya pasado doon sa standard. Optional test, and then hanggang dumating tayo doon talaga, i-recommend na natin replacement. Okay? I think that's all.
This time is a question. In Zamboanga City, it's a common problem of PTCT failure because of the migratory birds that we have in the city. Then they make the power lines, the transformers, and the PTCT at their resting place. So the accumulation of cook will create the arc flash and will burn the terminals of PTCT. My question is, can we protect PTCT by installing it upside down? Opo.
Siguro po, kasi utility po yan, call po nila yan, no? Pero normally, naka-experience po kami niyan eh. It is, nandun pa po sa Sapesa Zone, may isang bird na malaki nga. Yung kulay itim, ano bang tawag doon? Uwak. Tama. Talaga magaling sa Tagalog si BPI. Eh. Pag gano'n niya, pumutok. Pag putok niya ngayon, yung lahat ng planta doon na apektuhan kasi doon nakakonekta. Eh. So una, mga ginagawa po namin doon, ang nire-recommend namin, may mga tinatawag tayong bird spike. Diba? Bird spike. Para yung ano rin nila, doon lumalabas. Kaya nga lang din, kapag talagang umano yung pakpak at line to line, minsan wala tayong magagawa. Sir, hindi ko kayo masasagot, di po kayo utility eh. Pero kung makakausap niyo po dito yung Zamboanga Electric Cooperative, maganda po yung suggestion. Kasi pwede naman kasi, no? It's more of kakablehan mo lang naman. Yung city naman, iwa-wire mo lang ng tama. You can do it na. Diba? Okay? Maganda, no? Kaya inanuan ko yung ano eh, para medyo maganda yung tanungan natin. So yung copy naman po ng presentation, nakakakuha po kayo dito. I think si Gov Alex ko nangingi na po sa amin. Bibigyan na lang po yung lahat natin. Para po yung gustong pumunta sa preventive maintenance business, to tell you the truth, yung ako po from Central Laguna, 2015, nagkaroon po kami ng mga PE mentoring doon. Yung batch 2, batch 3. Hanggang ngayon po, batch 15 na kami. Automatic po, doon pumupunta ang negosyo. Kasi napakalaki po yung market, no? For preventive maintenance. Lalo na po, pag talaga pong, ito po ba ini-implement ng DOLE or POPO na kailangan lahat ng building nyo, for example, this one, may kailangan preventive maintenance. Hindi kayo bibigyan ng permit to operate. Pag walang preventive maintenance, sign and seal by PEE. No? Pag wala, hindi kayo i-renew. May mga, doon po sa Luzon, meron pa rin pong hindi nagpa-follow, pero sa PESA po, definitely sa PESA, required po yun. Hindi po kayo makakapag-renew. In fact, pati yung electrical design analysis, requirement po yun. Kailangan, bago ka kahit wala kang expansion, kaya kung makapag electrical design analysis ka na o PSA ka na, hingi ka ng PDF dun sa nagano sa'yo para later on, sign and seal na lang ang papel. Okay po. Thank you very much po sa mga questions. Thank you very much.
Alright, thank you very much, Engineer Alberto Farmer. Now to award the plaque of appreciation, may we call on Engineer Joseph Makindang to award the plaque of appreciation.
Dear Beto, Alberto R. Teta, professional electrical engineer, in grateful recognition of his invaluable contribution to the Institute of Integrated Electrical Engineering, Technical School, in Western Mindanao Regional Conference, the theme, leadership, rising above adversity, passion and commitment, on October 6 to 8, 2020, Palacio Club School, Marshall Garden Hotel, in Zamboanga City, within the 8th day of October 2020, signed by Engineer Mark Anthony Sebastian, President of Sambasuka Chapter, Engineer Alexander Dico, Governor for Western Mindanao.
Thank you so much, Engineer Alberto R. Herrera Jr. We are now down to our last but not the least technical seminar. Again, a reminder for our next guest speaker. We would like to inform you that you are given 1 hour for your presentation. If you hear this sound, you only have 10 minutes to wrap up your presentation. To present and talk about leveling, uptrend, and standards of education for electrical engineering, let us all welcome our guest speaker, who is our 2022 IIEE National Vice President Internal, Engineer Lyndon R. Bage. A big round of applause, please.
Dito na lang ako sa baba para doon kayo nakatingin sa ano. Nagulat ako sa second floor, kasala na yung nandun. Kala ko kinasala naman si John Herrera eh. Okay, so this is the last leg of the presentation kasi this is the last conference we have in this year. But initially, we present itong mga upcoming changes, particularly in the education. Sinong nag-aaral pa rito ng college? Taas ng kamay. College. Kasi kahapon marami kayo. Pero nung fellowship night, umuwi na kayo. Sino naman dito yung REE? Taas kamay. Huwag kayo mahiya. Yan. PE. Taas kamay. Yan. Tapos meron daw hindi licensed electrical practitioners pero umattend. Ano kaya ibig sabihin nun? Of course, para matuto. So itong lecture na to is not as what we want nung tayo nag-umpisang kahapon ng mga presentation. So the first question, yung bang first day of presentation, may natutunan kayo? Dapat. So dito, ipapakita namin ano ba ang latest trends in educational system, particular sa mga bata. Kasi sa mga edad namin, medyo patapos na tayo, but we still starting to learn more. Kaya tayo nagpa-practice, tayo ay umatin ng webinar, but not for the points. Kasi kung magbilangan tayo ng points, palagay ko yung iba sa inyo naka-100 na. Sa dami ng utang sa sa PRC, mga undertakings, but later on babayaran daw din natin 'yon. And a good thing, when I renew my license, mas matagal pa yung waiting time sa internet para maganap ng araw kaysa dun sa pagpunta. Dahil pagpunta ko doon, ang aga ko sa Robinson, alas 6 pa lang nandun na ako para mauna, pero nag-start yung alas 10. Pagdating ko doon, ako lang palang magre-renew. So nakuha ko siya in 30 minutes. Kaya hindi naman mahirap na ngayon. Basta kompleto ka lang ng document. So I'll start with my title. So this is Leveling Up Trends and Standards of Education for Electrical Engineers and Technology Curriculum. I presented this because I'm the academe. Sabi nga kanina, kung saan akma yung tanong, doon natin itatanong. So dito, most likely magtatanong sa akin is academician. Sinong teacher? Taas ang kamay. Wala. Ayun, isa. Ngayon lang nalaman dito pala sa Mindanao, isa lang ang eskwelahan. Yung Mindanao State University lang ata. Kaya pala mababa ang membership nyo. It's only 1,081. So medyo maliit pala yung mga eskwelahan dito, hindi ganun karami. So medyo we need to develop more. Kaya ito po in-encourage namin sa inyo. Ay, dito pala daw. Diyan ako ngayon. So, I just give you some backgrounds first why we need to acquire education. So, education may be acquired through formal course of instruction offered by institution established for the purpose, or informally through means outside the formal school system, such as on-the-job training, exposure to work. Yung ginawa ni BPX, in-expose niya yung work niya, nagkakaroon ng sharing, and that is part of education. Self-experience, self-learning, and of course, training under out-of-school study program. Actually, that is the future activity of the IIEE. We go with training. Kasi ang training is one of the important things for us to learn, especially yung mga bata pa. Sa edad namin, siguro additional knowledge or another experience. In my case, if I'm in the academe, I go with industry, then we go for training. Again, it is a lifelong, or rather, life is a continuing education. So there another way is yung lifelong process. So sabi nga ng iba, pag ba't natapos ka na ng 65 years old, hinto ka na sa trabaho. Depende sa inyo yon. If you want to do the work as an electrical practitioner, you just update your license, then you can fulfill the work. Wala namang retirement ata. Ang retirement mo ay yun na, pagka mahihiga ka na. Okay. So, legal basis po tayo. Napakaswerte ng mga bata ngayon dahil free tuition fee. Nung tayo nag-aaral, lalo na sa government, medyo mura pa noon pero may bayad pa rin. Sila po, zero. Papasok lang sila sa eskwelahan, gobyerno magbabayad, tayo po yung taxpayer. Kaya dapat ang mga bata, pag natapos ng pag-aaral, dapat tutulong sa gobyerno, tutulong sa Pilipinas. Kaya po maliwanag dyan that in the Constitution, Article 14, the right of all citizens to quality education at all levels and shall take appropriate step to make such education accessible to all. The purpose of education is to provide an individual with knowledge, skill, competence, or usually desirable qualities of behavior and character. Kaya binabanggit namin whenever we do this kind of activity that don't focus, especially mga officers dito sa ating region, don't focus on electrical practice. You can also focus on attitude, values, ethics. Kasi ang isang engineer o isang RME or even a student, number one is attitude. So isang importante po yung, kaya ini-inculcate yan na dapat lahat ng aspeto para matuto tayo includes behavior. So ba't nagkaroon ng changes? Because of the globalization, nagigera sa Ukraine at Russia, apektado tayo. Everything na nangyayari sa buong mundo, damay tayo. Especially in economy. The globalization is the breakdown of national borders and emergence of regional economies, particularly in Asia, Europe, and even in America. There is also what we call mobility, the demand of comparability, national qualification framework, and regional referencing framework. Nagkakaroon ngayon ng comparison with the work ng iba't ibang country. Kaya we need to upgrade our own workforce. Another is yung national political economic context. We are now on the era of BBM. Tapos na tayo sa Aquino clan. So balik na naman tayo sa Marcos clan. The question is, in terms of political issue, maliwanag pa rin that there is a mismatch between educational qualification. And I will discuss it more. So again, education is a cornerstone of every nation's social and economic development, and universities plays an indispensable part in education, research, and innovation. Kaya natanong namin during the chapter's officials meeting kanina, katatapos lang, ang emphasis ko is, let's look on the universities. Opportunity, isa nga lang daw. Why? Kasi ang mga anak natin ngayon, anong forma ng pag-aaral? Puro virtual. Virtual. No? Paano mo ituturo ang electricity sa virtual? Sige nga, gumawa ka nga ng ilaw tapos isaksak mo dyan sa kuryente. Hindi natin nakita. Namatay yung bata, so kasalanan pa nung teacher. Pero that is the new norms. So what our organization would like to is to help them provide additional learning, mag-ampun tayo ng school, i-adapt ng chapter, then try to help the school, the teacher, or the electrical practitioners in the academy to provide new information para yung bata madagdagan ng knowledge. Napakahirap. In my case, as a teacher, ang hirap magturo. Tuturo mo yung complex number, paano mo kayo susulat. Kaya medyo matindi ngayon ng ating system. So, with this, we really need to harmonize our higher education in Tibet. Tibet is the acronym ng Technical Vocational Education Training. Yan po yung NMYC, yung mga senior dito, yung NMYC, yung National Manpower Youth Council. Yan po yung TESDA ngayon. So, ginawang TESDA to uplift yung educational system dun sa ating tinatawag na skilled labor or skilled worker. Pero again, in this presentation, if you are a skilled worker, you are a white-collar job, blue-collar job, isa lang ang ating main aim, to promote the quality and image of higher education in Tibet so that there will be an employment, a greater mobility of professional talents in skilled labor. So kung nandun ka sa portion na yon, wala tayong magagawa because that is your option to work, but you need to improve and you need to learn. That's why with this presentation, I hope yung mga nasa academe will help the student, yung naman nasa industry, you share what you learn from your work. So magmula kahapon, puro sharing, di ba? Halos sharing iba. And of course, they give new technologies. And as far as my concern naman as academician, then I share to you what's the latest trend in your education. Now, nangyari itong Philippine Qualification Framework way back in 1998 pa. Sinong presidente noong 1998? Mali. Di nyo Estrada kaagad. Ramos muna. Ramos muna yan, 1998. Sino sumunod? Estrada. Pero walang 2000 to 2003. What happened? Ay, sumakay ng jeep. EDSA 2. EDSA 2. So, hindi napansin ito. Hindi na bigyan ng pansin. Kaya in 2003, that is the time of Macapagal Arroyo, they created the Philippine Tibet Qualification Framework, in which, in-improve further, they called it now an executive order para may policy making. Then in 2012, nagkaroon ng institutionalization of Philippine Qualification Framework in which President Pinoy na siya. Until such time in 2014, nagkaroon ngayon ng RA 10647, Authorized Education Act, which promote PQF. Dito ngayon nagkaroon ng K-12. O sino may anak ng K-12? Taas kamay. Ay, walang may anak dito. May anak na nakapasok kayo sa K-12. Ayun. Or, hindi pa nagki-K-12 kasi nasa grade 1 to 6 pa lang. O grade 1 to 10. Now, or kung gusto nyo magkaanak, gusto nyo ba mag-engineer ang inyong anak? Siyempre, kung ano yung ng tatay, yun din ng anak, di ba? Sabi nung tatay, anak, mag-dentist ka kasi sayang yung dentist chair. Walang gagamit pag walang dentista. O di kung ikaw ay electrical practitioners, anak, mag-electrical practitioners ka, sayang yung tester. Masisira. So kung ganun ang pamangyayari, kailangan ang bata naka-enroll sa STEM. Science, Technology, Engineering, and Mathematics. Explain ko yan further. Binibiting ko lang kayong kabuuan yan. In 2018, ayan, naging RA 10968, the Institutionalization Act of the PQF. O, di si ano na yan? Duterte na. So ngayon pa lang tayo nag-evolve. Pero ang ibang bansa, lampas na dyan. So nagkaroon ng political issue kasi sa atin, kaya medyo nagbagal. And napadali noong 2015, kaya hindi na pag-aralan mabuti. nilahat natin na maging K-12 ang lahat ng program, in which there are only 8 programs that are being focused by the World Trade Organization, yung ating tinatawag nating World Trade Act, in which meron tinatawag na memorandum agreement na engineering ay kasama. Nilahat nila, so wala tayong magawa kundi naka-K-12 ang lahat ng mga bata. So aside from STEM, nandyan ngayon yung HUMSS, Humanities and Social Science. Merong ABS, yung Accounting, Business and ano yung S, di ko matanda yung S. And yung pinakasikat is the GAS. Ano yung GAS? That is General Academics and Sports. Kaya kung bata gusto lang mag-basketball, doon mo siya papasukin. Kasi laro lang ang gusto niya. Ganun ngayon nangyari sa K-12. Nagbago ngayon ang isip ng bata. Sabi niya, gusto ko tayo maging doktor. GAS ka, nako, malayo. Kasi ang requirement ng doktor ay STEM. Kaya ang bata dapat maaga pa lang, tinatanong nyo na. So yung anak kong hulin, nakapasok sa K-12, civil engineering siya. Pagpasok niya dito ng pag-aaral, virtual kaagad. Ayun. Puro virtual. Kaya yung sa bahay, puro laptop, puro monitor, puro ML. Yan. So yan ang problema ngayon. So, tingnan nyo ngayon yung edad. Ang K-12 is 19 years old pag graduate. Di ba nung panahon natin, sir, pag 19 years old, nagtatrabaho na. Kasi allowed yan by DOLE. Kaya ang bata ngayon pag graduate, 23 to 25 years old. Gusto na mag-asawa. Tapos na. Yan. So yan ang ano ngayon. Kaya yung mga future husband and wife dyan, pag-aralan nyo na kung anong plano natin sa mga bata. Kasi hindi na magbabago ito. This will be the start of a new era in education. And that is the Philippine Qualification Framework. Ito, para sa lahat ito, I hope you will understand my presentation. Kaya ako binanggit kanina, if you are an REE, RME, PEE, you can promote yourselves through what we call Philippine Qualification Framework or Philippine Credit Transfer System schematic diagram o yung tinatawag nating access ramp. Doon sa baba, andun yung K-12, we call this basic education. Kapag ang bata gusto na magtrabaho, he can do work provided that he undergoes techbook. Yung mga electrician. Ikukot ko muna, electricians. Kasi pagka nag 6 months na practice ka at binigyan ka ni TESDA, electrician ka. But the problem is not a licensed electrician. Pero base sa batas, pwede. Kasi yung batas na isang batas, nagko-complex sa isang batas. But it is a law and we need to follow. So, you will take book. Then you can work, you can earn your experience. Ito na ngayon, gusto mong mag-aral kasi gusto kang maging manager. Wala kang tinapos. Pupunta ka ngayon sa next matrix. Ang tawag doon is informal, non-formal. And one of the most famous is ETIAP. Hindi ko na sabihin yung school kasi ayoko mag-promote. So, may mga school na nagpo-provide ng Expanded Tertiary Education Equivalency and Accreditation Program. Dito, ina-accredit lahat ng inyong experience, training attended, seminar attended, like this one. Iipunin niyo yan, then i-apply niyo sa TESDA at bibigyan kayo ng tinatawag na portfolio assessment. In which, if you require to take the exam, magte-test kayo, practical test, magte-training, then bibigyan kayo ng certification. Ang tawag doon ay recognition of prior learning. Kaya yung susunod na mga gagawin natin, you need to have an access of your certificates. Sa edad namin dito, medyo na kami. malamang nawala na yung mga certificate, nawala na yung mga diploma. So, mag-umpisa kami sa panahon ngayon. Pero sa mga bata, you have to collate all these things kasi in the future, that will be part of your accreditation to become a level higher than what we expect. Ang tawag doon is leveling. So, let's proceed. Kung ikaw ay nakakuha ng mga informal, non-formal, at napasa na yan sa CHED, PRC, and DepEd, including DOLE, magkakaroon ng tinatawag na credit transfer. Anong credit transfer? Ito yung pagkikredit ng mga nakuha nyo dun sa susunod na step. Para bang may isang estudyante na lumipat sa eskwelahan, sa ibang eskwelahan, nagpa-credit ng subject. Yun yung pinaka-literal. Pero dito, i-qualify yung mga trainings nyo in which magsusut ba dun sa tinatawag na CHED equivalency certification. In which, yung mga nakapula dyan, yung mga network na yan, dyan natin binabase yung credit transfer. So pag ikaw ay qualified to go in a higher degree, then ibibigay sa inyo yan through credit accreditation. Nandyan ngayong NC 1 to 5, and of course, nandyan yung ibang alternative learning system. Ito yung mga sample nito, yung mga artista na hindi makapag-aral, mag-apply dyan, bibigyan ng module, pag pumasa, tapos na ng kurso. Ganun kabilis. Pero again, this is just not implemented yet kasi inaayos pa yung credit transfer system in which ito ay throughout all the sector. Hindi lang sa mga artista. Kasi karamihan artista nag-a-apply dyan sa bubang yan. Okay. Kung ikaw naman ay papasok in a formal education, you have the BS, Master, and PhD. Yan yung normal na program na binibigay ng ating government. So then, higher education, then post degrees. So in summary, ito siya. This is now our official qualification framework in Philippine setting. We label ourselves as 1 to 8. Yung 1 to 8 na yan, may equivalent yan through TESDA and through higher education. So, if you are in the TESDA equivalency, yun yung mga hindi nagtapos ng pag-aaral pero nagtatrabaho ngayon, nagkataon na bigyan ng RME license, magpupul kayo dyan from N1 to diploma. But diploma is not yet available. So pinakamataas na level sa inyo is NC4, but you apply for accreditation sa TESDA. Para dala-dala niyo yan kung mag-abroad kayo. You are certified by the Philippine government. NC1, NC2, NC3, NC4. Ngayon, kung ikaw ay nag-aaral, o yung tinanong ko kanina, yung mga bata, fourth year ngayon sila. By the way, first batch ngayon ng graduate ng 4-year degree program. By next board exam, sila yung unang uupo o mag-exam na 2 years physical, 2 years virtual. So, bahala na si Batman. So, binabanggit naman natin sa BE yan that this is the situation. So, ewan ko paano nila tinitimbang kung paano magkakaroon ng exam by that kind of situation. Virtual exam. Oo, parang virtual exam daw pero nasa examination room ka. Intra. Hindi outside, nasa loob. So, once na-graduate ka ng degree program, automatic magpupol ka sa level 4 to 5. Kasi hindi ka pa nagtitake ng board exam. So, 4 to 5 ka if you are not a licensed degree. So, pwede ka magtrabaho, pwede ka mag-abroad, pero qualifying level mo lang is 4 and 5. Once nag-board exam ka at pumasa ka, you are now in the level 6. So, pwede mo nang gamitin yung TOR mo, transcript of record, diploma. Siguruduhin mo lang na yung diploma mo ay medyo recognized ng CHED yung school. Kasi in my situation as technical TC or other chairman ng engineering sa CHED, merong isang ring nagreklamo na bansa, tinanong yung eskwelahan kung ito ba ay totoo. Nung makita ng CHED na alarma, kaya nagmadaling survey kung ano bang may school na nag-offer ng engineering. And there are 512 schools offers engineering program in any program. In electrical engineering, there are around 330 na school. Yan. Eh yung eskwelahan pa lang yun ay hindi na, sarado na. So itong tanong, paano kaya nag-aral doon yung bata, eh yung nagsarang eskwelahan ay medical school? Pero nung tiningnan yung record, meron pala. Kaya lang, dahil konti estudyante, nagkataong graduate siya ron, yun ang dala niya. Hindi kilala, like UST halimbawa, hindi kilala yung school. Kaya tinanong. So, hinanap yung dokumento. Di ginastify, pero pinauwi din sa Pilipinas yung magtatrabaho sana sa abroad na yun because of that credential. Kaya ginagawa ito para lahat ng school ay ma-credit at malaman na that is a Philippine government school in the Philippines that is recognized by the Philippine government. Kaya dapat alamin ninyo kung yung school ay recognized by the Philippine government. Until maging master's degree ka, maging doctorate degree ka. O tanong, bakit wala dyan ang PRC? Ang PRC kasi hindi involved on the framework. They are the one who handles the regulation. So sila ngayon magre-regulate sa atin. Kaya doon sa Philippine Qualification Framework na yon, na-organize ngayon ng Philippine Statistical Authority na from 0 to level 8, meron na tayong level of education. So, inadapt na nila yan. Kaya pag nagkakaroon ng statistical survey, tinatanong kayo, yun, nililevel na ngayon. So, meron talagang mismatch in terms of qualification. Okay? So, yan yung Philippine Standard Classification of Education. Now, I want to share with you with this so that you will understand bakit nga ba kinaklasify. Ang engineer should be address yung tinatawag nating complex engineering problem. Gusto natin i-emphasize yun that if you're an engineer, you answers complex engineering problem. Kaya nga ang subject ngayon sa first year sa college na math ay calculus na. Wala na yung ating mga trigo, wala na yung algebra, solid means mensuration. Hindi, si Rizal nandiyan pa. Ikikwento ko sa iyo ba't si Rizal ay nandiyan pa rin. So, lahat ng math ibinaba na. Kaya, ang bata pag hindi STEM graduate, may hirapan. Pero did you know by statistic, mas mahina pa yung STEM graduate kaysa doon sa non-STEM. Bakit? Kasi nag-aaral sila. Pinag-aaralan nila yung calculus. Samantalang yung non-STEM, they expecting na yung tinuro sa K-12 ay tama na. Base sa statistika, kaya yung ibang school, mini-merge yan, lalo na pag wala silang estudyante. Bakit? Lahat ng estudyante ay nasa government. Kaya talagang malaking gastos ng gobyerno ngayon. Second, if you are a technologist, ang technologist is a 4-year degree without passing the engineering. Technologist kayo pwedeng tawagin. Or other programs na electrical engineering relevant, like yung Bachelors of Engineering Technology, Bachelors of Industrial Technology, Major in Electrical Technology. Yun yung mga yan tinatawag nating technologists. Pero 4-year degree na rin sila. Now, how we compare with the engineering? Yun yung tinatawag nating qualification. If you pass the engineering qualification, then you can enroll in engineering. But if you not pass the qualification, but you want to be an electrical practitioner, pwede kang dalhin sa BS BS, or rather, Bachelor's of Engineering Technology, major in electrical. Kaya po, dun sa bago nating CBL, we do encourage them to be a member. Kasi wag nating yan, gusto niya lang maging electrical practitioners, kaya lang yung level ng kanyang learning medyo mababa. Gusto niya, join natin para mas marami yung ating group para matalo natin yung ibang group. So alam niyo na yun. Next, technician. Nung kapanahonan namin nandito sa grupong to, except si Ining, meron tinatawag na electrician. Yung electrician dati ay nag-aaral lang ng 1 year, 2 years. Yun yung electrician dati. No? Tama, electrician o technician dati rather, we called it technician. So yung technician na yon ay group into this category. Kaya makikita nyo, hin-highlight ko, that the technologies shall only define and applied engineering procedures, processes, system, or methodology. So sila yung nagre-represent nung dinesign ng engineer. Pagdating sa technician, sila yung nag-i-implement. Respectively, a wide practical procedures and practices. So gagawin kong layman para mas maintindihan. Normally, pagka magdi-design ka, you are a licensed electrical engineer or a PE per se. Yun yung logic natin, ha. Pagdating sa technologies, sila po yung nag-i-implement. Kung ako si PE, ikaw si REE, REE, ikaw mag-implement nito. Or kuminsan, di ba, REE, design mo to, check ko na lang, and I'll sign. Nadi-distribute yung work. Pagdating doon sa dulo, yung technician, yan yung mga RME. Anong gagawin ng RME? Sabi nung RE, akit ka sa kesame, kabit mo yan. So, nadi-distribute natin. Kaya kuminsan kasi, kaya nagkakaroon siguro ng parang miscommunication because sometimes the PE is the REE and the RME. Nilahat niya na yung pirma dun sa dun sa permit. So, share para makita na ito ka, you are the designer, ito ka as RE is the implementer, and the third one is the skilled. Siya yung mag-a-apply. Kaya sa education, ina-emphasize ito that we cannot put all of us in one level. Hindi po pwede lahat hindi lahat pwedeng manager. Dapat meron ding foreman, meron ding head, and of course merong skilled worker. And that is part of the yung general philosophy of work. Not all of us are boss. So pinapakita yan dyan. Kaya sa pag-aaral, dinidefine natin on what level the education is now. So, binanggit ko kanina, upon graduation, you are level 5 and you must address the 3 domains: the knowledge, the values, the skill, the application, the degree of the independence. Knowledge and skills that are mainly theoretical and abstract with significant depth in some areas together with wide-ranging, specialized, technical, creative, and conceptual skill. Kaya pag nagturo kami, expect that the student only learn 1% of the totality of his work. The 99% is on the work itself. Pag sinabing Ohm's Law, ano ba yung Ohm's Law yan? Di ba yun ang pinaka-basic law that we know? Pero kung di mo alam si Ohm's Law, that's a big problem with you. Pero pag nag-fault calculation na, iba na yon, no? Kasi that is another step of level. 6, 7, and 8. Baccalaureate, post-baccalaureate, and doctoral degree. Now, how we relate now in the work? Diyan pumasok si PRC. Ang tawag doon is Career Profession Specialization Program, CPSP, in which tayo po ay member, and the chairman of the committee is Honorable Jimmy Mendoza for the PRC part, and for IEE, si former PEE chairman, Atoy Laines. So pinagtatrabaho namin sila para mabuto. So yung 6, upon passing the board exam, you have now to demonstrate a broad and coherent knowledge and skill. Meaning broad na. So si Ohm's Law, medyo tatas mo na ng level yan. Anong susunod na law, boy? Okay. Kirchhoff's. Ano pa? Susunod. Ano na, yung marami na, yung mga theorems, theories, then pasok ngayon yung mga applications. Dapat, alam mo nang i-apply yan. Kasi pumasa ka na sa board exam. Once you learn more about your discipline, magkakaroon ka ngayon ng interest to lift your professional requirement. Doon ka ngayon mag-PEE. And PEE, marami ng mentoring para dumami tayo. Alam nyo bakit Singapore, ang doctoral degree doon is almost 20,000. Dito. By the way, may bagong PEE ngayon. So, yun. And there are 4,000 students who passed the board exam. So bagong member natin yun. Kaya wala si President, naghati kami. So siya ngayon yung mag-oath doon. Kaya kaninang madaling araw, ewan ko natulog pa sila. So, dumiretso na doon. So, kami ngayon yung naiwan. The next is yung supposed to be doctorate degree in education. Pero in our case, once you pass the REE and you pass the PEE, automatic level 7 ka. But you need to be recognized by PRC. Because not all PEE applies yung degree niya sa work. Kasi minsan nag-PE ako pero hindi ko naman pinapractice. It's just for my own promotion, etc. But the practice is not you did not function yung supposed to be naging PE ka, hindi mo naman siya ginamit, then you might not be earned this level 7 kasi i-apply mo siya. And this is already approved. May resolution na ang PRC dyan. So all PE are basically level 7. Okay. Gusto mo mag-level 8. Yung level 8 na yan is, again, ina-apply sa PRC for you to be recognized in highly advanced systematic knowledge and skill of highly specialized. Sa kabila is advanced. So, advanced, highly, so mas mataas. Doon ngayon pumapasok yung expertise. So, your PE, you have to be expert in one aspect of practice, which I will be given to you later. Now, ano ang halintulad ng ito sa academe? Kung ikaw may master's, kung ikaw may PE, sabi sa batas pa lang ng PRC to, hindi pa to batas ng kalahatan, equivalent daw yan sa master's degree. So, ikaw na teacher, PE ako, dapat master's degree na ako. May possibility in the future if the credit transfer will be approved. PE ako, equivalent sa master's degree, kaya lang sa academe kasi medyo may problema because they pass their master's degree through education. Tayo, through practice. But nevertheless, we need the experts in the academe. Kasi kami, we are expert in teaching, but we are not expert in application. Kaya mayroong mga ibang school talagang nag-hire sila ng practicing engineers. Okay. Doon sa doctoral naman, Pagka kayo ay naging specialized in a particular area of electrical practice, pwede kayong tawaging level 8 kapareho ng doctoral. So ganun hinahambing. Kaya pag level 8 kayo, expert ka in a particular specialization. Bakit? Kasi kung interest mo mag-abroad, okay? Interest mo mag-abroad, kailangan ma-meet mo yung requirement ng abroad na pupuntahan mo. Sa ASEAN, meron na po silang qualification, kaya merong ASEAN Qualification Framework. Itong sample na to ay Malaysia. So kung pupunta ka sa Malaysia, if you want to be recognized as electrical engineer, dapat ma-meet mo yung leveling nila. Sila 9. Pero based on the study ng mga expert in a qualification framework, kaya lang naman naging 9 kasi nagkakaroon sila ng sub-leveling. But in the comparison, kaya ng ating 1 to 8. Sila 1 to 9. Pero pareho lang ang content. Pero once na ma-recognize ka, pwede ka magtrabaho ng Malaysia, Indonesia, Singapore, na engineer ka. Bakit? Kasi sa Canada, I have a classmate there, parati kong sinasample. REE siya rito. Pagdating niya dun sa Canada, ano siya? High school graduate. Accredited as high school graduate. Bakit? Pagtingin sa transcript, algebra. Kasi di ba ang subject dun, algebra. Ay, algebra. Okay, high school. Pero ano siya, professional license sa Pilipinas. Pagdating doon, skilled worker. Eh wala siyang magagawa kasi ang asawa niya nandun. O ang gusto mo, hiwalay sila. So nandun, nagtiyaga. And sa Canada, acceptable na yung accreditation. So habang nagtatrabaho siya, hindi niya sinasabing electrical practitioner siya kasi ayaw ng mga Canadian doon nung mayabang. Yung IM ganito, ayaw nila noon. Gusto nila makita kang ito yung tinatrabaho. Hanggang sa nalaman na, ano ka pala, I'm an electrical engineer in the Philippines. Okay, tinanggal siya sa trabaho. Pero, dinala siya sa mas mataas na level. Talagang yung mismong kumpanya ang nagpo-promote sa kanya kasi hindi niya na kaya, hindi niya na mababayaran yung level. At ang huli niya, bago siya magretiro, no? Ano siya, manager ng subway system sa Canada. Yun ang huli niyang work. So na-fulfill niya yung yung dream. So yung kinita niya ron, dinala niya sa Dumaguete siya nata nakatira. So nung tinawagan ako, pag may kailangan talaga tumatawag sila. Mag-expire na yung license niya. Sabi ko, punta ka dyan sa chapter, mabilis na ngayon. Mabilis nga. Nung makilala siya ng chapter, pinag-member na doon. Doon na siya ngayon. So ganun ka-importante ito kung mag-abroad kayo. Pero kung hindi, dito nga sa Philippines, katulad namin, ano lang yan, it's more on pride. Recognition of yourself if you want to apply. Pero the organization is willing to help us. So, ito na po yung mga senaryo na nangyayari ngayon. Nag-exist pa rin RA 7920, isang issue yan. 1995 pa siya, o bilangin nyo na ngayon. So, medyo luma na si RA 7920. Sino bang pinanganak dito na RA 184? Meron pa ba? Kayo daw, sir? RA 184? Oh, abot pa pala si sir. Ilang taon na kay sir? Hindi, sasabihin ko na. Meron kasing naprobahan sa meron naprobahan, 50. Meron kasing naprobahan sa board kahapon. We are looking for member na naging member sa IAE since 1975. At dapat ang edad niya ay 70 years old. Which of which? Kasi may magbibigay kami ng recognition sa mga oldies na member pa rin ng IAE. At alam nyo ba na may nagsoli sa amin o nagbigay sa amin ng sign and seal na ang number niya ay 1. Binigay nung empleyado niya kasi kinamatayan, naiwan lang doon sa opisina, nung ginigiba ni opisina niya, nakita yon, naalala si IAE, binigay. Lolo ni Dasa. Yan ang palang kauna-unahang PEE, number 1. Yun. Tapos kauna-unahang PEC na preserve niya doon. Kaya binigay sa amin, then siguro we will show it to you during the ANC. Kaya tingnan nyo, no, puro outcomes based. So we need to level up our education. So yun ngayon yung mga trending ngayon sa ating Bachelor of Electrical Engineering. So dinidefine yung electrical engineering. Okay? By the way, So ito yung definition, maliwanag na dapat ang pinag-aaralan sa eskwelahan ay relevant sa definition ng engineering. Even ethics is one. Other social sciences included. Okay? So, may research, may thesis, may product development. Kasi tayo, we give way do sa mga research and development ng mga company. So, if you lean to do research, then binibigay yan ng pag-aaral, sa pag-aaral. Again, level 6, so clear na sa atin yan. Ito yung RA 7920, yung mga work nyo. Dinefine masyado ng RA, inisa-isa. Okay, para makita na lahat ng mga yan ay pwede nating trabahuin. Okay? So, lahat. Okay? Kaya yan, nagkakaroon ngayon ng misinterpretation na ng mga batas. Kasi maliwanag dun sa atin, we have now the instrumentation and control system, the software development, the safety engineering. So ang safety engineering ngayon is being taken by all the discipline. Kaya dun sa ating specialization, we include safety engineering. Kaya kung kayo nagpa-practice sa safety engineer, then you are in a good track. Ito ngayon yung 8. No? Sinimplify para mas makita kung saan kayo level. So at this point in time, kung yung work nyo ngayon, dapat mag-fit yan. So are you now in the system planning, power system maintenance and operation, power system protection and control, electrical system design and inspection, layo ng mga saga LGUs, electricity market, are you part in the business in electricity, construction and project management, in which mas marami yan, pero later on, nagkakaroon ng sub-discipline or sub-specialization, pero medyo madugo na yon. Kaya medyo unti-unti natin, then later on, yung mga future leaders ng IEE will develop on a particular sub-specialization. Then on my part, number 7, I'm in the engineering education research, then dinagdag yung electrical safety engineer. Ang tanong, nandiyan ba kayo sa 8? So siguro doon na nandiyan kayo sa 8. Wala bang beautician dyan? Or couturier? So, dapat naka-embed kayo dyan in the future. Okay. Ito, tinatanong mo si Rizal. Ayan. Alam nyo po, sa ginawa ng CHED, kasi ang CHED is a macro eh. We cannot do away with Rizal. Kasi letter E, yung tinatawag nating outcomes. Letter E, a graduate of higher education institution shall preserve and promote Filipino historical and cultural heritage. Kaya meron pa rin tayong Rizal. Ang Rizal ay isang batas. Hinanap namin, hindi ko lang matandaan yung RA niya, panang Commonwealth, na dapat daw sa level ng pag-aaral, si Rizal ay kasama. Kaya nung bata ka pa, elementary, Rizal na. High school, Rizal pa rin. College, Rizal pa rin. Ang tanong, anong kinalaman ni Rizal sa electrical engineering? Wala. Pero pag-aralan nyo si Rizal kasi babagsak kayo. Yeah. Philippine history. Tama yan. So, may bago ngayong dinagdag, yung general education curriculum. There are around 36 units. Ang isang popular ako doon, yung mathematics in the underworld. Modern world. Di ba mathematics in the underworld? Nakuha nyo ba yon? Oh, yun. Anong tinuro doon? Ang nilagay niyo statistic. Pero basically, ang laman dapat noon is all aspect in mathematics. Saan ba nanggaling si math? Kaya mathematics in the modern world. Pero tawag ko doon underworld. Tsaka yung isa, yung pagsasarili. Ano ba yun? Self-understand. Yun. Understanding ourselves. Sa Tagalog, pansariling, pagsariling sikap. Pinagsama yon na social science, pinagsama yun na sociology at saka psychology. Yan, yung mga napakagandang title ngayon. Pansariling pagsasarili. Tama ba yung Tagalog? Alam niyo ba Tinagalog? Kasi nung time na kasama yung Filipino 1 and 2, di ba tinanggal namin? Kasi siyempre yung competency niyo magmula nung bata kayo, nagtatagalog kayo, nagpipilipino kayo. Tinanggal namin. Sorry kung may Filipino teacher. Nagalit sila, dinimanda kami sa Supreme Court. Hanggang umabot Supreme Court. Sabi nung Supreme Court, alam nyo na yun nung bata pa kayo tinanggal. Para lang magkaroon ng subject yung mga Filipino teachers before, siguro wala na ngayon dahil 4 years na. Tinagalog ngayon lahat. Kaya yung panlipunang pagsasarili, pansarili, parang ganun. Sa English nun? Understanding yourself. Understanding the self. Yun. So, dinagdag yun. Kaya, yan. Okay? Pero, ito yung dapat nating matutunan. Kaya yung mga future leaders dito or incoming official next year, dapat aakma yung inyong mga webinar, seminar, particularly on this outcome. Yung bang ituturo sa inyo ay may mathematics, magde-develop ba kayo or conduct ng appropriate experiments, katulad ng ginawa ni BPX kanina, although more on lecture, pero ginawa niya is the presentation of his experiments or testing in their work. Sinishare niya ngayon. Then, design, yung mga fault calculation, harmonics, etc. Nagpo-fall sa C. Letter D, function effectively on multidisciplinary and multicultural teams that establish goals, plan tasks, and meet deadlines. So yun yung grupo natin. Di ba? This is a multicultural team. That's why during our opening, yung ating doxology is generic. Wala po tayong na-emphasize of religion. Kaya dapat pasok siya on letter D. Letter E, formulate and solve problems. Kung ito yung may mga workshop or may training. Recognize ethical and professional responsibilities in engineering practice. So, pinag-aaralan yung mga batas, yung mga codes, etc. Communication effectively with range of audiences. So, itong dalawa, graduate na ba kayong dalawa? So pinagpa-practice natin mag-MC. So, pag-graduate nila, yan ang trabaho nila, MC. So, ganun, di ba? At least they learn as part of the outcomes. Then, articulate and discuss latest development in the field of electrical engineering. Demonstrate knowledge and understanding of engineering and management principle as a member or leader in a team to manage project of multi-disciplinary environment. So, itong mga to, nililevel natin according to the profession. Kaya nung misang nagpunta kami sa isang conference at meron pa rin nata dito, ewan ko lang kung natuloy, yung mga RME nagkakaroon ng skill competition, yung pinapakit sa poste. So, parte yan ng ating outcomes. Ibig sabihin, ini-improve natin yung ating system. And that is not included in the subject matter sa mga bata o sa mga klase. Bawal kasi yon na magkaroon ng contest na yung bata, pakitin mo sa poste. Di ba? So, sa mga professional na yon. Okay? So, pag gagawa kayo ngayon ng inyong webinar, seminar, workshop, chapters activity, ito lang yung gagamitin nyo for application sa CPD. I-match nyo lang kung yung bang lecture nyo is more on a knowledge lang or problem-solving skill, or skill-oriented group or attitude-oriented group, yun yung ilalagay yung outcomes. Kaya in my case, nasan ako dyan? Ayun, doon ako sa attitude-oriented group. I presented what we do in the educational system. So yun ang magiging attributes natin or outcome ng ating activity. Kasi nilalagay yan sa form. Ito, mahigpit ng CHED dito. Ang PRC. You have to fill up what is the objective of the program, topic, learning outcomes per topic. So nilagay ko dyan, articulate and discuss the latest development in the field of electrical engineering, recognize ethical and professional responsibility of engineering practice, and recognize of the need for additional knowledge and grades in lifelong learning. Kaya mahigpit si CHED dyan, si CHED, si PRC, baka later on yung 1 point per hour, bumaba na yon. Kung ay tuturo nyo lang, what is resistor? So pag ganun nakababa, wala na. Kaya ang civil nagagalit sa kanilang CPD kasi meron silang 3 araw na conference, equivalent lang sa 6 points. Kasi daw, yun daw mga tinuturo nile-lecture ay naituro na raw sa college. So, maaaring mangyari sa atin to dahil medyo ini-improve na natin yung Unlike before na, sige lang, no, umatin ka lang, ito lecture, 1 point. So, kaya ngayon ang field trip sa ANC, kasi ang field trip is equivalent to 1 point lang. So, walang pupunta. Ang ginawa namin, seminar in the plant. So, pumunta ka sa plant para mag-seminar. O, di binigyan siya ng 6 point. So, strategy. Pero dapat may learnings dun sa planta. Mas maganda yun kasi pakikita niyo mga equipment. Baka ipatest pa sa inyo. Di ba? Exposure. O, bagong outcomes yun. Bagong learnings. Kaya lang siyempre, medyo gagastos nga. Kasi ang pag-aaral naman ganun eh. Napakaswerte nga lang ng mga bata ngayon dahil libre sila. So, ganun din sa Bachelor of Engineering Technology, pareho rin tayo ng skill. Okay? Kaya lang level 5 kayo. Pero ito ngayon yung specialization natin. Sino yung RMEs natin dyan or technologies? Dapat kayo ay nasa operation management, technical service and maintenance, production, routine design, test and evaluation, manufacturing. Nandun din kayo sa consulting, okay? Distribution and sales, and other technical training in electrical system. Kaya lang, may provision of number 10. Yan, related professional career occupation. Kung wala dyan, pero relevant in electrical engineering practice, then mas maganda. Kaya nga, pag nag-apply tayo ng MUAPO, yung Most Outstanding Association of Professional Engineering, Professional Organization, tinitingnan niya lahat. Kaya ang sinasuggest namin kung gagawa kayo ng activity, dapat talagang relevant to electrical practice. Huwag kayong magtutuli. Kasi hindi natin yun. Huwag lang kukuryentehin nyo sila. So, hindi tayo pwede doon. Yung bloodletting, okay lang yon kasi mas maraming matutulungan doon. Pero pag pinenta yan, medyo less ng konti. Dapat electrical practice para maging most outstanding ulit tayo. By the way, nagbabago na yung qualification or other criteria. Kailangan may tali tayo. Ibig sabihin, hindi lang picture. Halimbawa, bigay liwanag, pinigyan ng ilaw, pero hindi naman kinabit yung ilaw. Dapat ikakabit nyo kasi nagbigay kayong liwanag, hindi nyo naman kinabit. Props lang. Dapat actual. Talagang ikakabit nyo. O baka naman kinabit nyo, kinabukasan, inalis. O may kwento kanina, may gagawing MOA, magbibigay ng solar lamp. Sabi ng isang Board of Governors, baka naman yung solar lamp mo is good for 3 days lang. Dapat naman yung mahabang buhay nung inyong i-donate ng mga lamp. Okay? So, the same din ng ating outcomes. In-emphasize lang that if you're engineering, dapat broaden. Complex. If you're technologies, dapat broaden. Kaya lang ito yung nagiging issue dahil kung ihati natin tong grupo into particular activity, mas matrabaho. Pero on my case, is better na sama-sama na lang ngayon para yung mga ma-encourage to earn their degree more, mag-aaral. Kasi kailan mag-aaral eh. Dahil ang batas sa RA 17 and 20, ang allowed lang mag-exam sa RE ay Bachelors of Electrical Engineering, Bachelor of Science in Electrical Engineering. Kaya yung iba medyo nagtatampo kasi nawala yung S nung ano nila eh. Pero kung mababago yung batas, then maaari din kayo mag-board exam, yung mga Bachelors of Engineering Technology. Okay? So ganun din, walang pinagbago except on the approaches lang. So again, ganun din sila. Level 8 din. Ito ngayon karagdagan. Sa education ngayon, nagkakaroon ng tinatawag na flexible learning. Ito yung may time na pupunta sa school for laboratory work. Pero ang lecture sa LMS, kasi sayang naman yon, inimbest ng school, gumamit ng Zoom, na napagalitan pa nga yung isang eskwelahan sa Senate na ang kanilang budget ay napakalaki, pero virtual naman yung kanilang ano. So pinagalitan sila. Ang laki-laki ng budget nyo, virtual naman pala. So dapat flexible din. Second, ayan, inaalaw na ng CHED magkaroon ng laboratory activities, thesis design, OJT, and others na face-to-face. So ngayon, mukhang open na. Basta kaya ng school na mag-provide ng mga distance, social distancing and protocol requirement. Okay, yan na yung na-mention kanina. Ngayon, ini-encourage na rin kayo if you wish to earn a master's degree and doctorate, meron na po ang test na niyan, ang CHED niyan, pero you have to try to look for a better school. Pero konti lang talaga ang may mga master's degree in engineering. UP, LaSalle, and other school na medyo na-allow na may master's degree. So maganda rin yan, no, for your promotion. So level 7 sila, level 8 ang tawag doon. And ito ngayon, yung bagong inintroduce ng PTC. PTC is Philippine Technological Council. Pinapakita rito yung student to professional life cycle and qualification. Kaya yung A to B, yun yung explain ko kanina, dapat ang school is accredited whether national o international. So kung ang school nyo ay nagpapa-accredit na government sa AACOP, okay yon. Sa private naman, yung PACOCOA tsaka PAASCO, so nag-accredit sila. Pero it's better sana kung ang school natin ay accredited abroad, such as Washington Accord for Engineering, Sydney Accord for Technology, and Dublin Accord for Technicians. So if you pass the educational program, the next level is training and experiences. So dito, ikukulit na natin lahat yung ating training experiences. Number 1, license. Number 2, certification. Number 3, sasali kayo sa mga accrediting institution to provide ASEAN Engineer. Ako po ay ASEAN Engineer in 2016. Pwede kayo mag-APEC. Pwede kayo mag-ACPE. Okay? But again, this is just a recognition for yourself. So, self-application po ito. So, if you want to have your title, in my case, halimbawa ko, Engineer Lyndon Bague, PEE, ASEAN Engineer, APEC, RIP. Oh, yan. So, kasama yun. No? So, yun ang title. Pero maganda yan for interaction with other business clients. Oh, you're an APEC engineer. Okay, we can go abroad and doon tayo mag-business. Yan. Hindi na kayo mahirapan kasi nga recognized kayo. Then, doon sa independent practice naman, if you have your own business, ikaw yung nag-aasikaso ng business mo, is better pa rin dahil you can transact your business abroad. No? Kaya yung nangyayari sa atin sa local, sa Pilipinas, marami mga foreign countries na pupunta rito, ina-accredit natin yung kumpanya nila, ayun, may pumapasok na foreign ngayon. Yun ang contest natin. Kaya dapat tayo din, pag nagpunta abroad, dala-dala natin yan, we can work abroad. Kaya yan ang strategy ng ginagawa sa Middle East. So, PRC has a MOA with Saudi Arabia, kaya yung license nyo ay recognized sa Saudi, o license natin. In other Middle East country, yun, nag-organize tayo ng IAE doon. Although we need to follow what are the rules and laws, kaya medyo limit lang. Pero somehow, pagka Pilipino with the license, Philippine license, and member of IAEE, tinatanggap na rin nila. Lalo na pag meron kayong mga recognition. So I hope with that presentation, by the way, bago kong tapusin, yan yung mga engineering registry. Sa ASEAN Engineer, may 10 country. Sa APEC, may 10 din. Ang natin, yung International Engineering Alliance, merong 19 global countries economies na member. So pagka member tayo dyan, then maganda yung natin. Kayang-kaya nating labanan ng ibang foreigner in terms of our practice. Basta meron kayong recognition. So with that, I think maraming salamat at sakto ko 5 minutes ba.
All right, thank you so much, Engineer Lyndon R. Bage. Now, the floor for questions is now open. Do you have any questions for Sir Bage? How about in the Zoom po? Are there any questions?
Hindi, iniimbitahan ko na lang kayo sa ANC. Please do attend. At this moment, we have 2,900 pa lang yung participants. And meron naman exhibition doon or may exhibit portion. If you cannot attend through face-to-face, you can go there to visit the exhibit. Open siya on Thursday, Friday, and Saturday, November 9, 10, 10, 11. Okay, so I hope to see you in Manila. Especially yung mga mabibigyan ng awards. May mga mabibigyan. Bahala na si Governor magbigay sa inyo ng info. And of course, yung President, incoming President, tsaka yung present President, you can be at Manila free of registration. So kayo po yung libre. Yung iba may mga discounts. Try to look na lang yung ating information para ma-avail nyo po. Thank you.
All right. So at this may we call on the 2022 Zambasulta Chapter VP External for Engineer Lucino Agraviador to award the plaque of appreciation.
Yeah, I would like to read the citation. Electrical engineers of the Philippines of appreciation is hereby presented to Engineer Lyndon R. Bage in grateful recognition of his invaluable contribution to the Institute of Integrated Electrical Engineers of the Philippines, Incorporated, as a technical speaker during the 9th Western Mindanao Regional Conference with the theme, Leadership Rising Above Adversity Through Passion, Commitment, Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur, Martian Garden Hotel, Zamboanga City, given this 8th day of October 2022. Signed, Engineer Mark Anthony U. Sebastian, President, Zambasulta Chapter, and signed by Governor, Western Mindanao Region, Engineer Alexander D.
So again, thank you so much, Engineer Lyndon R. Bage. Yan. So ayan, partner, we are now done with our technical seminars and technical product presentations. Now, to energize our participants, let's have one of the most awaited part of the program, the raffle. The raffles.
But of course, before that, here are some things to remember. Only those who are present on site or in Zoom are eligible to claim their prize.
Once your name is called, please proceed in front of the microphone. Those participants who are in the Zoom, you may raise your hand for you to be acknowledged. So pag hindi po kayo nag-raise your hand, isi-spin po natin again yung wheel. Ayun. So within 10 seconds lang po. Ayan. So let's have our raffles. Okay, so we have two sets of roleta. We have the face-to-face and online. So gagawin po muna natin is face-to-face po muna. So our first prize, we have the umbrella marshals. Ayan, umbrella. Ayan. So perfect sa panahon natin ngayon. Maulan tayo ngayon, kailangan natin ng umbrella. So for us to be able to know kung sino ang mananalo ng isang umbrella, i-roll na natin ang ating roleta. Let's spin the wheel. Yan. Sino kaya ang lucky?
All right, congratulations, Mr. Alvin P. Marmito.
Oh, meron na po kayo. Sir, photo op po muna. Much. Yan, for our second prize, we have notebook. Yan, so perfect ba yung notebook for us to be able to correct our plan. So, di ba nga sabi sa kasabihan, if you plan, he plans to fail.
Congratulations, Lapasiga Rafael.
Lapastique, Rafael. Seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. In the wheel.
Congratulations, Ruben V. Agudera.
Yan, nandito po po si Ruben Tudera. again. Now we will have our roleta for the online participants. I would like to thank Ryder for the sponsorship for our notebooks and RCDC for the sponsorship of our umbrellas. So spin the wheel.
Congratulations, Mr. Abdul Bari Jamar A.
Again, for the online participants, please raise your hand po. Okay. Yeah. Ayan, so okay, present to po. Congratulations again to Abdul Bari Jamar A. Yan, another roleta po for the on-site participants. Again, we would like to thank RCDC for the sponsorship of our umbrellas. Again, so congratulations to Cabanos Eddie Nower J. Are you present? Online? Again, so wala daw po. Let's spin the wheel again. So again, we would like to inform our online participants to please raise your hand for you to be acknowledged. And so congratulations to Calivoso Gerald Jasper N. And please raise your hand for you to be acknowledged. Wala. So let's proceed po muna to the on-site participants.
Congratulations sa Cedor Samuel A.
Back home to you.
For our sponsors, Snyder for our notebooks, and RCP for our umbrellas.
Congratulations, Jomar S. Astilio. Congratulations, Julius John Magtango.
And we would like to thank to our sponsor, Snyder Electric. Yan, andito po ba? Okay, so let's proceed. Let's get in the wheel.
And we would like to thank our sponsors, Snyder Electric and RCB. Now, congratulations, John J. Pril Bugas.
Yan, so congratulations to Maribel Alvarez. Maribel Alvarez. Oh, Alvarez on the line. Still one more time. Yan, so congratulations to Josen A. Calahong. Calling the presence of Josen A. Calahong. Sponsors, Snyder Electric and the RCB.
Congratulations, Abdul Hakam Taji.
Sir Abdul Hakam, are you here? Seven, 5, 4, 3, 2, and 1. Let's spin the wheel one more time.
Congratulations, Richard Don Democrito.
Congratulations po. And we would like to thank our sponsors, Schneider Electric and RC.
Congratulations, Alvin Ayan Atilano.
And so congratulations po. Again, thank you RCBC for the umbrellas.
Once again, we would like to thank our sponsors, Snyder Electric and RCB.
And so congratulations to Michael L. Natel. Michael, are you around? Okay, so Sir Michael is not around. One more time, please. Yan, so congratulations to Alfonsi H. Mahalan. Yan, so wala daw po. Overtime.
Congratulations, Eduardo Del Barrio de la Cruz.
Eduardo, are you with us? 9, 8, 7, 6, 5, 4, and 1. I'd like to thank our sponsors, Schneider Electric and Ice.
Back home to you.
Congratulations, Oscar Biscal. Oscar. Congratulations po.
Again, thank you so much, Schneider Electric and RCB.
Congratulations, Richard Brique.
Engineer Richard M. Brickman, are you around? Eight, 7, 6, 5, 4, 3, and 1. Let's spin the wheel.
Congratulations, Sir Jonathan Dalumbar.
There's Jonathan.
Back home to you.
Of Sir Jonathan Dalumbar. 10, 9, 8, 7, 6, 5, 4, 2, and 1.
Congratulations, Mr. Atiga Jerry Nunez.
Again, congratulations po. Once again, we would like to thank the following sponsors, Schneider Electric and RCBC.
Congratulations, Dodong Emur.
So 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. About that. Yan, so congratulations po to Gilvin Medina. Once again, calling the presence of Gilvin Medina. Yes, presence is here. Congratulations po. And once again, thank you so much to our sponsors, Schneider Electric and RC. Congratulations to Jorlan L. Daguro. Calling the presence of Jorlan L. Daguro. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Sorry.
Congratulations, Andres Linardo V.
Sir Medardo, are you here? Nine, 8, 7, 6, 5, 4, 3, 2, and 1.
Congratulations, Joey Vergara.
The presence of Joey C. Vergara. Sir, are you here? Ten, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Ayan.
And we would like to thank the following sponsors, Schneider Electric and RCBC.
Congratulations to Maybelline Agbaoli. Yan, dito present again. Once again po, congratulations. Won an umbrella and thank you to RCBC for our sponsor.
Congratulations, Aishar Y. Hajirul.
Yan, so congratulations po. Once again, thank you to our sponsor, Schneider Electric. Congratulations to Mapanaw Ryan. Yan, so congratulations po. Once again, thank you to our sponsors, Schneider Electric and the RC.
Congratulations, Gonzalo Grafia.
Back home to you.
Congratulations to Joseph P. Lamoste. Calling the presence of Joseph P. Lamoste. Sir, are you here? Ayan, nandun si Sir.
Congratulations.
Once again, we would like to thank our set of sponsors, Schneider Electric and RCBC.
Congratulations, Rohani Sapayani.
Yan, once again, congratulations. Once again, thank you, Schneider Electric and RCBC.
Once again, we would like to thank the following sponsors: Schneider Electric and RCB.
Congratulations to Di Maano LLC. Yan, congratulations, Tagupa Julius Charles Panun Shalman. Are you here? 10, 9, 8, 7, 6, 5, 4, 2, and 1. Congratulations to Alan Carl F. Bustamante. Alan Carl F. Bustamante.
Congratulations, Almirante Sanson.
Sponsors Schneider Electric and RCBC.
Congratulations, Marlo Kiel Gallo.
Congratulations, Fernando Rodel D. And congratulations of Fernando Rodel D. Sir, are you here? Schneider Electric and RC.
Congratulations, Edwin Pedong. Mr. Edwin. Congratulations. Congratulations, Brian Caesar Albrecht.
Yan, so congratulations to Jose Cordura. Congratulations to JP Glenn P. Columbres. Again, congratulations po. We would like to once again thank our sponsors, Schneider Electric and RCP.
Congratulations, Jerry May Madayag.
Congratulations to Joselito O. Ungab. Our Schneider Electric and RCP. Congratulations to Joseph T. Agkawili. Where are you?
Congratulations, Mark Raymond Enriquez.
Calling the attention of
Congratulations, Aubrey Garcia.
the attention of Miss Aubrey A. Garcia. Are you here with us? Once again, congratulations po.
Congratulations, sir.
We would also like to thank once again our sponsors, Schneider Electric and RCPC. Congratulations po to Joseph P. Makinda. Once again, thank you to our sponsors, Schneider Electric and RC.
Congratulations, Sir Sally Omar E.
They are here with us. And so once again, congratulations. Yan, congratulations to Baltazar Crisanto Pableo. Congratulations po. Once again, we would like to thank our sponsors, Schneider Electric and RCBC.
Congratulations, Sir Gary G. Palacao.
The attention of Gary G. Palacao. Are you with us? 10, 9, 8, 7, 6, CR.
Congratulations, Aguas Reynante D. Congratulations, sir.
Again, we would like to thank our sponsors, RCBC and Schneider.
Congratulations, Bartolome Carlo B. Sir Carlo.
Are you with us? Congratulations to Ben Nasser B. Isnain. Congratulations to Ben Nasser B. Isnain.
Congratulations, Angkahas Mark.
Ayan, once again, congratulations, Anthony Mark B. Anka. And once again, we would like to thank our sponsor, Electric First.
Congratulations, Makaon Eldred Elmer Gonzaga.
Ayan, congratulations to Jonathan B. Vesta. And we would like to thank these following sponsors: Schneider Electric, RCBC, National Commercial, and Player Tech.
Congratulations, Kenny Erwin B. Gumapak.
Calling the attention of Sir Kenny Erwin B. Gumapak. Are you with us?
Congratulations, Romen S. Magalang.
Attention of Romen S. Magala. again, we would like to thank the following sponsors: ClearTech, National Commercial, RTB, Schneider Electric.
Congratulations, Joel E. Mabilog.
Congratulations, Lupet.
Congratulations, Hernando Roy Grayson. Again, congratulations, Hernando Roy Grayson.
Congratulations to Anthony Gerald E. Fernandez. So to proceed with we are going to have our last raffle.
Congratulations, Adrian Angelo S. Pai.
Congratulations po. Ayan, so congratulations. Once again, congratulations to our set of winners. Huwag kayong mag-alala, minor prizes pa lang yon. Later on, we have our major prizes, so stay tuned everyone. So for now, we would like to award and give recognition to our winners on our recently held skills competition to be led by our Zamba Sulta President, Engineer Mark Anthony U. Sebastian, and Zamba Sulta VP Technical, Engineer Marjorie C. Ibanez. A big round of applause, please.
Hello. Good afternoon, everyone. Let me take this moment to award the winners of our skills competition held last October 6, 2022 at College of Engineering Set 116 and Set 117 for building wiring installation. So, as I call your name, may I request those who participated in the skills competition to come up here in front and receive your certificate of participation and at the same time your cash gift. Okay? For the third runner-up for building wiring installation, we have Alba Andong Jr. For the second runner-up, we have Sir Paul Ondong. Sir Paul Undong is here. Okay, for our first runner-up, we have Adrian Angelo Bai. We have also one participant, Sir Joshua R. Eroila. Okay, he is going to receive a certificate of participation. Joshua. For industrial motor control skills competition, we have third runner-up, Sir Joventino Ligaria. Okay, since Sir Ligaria is not around, pardon, we have the third runner-up, Sir Vincent Deo Gos. And for our first runner-up, we have Sir Joel Amilanan. Second runner-up natin, pardon, sir. Okay, for our second runner-up, Sir Joventino Ligaria. Congratulations, sir. I would like also to call the students who help us in facilitating the skills competition. They were going also to receive certificates. May I call Michael D. Alvarez, Axel Ross Elureg, Ernie Bergonia, Erwin Chan Maestre, Giselle Kate Garcia, and Robin May Casemiro. They are the two.
And also, I would like to give certificate of appreciation to the student assistants who helped us from the day one up to this event, where they help us in all the work in this particular. May I call all the students? Alisa Lacaste Santos, Gabriel Principal Gomez, Kate Garcia, Erwin Chan Maestre, Kenny Francis Losabia, Debbie May Borgonia, Rian Jane Ebol, Axel Ross El Jurek, Michael Alvarez, Michelle Alvarez, Khalid Siraji, Ryan D. Abella, Aldre Mendoza, AGM Repollo, Francis Xavier Bukoy, Robbie May Casinillo, PJ Perez, one of them, Nico Sevilla, Elisha May Jose, Kenneth Ken Coyos, Franz Derek Francisco, Luis Angelo Ebol, and Maria Luisa Relampagos. These students are the one who help us in making in all the work in this particular event, the 9th WMS. Workforce is not enough. Thank you very much.
Now we will proceed to the awarding of the plaques of appreciation. We would like to call on the presence of Engineer Brian Lloyd C. Paliega. Let me read the citation. Institute of Integrated Electrical Engineers of the Philippines Incorporated, plaque of appreciation is hereby presented to Engineer Brian Lloyd C. Paliega in grateful recognition of his valuable contribution to the Institute of Integrated Electrical Engineers of the Philippines Incorporated as technical speaker during the 9th Western Mindanao Regional Conference with the theme Leadership, Rising Above Adversity, Through Passion and Commitment, Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur, Martian Garden Hotel, Zamboanga City, given this 8th day of October 2022. Signed by the President of the Zamba Sulta Chapter, Engineer Mark Anthony U. Sebastian, and Governor of the Western Mindanao, Engineer Alexander D. Co.
Now, may we call on a representative from the La Huerta Nalapaz Adventure Park for the awarding of plaque. Let me read the citation. The Institute of Integrated Electrical Engineers of the Philippines Incorporated plaque of appreciation is hereby presented to La Huerta Nalapaz Adventure Park in grateful recognition of their invaluable contribution to the Institute of Integrated Electrical Engineers of the Philippines Incorporated as major sponsor during the 9th Western Mindanao Regional Conference with the theme Leadership, Rising Above Adversity Through Passion and Commitment, Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur, Martian Garden Hotel, Zamboanga City, given this 8th day of October 2022. Signed by the President of Zamba Sulta Chapter, Engineer Mark Anthony U. Sebastian, and the Governor of Western Mindanao Region, Engineer Alexander D. Co. Once again, congratulations.
Another plaque of appreciation. Institute of Integrated Electrical Engineers of the Philippines Incorporated, plaque of appreciation is hereby presented to Meralco Industrial Engineering Services Corporation. Grateful recognition of their invaluable contribution to the Institute of Integrated Electrical Engineers of the Philippines Incorporated as sponsored technical presenter during the 9th Western Mindanao Regional Conference with the theme Leadership, Rising Above Adversity Through Passion and Commitment, Leading on the Road to Recovery, held on October 6 to 8, 2022 at Palacio del Sur, Martian Garden Hotel, Zamboanga City, given this 8th day of October 2022, signed by President of Zamba Sulta Chapter, Engineer Mark Anthony U. Sebastian, and our Western Mindanao Governor, Engineer Alexander D. Co. Once again, congratulations. Okay, so let's continue our MITRE prizes. Raffle, please. So we are going to have our raffle on site. In the meantime, we would like to thank the following sponsors: Player Tech, National Commercial, RCBC, and Schneider Electric. Congratulations to Leonil Monteron. Of Leonil Monteron.
Congratulations, Roland Magante. Sir Roland Magante.
Yan, so wala daw po. Spin the wheel once again. And we would like to thank the following sponsors: Player Tech, National Commercial, RCBC, and Schneider Electric.
Congratulations, May A. Flores.
Of Miss May A. Flores, are you with us? And
Congratulations,
once
ma'am.
again, congratulations po.
Congratulations, Joseph E. Mariano. Congratulations, sir.
Yan, once again, congratulations to Joseph E. Mariano. We would like to thank our sponsors: Schneider Electric, RCB, National Commercial, and
Congratulations, Ferdinand L. Daracan.
and requesting the presence of Ferdinand L. Doracan.
Would like to thank Schneider Electric, RCBC, National Commercial, and Player Tech.
John Michael Dan. Yan. Yan, sir. Congratulations po. Congratulations to Domingo E. Lusaya. Let's keep the presence of Domingo E. Lusaya.
Congratulations, Mark Anthony R. Villaflores.
And once again, congratulations to Mark Anthony R. Villaflores.
Congratulations.
Once again, we would like to thank the following sponsors: Clear Tech, National Commercial, RCBC, and Schneider Electric. Congratulations to Suela David Lincopines. Sir David, are you with us? Yeah,
Congratulations, sir.
Okay, so we are going to have our last minor prize. Yan, brace yourselves, everyone. Congratulations to Dan Vincent S. Fuertes. Yan, calling the presence of Dan Vincent S. Fuertes. One more spin. Congratulations to Roculo Francisco Jr. Requesting the presence of Engineer
Congratulations, Jonelle F. Toribio.
requesting the presence of Jonelle F. Toribio. And congratulations. And once again, thank you so much for our sponsors, ClearTech, National Commercial, RCBC, and Schneider Electric. Once again, congratulations to our set of winners. Don't worry, guys. We still have a lot at stake for our major prizes. And again, congratulations to our winners.
At last, we are almost done with all of our agendas. And now we are down to our closing ceremonies. It is sad to say goodbye, but of course, this does not end here. Bunch of activities are yet to come.
Indeed, partner, but we cannot just end without expressing our heartfelt appreciation to the people behind the success of this event. So, may we invite once again on stage our ever dynamic Western Mindanao Regional Governor, Engineer Alexander Dico, to give the recognition of the people behind the success of the 9th IIEE Western Mindanao Regional Conference. Sir, the floor is yours.
Yes, a pleasant evening to each and everyone. First of all, I would like to request all the Samba Sultan chapter officers. Is it already here? Yan, okay. So, may I request everyone to please stand up to be recognized. And to the head of the Samba Sultan chapter, President Mark Sebastian. Okay. I know hosting of this kind of conference is very much challenging, no? Particularly in the preparation time. Press Mark, we thank you for your commitment, no? For bringing our team to this success of this conference. To the officers who are here, no? Marami pong talagang salamat. Without you, hindi po ito happen. To our former regional governors present today, Engineer Alvin P. Miguel, former Governor Engineer Victor Polisardo. Thank you so much for giving us the wisdom and guidance as we prepared this conference. Malaking bagay po yung guidance nyo na ibinibigay sa amin. To the sponsors, to the exhibitors, lalo na po sa inyo, maraming salamat po. To all the delegates, no, far away from Zamboanga del Sur, Zamboanga Tibubay, Misamis Occidental, and Zamboanga del Norte. Thank you so much po. Alam ko, hindi lang po ang preparation na ito ay para sa maging isang tao lamang, kundi sa group success. So with that, we thank you for this successful event na nagawa na natin. Thank you po.
Thank you very much, Engineer Alexander Dico, and to the people who made this event possible. I am deeply honored to be invited here and share such a wonderful experience with you all.
True, partner. I am also very grateful to be here. But wait, partner, hindi pa tayo tapos. We still have another guest speaker who will be introduced to us by our 2022 Zamba Sulta VP External, Engineer Lucino J. Agraviador. Sir, please do the honors.
Ladies and gentlemen, good evening. I'm honored to introduce to you our guest speaker for this event. Our guest speaker is an elected public servant. His profile and credentials in public service express agreed that working for the common good includes a full recognition that every citizen's voice is worth being listened to. As an elected public servant, he served in the city of Zamboanga as a member of Sangguniang Barangay in Barangay Ayala in 2018 to 2019. a member of Sangguniang Panglusod, City of Zamboanga, from 2019 to 2022, and currently as the representative of the first legislative district of the City of Zamboanga. He sits as a vice chairman in 3 very important public service committees, such as the Overseas Workers Affairs, Poverty Alienation, and People's Participation. In addition, he also sits as a member of the 15 more committees, such as the Committee on Civil Service and Professional Regulation, Labor and Employment, National Defense and Security, to mention a few. His participation in various noble cause responsibility in the government shows his commitment and willingness to put public interest first. And adding to his laudable and admirable credentials as an elected public servant, our guest is also a master mariner and has served in a few shipping lines as a chief officer. His 2 degrees in the field of marine profession, like the Bachelor's of Science in Marine Transportation and Bachelor of Science in Marine Engineering, both earned at Zamboanga State College of Marine Science and Technology in 2002 and 2018, respectively, paved the way for this position as Chief Officer in shipping companies. Ladies and gentlemen, with much pride and honor, please welcome our guest speaker, the Honorable Kimer Adan T. Olazo, Representative, 1st Legislative District of Zamboanga City.
Thank you so much for that very wonderful introductory, sir. Good evening. Please have your seat. Well, thank you so much for inviting me here. I'm very sorry I came in so late. Being a public servant, I have to be with my constituent most of the time. But then, sabi ko, pag uwi pa ako, magpapalit pa ako at magbibihis ako, hindi na ako makakarating. Baka pagdating ko, umuwi na po kayong lahat. So sabi ko, never mind. The important thing is I'm here. I'm here with you tonight and I have to deliver some speech to each and every one of you. First of all, I would like to greet a pleasant evening to the 22 Board of Governors of the National Board of Governors, National F. Padua III. Good evening, sir. VP Internal Affairs, Lyndon Arbage. Am I correct? Sir, good evening. To VP External Affairs, Alberto Herrera Jr., good evening. VP Technical Affairs, Ramon Gatchalian Jr. Buenas noches, welcome to Zamboanga City. And the National Secretary Esperanza Collado, I'm sorry. The National Treasurer Catalino Rana. Good evening. To the National Auditor Florigo Varona. Hi, good evening. Immediate former President Alan Anthony P. Alvarez. Wala dito. Okay. To the Regional Governors, Northern Luzon, Francisco Fontanilla III. Good evening. Central Luzon, Woody Herama. Good evening, sir. Metro Manila, Orville John Borrega. Good evening. Southern Luzon, Erjan L. Ray. Good evening, sir. Ang babata ng mga engineer, mga pogi pa. From Bicol Region, from Bicol, Alexis Olila. Good evening, sir. Western Visayas, Neil De Guzman. Good evening. Eastern Central Visayas, Brian Pasilan. Good evening. Northern Mindanao, Sandro Villarosa. Southern Mindanao, Edgar Ibuen. And of course, to Western Mindanao, Sir Alexander Ko. Good evening, sir. Foreign, what's this? Ano yan? Foreign chapter, Jerin Talam. Am I correct? Jerin Talam, right? Buenas noches, good evening. Thank you for inviting me here. And of course, to your team leadership. Thank you for those kind words, for the very nice introductory words, sir. Buenas noches. I take the pride in being your guest speaker in this 9th Regional Conference of the International Institute of Electrical Engineers of the Philippines Incorporated Western Mindanao Region. Grounded on the theme leadership, rising above the adversity to the passion and commitment on the road to recovery. This event is a veritable source of inspirations as we move as one in helping our country rise above the gamut, the challenges that we're facing, sluggish economy, the lurking vestiges of the pandemic. Napakahirap po. Sa totoo lang sa ngayon, even ourselves in our business, we really struggle a lot. Of course, our business is connected to shipping lines. Kaya sabi ko nga kay engineer ko, and of course kay Toy, sabi ko, baka pwede magbigay sa amin ng mga electrical engineers. We badly needed that on board our vessel. Not only locally, but including on international vessels. But with the present situation, due to Marina Convention that we need to comply with this International Maritime Organization regulations, yung MLC compliance po, marami pong mga hinihingi na dapat gawin yung mga sumasampangay ng barko. That badly affects not only the managerial level course, yung mga kapitan, chief officers, chief engineers, and second engineers, that including the electrical officers on board vessel. Because on board international vessels, we also have electrical officers. And those electrical officers, there are licensed electrical engineers na katulad nyo rin po. And of course, they're having a very good pay on board vessel. As far as I remember, on 2018, my last vessel, yung electrical engineers namin, they're getting about $7,000 a month. Yun po ang sahod nila. Napakadali lang ng trabaho ng electrical engineer sa amin. Nagpapalit lang ng bumbilya. Bakit po? Normally, sa barko namin, everything is in order. Tumatakbo yung barko as per classification society. Lahat nasa ayos po yan. Minsan lang kung nagkaka-trouble talaga, then ang sakit ng ulo ni. Kung tatawagin namin si electrical officer is leki or ileki. Minsan masakit ang ulo mo, especially pag may troubleshooting tayo sa pneumatics. Because as an electrical engineer, your problem is not only electrical problem, but including pneumatics. Dapat marunong din tayo. Kaya yun ang mga ibang electrical officers na Pilipino, they don't have those experience. That is why our principal, which is a so-called American Eagle tankers, ang mga hinahire nila yung mga Indiano. Because those Indians, they were trained to do the job of pneumatics. Kaya sabi ko, kailangan mag-improve pa tayo doon. That is what I'm asking as a committee member of education. Sabi ko, dapat i-impart natin yan. Not only during college days already. Dapat dito pa lang sa baba, nag-aaral pa lang tayo in preparatory for our next course in college. Dapat kumuha na tayo ng mga sariling training para hindi na po mahirapan yung ating mga estudyante if ever they graduate and be in their position. But for every undertaking that you get yourselves involved in, always look beyond what you are tasked to do. It is only through this that you will realize the true purpose of going through it. As you lead your electrical engineers through the labyrinth of life, be advised on what must be the proper course of things. Alam ko po, napakahirap maging electrical engineers. I was also an engineering student before. I took up my civil engineering class at Western Mindanao State University. That was way back 1995. Nung nag-aaral pa po ako. But then my first choice was nautical. Gusto ko talaga maging kapitan ng barko. Just like my father. Because my father is also OFW, is also a ship captain. Sabi ko, itutuloy ko bang pagka-civil engineering ko? Or magkakapitan ako ng barko? My mother wants me to become an engineer. But my heart says no. You have to become a captain. Kaya lumipat po ako. Naging nautical student ako. Then, yun. I graduated in 1999 and immediately boarded the vessel until I become third officer in 2005. Then simultaneously, umakyat yung rango ko hanggang naging kapitan ako. So nobody was expecting na magiging kapitan po ako. Alam niyo po kung bakit? Based on my background sa scholastic, I was even na-kick out sa school ko. Na-kick out po ako and that is very bad on my part, being a kick out student dahil parang wala ka ng future eh. Ang tingin sa'yo dehado ka na. But then, it did not stop me from moving up. Sabi ko, may pag-asa po tayo. The real truth is, I even learned mathematics very late. I learned mathematics during third year high school na po ako when I started learning trigonometry and algebra. Ang tumuro po sa akin ay aking mabuting ina because my mom, she's really good in mathematics. So siya pong tumuro sa akin. And with the help of my friends, engineer friends, na tumuro sa akin, I was able to learn very quick. And hindi ko akalain, ito palang mathematics, pagdating natin sa barko, gagamitin pa rin pala natin. Most especially on my part, being a captain, I'm really using trigonometry in calculating distance. So, thankful ko po sa aking nanay. I was able to learn a lot of things from my mother. Kaya nga sa amin, education normally started at home. So, ang problema lang, medyo magulo ako sa school dati. But then, it did not stop me from pursuing my dreams and career until I become a successful captain, just like my father. Hindi lang yun, who thought that yung bata dati na kick out sa isang school na makakatapos ng pangalawang kurso, which is I graduated in 2018 with my second course, which is a Bachelor of Science in Marine Engineering. So engineering pa rin ang binagsakan ko. But then I'm so thankful that I was able to do that. And not only that, ito ngayon na I began serving our city. I become the representative of First District of Zamboanga City. Well, my political career started in 2018 when I ran for Barangay Kagawad at our barangay at Barangay Ayala. All I thought, 6 months lang ako magkakagawad, sasakay na ako ulit ng barko. My very good friend here, he knows that. So, when I ran for Barangay Kagawad, nanalo ako as number 3 Kagawad, and I'm so lucky that the former mayor, Celso Lobregat, saw me, kinuha niya ako and he asked me to run for city councilor in 2019. So I ran for city councilor, sabi ng kapatid ko, Kuya, huwag ka nang tumakbo. Sabi ko, bakit? Hindi ka mananalo. Sabi ko, bakit ako? Tignan mo yung makalaban mo, lahat yan mga incumbent councilors, tapos ikaw ang isa lang yung vacant slot. Tapos may mga returning councilors pa. Wala kang, hindi ka manalo, sabi niya. Sayangin mo lang yung time mo. Sabi ko, di bale na, politics is not my bread and butter. Sabi ko, pag natalo ako, sasakay ako ng barko. Pag nanalo ako, I'm going to serve my constituent. So I ran for city councilor in 2019 and I won as the number 3 city councilor in District 1. So here comes the very big test for me. Nagkaroon tayo ng COVID-19. Pandemic came. It was really difficult at first. Kasi biruin mo, being a councilor, you have to spend, supposedly yung trabaho namin is just legislation. You have to create a law for the city, gawa ka ng ordinance, that's all, resolutions. But being a councilor, hindi lang yun ang gagawin mo. You should be also a perfect public servant. Tutulungan mo yung mga konstituente mo. In everything they need, bibigyan mo sila. So sabi ko, mahirap pala maging konsehal, ubos-ubos tayo. Sa totoo lang po, my salary was 98,000 pesos a month. Not even a single peso went into my pocket. Every time may salary ako, may sahod, direct from the bank, bigay sa aking secretary dahil yun ang binibigay kong tulong sa mga konstituente namin dito sa Zamboanga City. Not only my salary, that includes my business, my tracking ako. Whatever I'm getting from my tracking monthly, that is almost 400,000, diretso binibigay sa konstituente. Minsan, wala na ako pambayad ng krudo. Naubusan talaga ako. Lumapit ako sa asawa ko. Bigyan mo muna ako ng 20,000 dyan. Sabi niya, bakit? Hindi nga po pasok yung pera mo sa akin para panay charity. Sabi ko, walang pang krudo yung truck. Sabi niya, yung truck mo, takbo ng takbo lang. Hindi tatagal, masisira na yan, wala ka na pambayad sa repair ng truck mo. Ito to nangyari nga. Nawalan ako ng krudo, but my wife is so good. She's very supportive wife. I asked for 20, she gave me 100. So, we're able to help back our constituent. So, here comes 2022 elections. Just last May, supposedly tatakbo ako ulit as councilor, not for Congress. I'm not interested in Congress. Ayaw ko maging congressman, nor even to go higher position. Sabi ko, okay ng councilor, masaya na ako dito. But then, the people really wants me to run. Ask me, okay, tumakbo ka for higher position, which I ran for Congress na nga. And I filed my COC last October to run for first congressional district as congressman in District 1. Pinagtatawanan ako ng mga taong dito sa District 1 and District 2. Sabi nila, si Kimer Olaso parang umakyat sa 10 stories building na walang hagdanan. Bakit? Kasi yung kalaban ko po is a veteran politician, a very well-known politician. Everything is with them already. But sabi ko, walang imposible kay Lord. Whenever you ask from our Almighty God, binibigay po sa atin. Sabi ko kay Lord, very simple lang, when I filed my COC, sabi ko, Lord, if this is really meant for me, give this to me. Pag hindi naman to para sa akin, give this to them. Let them serve again to our very beautiful city of Zamboanga City. But then everything changes around, During the campaign, the very hectic campaign, alam niyo po, napakabuti ni Lord. I have a very good result during the last May elections. I won as a congressman in District 1, and I won for 19,000 votes. I got the majority votes in District 1, and for the first time in the history, natalo ang klima ko sa eleksyon kay Kimer Olaso lang po. Although it's really sad on my part to run against my teacher, but then sabi ko, it's about time to change the leaders in Zamboanga City, to have new faces of leaders in Zamboanga City, a leader who understand, a leader who work, a leader who checks the community, and a leader who has the heart to lead our city into its best. Kasi mahirap pag yung leader po natin hindi they cannot unite with each other. Supposedly in 2019, we're going to have a flyover in Zamboanga City, but everything was canceled because yung mga leaders, walang union. Lahat gustong sumikat. On my part, being a new representative of Zamboanga City, whatever is our congressman doing and whatever is our mayor doing right now, I'm supporting and I'm giving them the 100% support because I want to fast track the development in Zamboanga City. Kasi nakita ko po, we are really left behind even to Cagayan de Oro, dehado na kami. Even to Osamis, nagiging dehado na kami. Lumalamang na sa Zamboanga City. Even to Pagadian, I was in Pagadian last month, sabi ko ganito na pala kagandang Pagadian. We were really left behind. Plus the regional offices was transferred to Pagadian. So I really feel bad about it. That is why when I met former President Duterte, I told him, sir, if it is possible, I want the regional office back in Zamboanga City. Because this is where it belongs. Zamboanga City po. But unfortunately, the last president told me that it's just about 1 month for me to stay in Malacanang. Sabi niya, wala na tayong time para baguhin yan. Sabi niya, maybe I can turn over it to the next president. I'm going to tell him about that matter. So I'm hoping that our new president, President Bongbong Marcos, will give an executive order that will ask to return back the regional offices to Zamboanga City. Kasi pag-isipan nyo naman, tulad ng marina ilalagay mo sa Pagadian, may barko ba sa Pagadian? May rahida ba shippers? We don't have any those in Pagadian. Look at the Coast Guard. They were sent to Pagadian. Nasa bundok sila ngayon. Wala sa dagat. Sabi ko, whatever na ando na, doon na yun. But like Marina, Coast Guard, City Health, Department of Health, let it be in Zamboanga City. Because we are already fully established in Zamboanga City. Don't bring it anymore outside from Zamboanga City. So that's the problem, ma'am, sir, kung ang mga leaders natin hindi nagkakatugma ng pag-iisip. Kung personal interest lang ang iniisip, nothing will happen to us. That is why medyo mahaba tong speech na ginawa ng staff ko. So 5 pages but I will read some of the quote here. Nasabi ko sa kanya, you have to write it. Sabi ko, in 1 to 10, there are distinct languages in leadership. Effective leadership communicate differently than do others. If you're a leader and you know this language, it can be very easy to grasp vision, to mobilize teams and to outline strategy. Kasi may mga leaders tayo, sarado yung mata. Sarado yung pag-iisip. Pag inisip nila, ito lang talaga. They're not open to anything. Of course, being a captain, being a leader, when I was still sailing on board vessel, I used to listen advice from my officers. Because a captain, you get chief officer, you get second officer, and third officer, plus your cadets with you. Nakikinig po tayo sa mga advices nila. But the ultimate decision that will come in your hand, ikaw ang magde-decide kung anong gagawin mo sa barko mo, kung saan kang patungo. Are you going to pass that rough weather? Are you going to cross that Bermuda Triangle? That is under your decision as a captain. The same, being a leader, we have to think twice, thrice. We have to think so many times before we decide to do things. That is why being a leader of Zamboanga City, pinag-isipan ko talaga kung dapat ba talaga magkaroon kami ng bagong ospital sa District 1 o hindi. Because we have a lot of hospitals in Zamboanga City. But unfortunately, our hospital that has been occupied by Basulta, Basilan, Sulu, Tawi-Tawi, that includes Zamboanga del Norte, Sibugay, they're occupying our hospital in Zamboanga City. Yung mga tiga Zamboanga, nawawala na po kami ng hospital. At this why sabi ko, magiging congressman ako. The first thing that I want to do is to put an hospital in District 1. So ngayon, I was able to allocate for start 40 million at Sambo Ecoson. We will be having our hospital finally. We can start building that on 2023 of January or February. So that's one thing being a leader. You have to listen. You have to learn things from your staff. Then decide the best thing for you. So meron akong inano dito kanina. The language of leadership is optimistic. Leaders are not naive, but they communicate and they give hope to our constituent. And that is Kimer Olaso, being a leader of Zamboanga City. Muchas gracias y buenas noches con ustedes todos.
Ayun! Thank you, Honorable Kimmer Adan P. Olaso. Now, may we call on our National VP Internal Engineer Lyndon R. Bage and Engineer Alexander D. Co to present the plaque of appreciation. Now, to give us a highlight of the whole session, help me welcome one of the greatest, a legendary, a former Western Mindanao Regional Council WMRC Governor, one of our favorite, Engineer Alvin P. Miguel.
Thank you for that kind introduction. I'll give you a grade of 5. Okay, thank you. First and foremost, allow me to express our sincere thanks with humility to Almighty God for His divine intervention as we culminate officially the 9th Western Mindanao Regional Conference in few minutes from now with great success. Lord God, thank you so much for the love and goodness accorded upon this IIEE family. As we continue to serve humanity with the power of electricity, we always glorify you in this manner. So, would like to reiterate once more with sincere gratitude to our honored guest, the Honorable Congressman of District 1 of Zamboanga City, the Honorable Kimmer Adan Olaso. Sir, magandang gabi po. Our very energetic IIEE leaders, the 2022 IIEE Board of Governors, led by no less than our very dynamic national president in the person of Feliciano Padua III. So joining perhaps online in this closing ceremony, so we would like also to take this opportunity to personally thank the chair of the Board of Electrical Engineering, the Honorable Francis B. Mapili, and the member of the Board of Electrical Engineering, the Honorable Jaime B. Mendoza, and all the immediate former presidents who join us online for this 3-day activity. So, and also to our very own regional governor, the host of the 9th Western Mindanao Regional Regional Conference, Governor Alexander D. Cole, and to all the officers and active officers, energetic officers, the host chapter officer headed by no less than our chapter president, the dynamic engineer, Mark Anthony Sebastian. My colleagues from the Western Mindanao region, the former regional governors of the region, the chapter officers of the region, supporters of IIEE, dearest participants, the electrical engineering students of the Western Mindanao State University, exhibitors and technical speakers, and but not the least, the auxiliaries, the lady auxiliaries, and also the husband and wives of the IIE officers. Likewise, you are also married to IIE. My warmest felicitation and blessed afternoon to all. Before showing our video clips for the presentation to highlight the 9th Western Mindanao Regional Conference and all its activities, in behalf of the men and women of Samba Sultan and the Western Mindanao region, sincerely, thank you very much. Muchísimas gracias. Dagan salamat. Maraming salamat. Magsukol to everybody for your unselfish support to the success of the 9th Western Mindanao Regional Conference. The IRE is deeply indebted to you people. We sincerely cherish and treasure your humble contributions to the great success of the conference. IIEE to me is an institute that is indeed extremely exciting, extremely enjoying, and extremely energizing. In closing, regardless of beliefs and culture that we have, IIEE did bind us together in one mission, in one vision, in one goal, having a one institute. No one can substitute. No one else can substitute. Thank you very much. And now, ladies and gentlemen, for the conference highlights, special mention to our dear electrical engineering students who prepared the documentation and arranged the presentation or the video clips. Thanks to Mr. Andre, Mr. Ryan, and Mr. AJ. So for the conference highlights, with your indulgence, people, let us now view the video clippings presentation. So technical team, let's get it roll. Thank you very much at magandang gabi lahat po. Thank you very much. There you are, ladies and gentlemen. So, again, welcome to the 10th, next year, 10th Western Mindanao Regional Conference. Okay, so see everybody on the 47th Annual National Convention this coming November 10 to 12 in Pasay City, SM Mall of Asia. Tama ba yun, sir? So, okay, God bless everybody and thank you.
So again, we still have one more video.
Western Mindanao, Western Visayas, Regional Governor, in the person of Livio Arbati.
Ayan. Muchas gracias. And there we have it. Thank you very much, Engineer Alvin P. Miguel. Now, to give us a final closing address, let us call in for the last time our our incumbent Western Mindanao Regional Governor, Engineer Alexander D. Co.
By the power vested in me, by the Constitution and by laws of Institute of Integrated Electrical Engineers of the Philippines Incorporated, I hereby declare the D9 Western Mindanao Regional Conference officially closed.
We are going to have our major wrap after.
Yeah, you can be the greatest, you can be the best, you can be the King Kong banging on your chest. You can beat the world, you can beat the war, you can talk to God, go banging on his door. You can throw your hands up, you can beat the clock, you can move a mountain, you can break rocks. You can be a master, don't wait for luck. Dedicate yourself and you go find yourself. Standing in the Hall of Fame, yeah. And the world's gonna know your name, yeah. Cause you burn with the God's flame, yeah. And the world's gonna know your name, yeah. And you'll be on the walls of the Hall of Fame. You can go the distance, you can run the mile, you can walk straight through hell with a smile. You could be the hero, you can get the gold, breaking all the records they thought never could be broke. Yeah, do it for your people, do it for your pride. Are you ever gonna know if you never even try? Do it for your country, do it for your name, cause there's gonna be a day when you're standing in the Hall of Fame, yeah. And the world's gonna know your name, yeah. Cause you burn with the God's flame, yeah. And the world's gonna know your name, yeah. And you'll be on the walls of the Hall of Fame. Be a champion, be a champion, be a champion, be a champion.
Yan, thank you so much. Siyempre, hindi tayo magtatapos ng hindi kayo masaya.
Yes, syempre naman, partner. At this moment, we will again have our raffle. And yes, you heard it right. We are going to have our major raffle.
Mismo partner, a lot of prizes are at stake. Meron tayong emergency lights, meron tayong electric fan, and a flat screen TV.
Ayan, napaka-exciting naman yan, partner. Okay, so magsisimula tayo sa pinakamaliit na prize, which is the emergency lights. Ayan, ready na ba ang lahat? Ayan, let's spin the roulette. Ayan, congratulations to Cecil Jane L. Topia. Requesting the presence of Cecil Jane L. Topia. Five, four, three, two, one. Ayan, sayang naman. Let's spin the wheel again.
Aside from that, we will also have 10 winners of 500 pesos. From Congressman Kimer Olaso.
Ayan, so congratulations, Rhino F. Javier. Calling the president. Ayan, congratulations, Rhino F. Javier. Sino pa kaya ang lucky winner na makakatanggap? Ayan, congratulations to Balad John Rex A. Calling the attention of Balad John Rex A. Countdown po tayo. 5, 4, 3, 2, and 1.
Congratulations, Bernardo W. Luis.
Winning tayo, guys. And congratulations to Joel J. Francisco. And you won 500. The wheel. Congratulations to Micaela Jean R. Gawad. Micaela Jean R. Gawad. Countdown, 5, 4, 1. Tayo na, let's spin the wheel again. So let's congratulations to Sulay A. Tanya the Fourth. Yan. So congratulations, Tanya the Fourth, who are going to Dol. Yes, calling the presence of
Benito R. Frendol.
you are going to receive electric fan. Ayan.
10, 9, 8,
7, 6, 5, 4, 3, 2, and 1. Sayang na ba? Ayan, congratulations to
Bobby M. Piedad.
Ayan. Countdown tayo. 5, 4, 3, 2, and 1.
Congratulations, Jimmy T. Hagonoy. You won electric fan.
And in the wheel. Professor! Yung partner, mukhang mapapansin talaga yung electric part. Ay, ayun, presence.
Congratulations! You won!
RC, BC, and neither elect. Congratulations to Tito Dalina Jr.
You are an emergency light.
And for our last and major prize,
Sino kaya ang
Eh?
makakakuha?
ng flat screen TV. Ayan, congratulations!
Finally, I am EJT Perez,
And I am Louis Angelen Abel,
signing off as your Masters of Ceremony. Muchísimas gracias y buenas noches a todos.
Yeah, you can be the greatest, you can be the best, you can be the King Kong banging on your chest.
You could beat the world, you could beat the war. You could talk to God, go banging on his door.
You can throw your hands up, you can beat the clock. You can move a mountain, you can break rocks.
You could be a master, don't wait for luck. Dedicate yourself and you go find yourself.
Standing in the Hall of Fame,
Yeah,
and the world's gonna know your name.
yeah.
Cause you burn with the burst flame, and the world's gonna know your name. And you'll be on the walls of the Hall of Fame. You can go the distance, you can run the mile, you can walk straight through hell with a smile.
You could be the hero, you could get the gold. Breaking all the records they thought never could be broke.
Yeah, do it for your people, do it for your pride. Are you ever gonna know if you never even try?
Do it for your country, do it for your name.
Cause there's gonna be a day when you're standing in the Hall of Fame, and the world's gonna know your name. Cause you burn with the burst flame, and the world's gonna know your name. And you'll be on the walls of the Hall of Fame.
Be a champion, be a champion, be a champion, be a champion.
Walls of the Hall of Fame. Be students, be teachers, be politicians, be preachers. Yeah. Be believers, be leaders, be astronauts, be champions, be truth seekers. Be students, be teachers, be politicians, be preachers. Yeah. Be believers, be leaders, be astronauts, be champions. Standing